guess what? Triangle, flat, above sea level, on the surface of the Earth.
This sounds like you're religious, George, honestly.
Me religious? No, I'm not religious. I'm just a person that understands the reality for what is presented, and every day is a different day, man.
You've built a system of beliefs for yourself that you can't break free from.
I disagree with you once again. I'm Portuguese, and from that nature, Portuguese knew about the flatness of the world. Even today, we use the Carta Marina for navigation. Nobody uses Google or any Google references of maps for navigation at sea. Maybe on land, you can use Google Maps or whatever application you use on your phone to reach your destination. But when it comes to the sea, they rely on the Carta Marina, which is the maps of the sea, of the oceans, where it's registered even the depth of the oceans in many cases. So the Carta Marina is still used today for navigation, and that is thanks to the Portuguese. Not only that, the armillary sphere, which is known today as the celestial sphere, is part of the Portuguese flag as well. So the Portuguese were using the celestial sphere. They knew how flat it was.
Did they call it a sphere?
Yeah, it's called the armillary sphere. That's what they call. Yes, it requires an equatorial plane of reference. Do you know what that is? An equatorial plane of reference with the center being Polaris.
What about down south?
Do you know what the plane is?
Do you know what a ball is?
Yeah, a ball doesn't have planes though.
Hyperbolic plane.
A what? A ball plan?
Hyperbolic plane.
That's sorry, man.
Well, you hit me up when you've got some proof for flatness.
Proof of flatness. You have many proofs of flatness. I just told you. Every single map, for example, anything that uses a Cartesian system, which is lines of longitude and latitude, that's proof of a flat plane.
No.
Yeah. Not just that, elevation profiles are also proof of a flat plane, which was it's what I was describing before, at least trying to.
How is that?
Elevation above sea level or below sea level.
How is that proof of a flat plane?
Do you know what level means?
It means curved round a ball or flat on a local scale.
Can you give us an example of level being curved? In which language? In which language does level means curve? Because not even in English level means curve.
In what language does sphere mean flat?
Level can mean curved in English.
That's my question. That's my question.
But that's not true, George. Depending on the context being used, level can mean curved in English.
That's not true.
Context matters.
Level
That
means
is
no
true.
parts higher than the other. No. Level means no parts higher than the other on
Yeah.
a plane.
We use that word.
Yeah.
No.
So
no
parts higher than the
That
other
last
is
part-
not
that last part,
curved.
You just threw that in there.
No, I didn't throw anything.
Level
It's
can
on the
have more than
definition
one
of
meaning.
level.
Level can have
Level
more than
means
one
no
meaning.
parts higher. No. Level means no parts higher than the other. And
But
sea
depending
level. And sea level. Do you know what it means? Sea level. Sea level means this is the definition of sea level: to conform to the shape of the Earth.
Right, so that could be a sphere, right?
I'll tell you again.
If Earth's a
To
sphere,
conform, no,
and
I'll
the
tell you
oceans
again.
conform
I'll tell
to
you
it,
again.
that
To
would make level
conform
curve,
to
wouldn't
the
it?
shape of the Earth. Do you know that that's how we produce ice cream even today? You
George,
know, you
George,
put the liquid in a shape, and the liquid conforms to the shape that it's in, just like gases. You know,
George, are you
like a
sure?
puddle,
What?
Are you
like a
sure?
puddle
Are
that.
you
Who makes
sure that?
ice cream like that?
Are you sure that sea level means conforming to the shape of the Earth?
That's what it says in the definition in the
Okay, so
dictionary.
Are
if
you just making up
Last I
Earth's
stuff?
not
checked.
flat,
You really just making
Last
stuff
I
up.
checked. Yes.
if Earth isn't flat,
Yeah.
that would make sea level curve,
Listen,
wouldn't
a
it?
puddle, yeah, or a lake, water conforms to the shape of the Earth.
No, you
So
just
if you
making
had
stuff
to
up.
freeze that water, yeah, and take it out, yeah, giant ice, you would have the shape of the container.
No, you're making stuff up.
You don't understand words.
I don't understand. All right.
I think he understands words. He's just making things up.
Doesn't understand that words have to have meanings for people that have already agreed. Like, you can't just throw it
Yes,
in the
and
bin.
people need to have common sense of understanding the words for what they mean.
You're not
And
getting.
words can have different meanings depending on the context
That's correct.
being used.
They're
Yeah.
under a
So
spell. They can't.
the same word,
Not
even
on the
with the same
dictionary, though.
spelling,
On
it
dictionary
can
and
mean different
definition of
things.
things. No, on the dictionary definition of things, it needs to be precise.
No, the dictionary is
Why we're
not precise.
defining.
The
Why?
dictionary will
Nah,
give you a definition for a word and it will give you the different contexts in which that word can be used, depending on if it's a word,
yes.
noun, is it an adverb? It'll even give you sentences showing how one word can be used differently depending on context. Because context matters, George.
In scientific terms, though, or in mathematical terms, yeah, they mean something else. They mean what they mean. Level doesn't mean curve. A horizontal line is not curved. A curve is not straight, and so on. Because
Yeah,
when it comes to empiricy, if you're trying to replicate something that I'm describing to you, you need to come design or whatever I describe it to you. Yeah, if you write down in words the length of a horizontal line or a radius circle, yeah, in the end we both need to come to the same conclusion. You need to put one object next to the other, look the same, because we are using the same convention. Now, once that we start using different conventions, it's a different story.
Breaking
When
up,
I
George.
say horizontal and you say, well, actually it means this, and you draw a curve, not horizontal. So you are on one mind using a different convention, which is not is
Can you
in
hear me, George?
agreement.
Breaking up. I don't know if you can hear me.
yeah, dude. They don't need common sense. They have authority to tell them everything.
Oh yeah, that's for sure. All of this comes from the education, isn't it?
They can't trust their common sense. They know because when they look out at the world, it goes against everything that they've been taught.
How so?
Like the lack of curvature.
Much clear logical argument
But I see things out
from
there
the
that
both sides.
sorry. I see things out there that tell me there is curvature.
Present it.
When I look out and I see a horizon and not, the land just continuing infinitely onwards into the distance, that tells me there's curvature.
So
The
the
horizon, you
horizon,
say. What's the horizon? What's that?
it's the actual curvature of the Earth, or is it an apparent
Now
location?
let him say. What is it?
It's
You're
the
looking
actual
out at the
curvature.
horizon. What's the horizon?
I'm trying to come on, George. It's the actual curvature of the Earth.
The
It might
horizon
not
is
be
curvature of the
in
Earth.
that exact location, due to the way light works.
No, hold
Roughly there, yeah.
on. That is what's the fallacy? That affirming the consequent. Yeah,
Affirming the consequence. All right.
that's what you're doing. Yeah, affirming
That's what
you reasserting that the horizon is physical, like having a place that you can go to. Things can
I
go
just
below it or above it.
qualified my statement, George. I just told you
You
that
try to
will not
find
be
the horizon as
exactly what it is.
physical. The horizon is not physical. It is
I didn't say it was
is what it is. It's the
Did I say it
limitation
was
of your
physical, George?
the limitation of your view.
But did I
What
say the
if you
horizon's
have?
physical?
That's what you're
Yes, you
saying.
did. You said it's a physical
George,
curve of Earth.
I never
That's
said
what
it's
you
the
said.
physical curve. I said when I see a horizon, it tells me there's curvature there.
Where?
As opposed to seeing
Where do you see a
the
curvature of
land
the
the
horizon?
land underneath my feet extend on forever.
Can
The
you
fact that
post
it
us a
stops
picture?
somewhere lets
Yeah.
me know
Post a
the
picture
Earth
of the
is
horizon curve, please.
So you live on a toilet paper roll, is what you're saying?
Now, I would like to see an image where the
that
horizon looks
that
curved.
is a possibility. Yes, it is a possibility. I live on a toilet paper roll. I've never actually
Can
heard
you
someone say that before. That
demonstrate some
is a possibility.
anyhow? Yeah, on a picture. I would prefer to see it. Yeah, a real picture where the horizon is.
How do
Well,
orbital mechanics work on a
hard to
toilet
hear
paper
you.
roll?
Hold on a second. The
Yeah, but George,
definition
it's
of
still hard to hear you
horizontal.
because you keep
The
breaking up.
definition of horizontal means parallel to the horizon. So it cannot be curved. You're saying that looking at the horizon, you see curvature when horizon is horizontal. What are you talking about?
I don't know if you can hear me, George, but it's too hard to hear you because you keep breaking up.
Damn satellites. Mic check.
Okay, keep
Yeah.
talking.
I'm
George?
having with my satellites.
Oh, man. I think you're just in a bad area or something.
A area.
Yeah, like wherever you at, you got bad reception.
So the GPS is not picking the connection properly.
Yeah.
Sorry, we were. Question for you guys. How many horizontals are there here? Anyone? The better one. What about angles? How many angles are on the sphere? No. I see. Who's hot miking?
I just turned mine on. Hopefully it's not too loud. I'm mowing the yard, and I'll just tell you what observation I've made just recently is what we're dealing with here on this Discord server is what people are holding in their mind to be true. Some people, they can't remove the ball image. That's all they can see, and that's all they can relate to. Some people here actually are paid opposition to just obfuscate and muddy the waters and just say ball, 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 ball. I think the last person that was talking when he said the horizon proves to him that that's where the curve of the earth just goes away. Like it extends and he can't see any farther, so that has to be the curve. But my question is, what about perspective and the vanishing point and understanding that we just don't see forever on the plane that we live on? Obtain other ideas to be able to see what may be true than just clinging to what you think you know.
What do you think, Nate? Does perspective have anything to do with it?
Perspective on its own, no, because perspective wouldn't make things disappear, bottom up, like it wouldn't cut things off, it wouldn't cause something in front to block something that's behind, Perspective alone just doesn't
Explain to
answer
me.
everything.
Explain to me. Actually, can you explain to us in the chat what's the purpose of binoculars, please?
To see things very far away.
So not beyond the curve.
No, not things that are being blocked by something in front of it. Like binoculars
Do
don't
you
give
know
you X-ray vision, unfortunately, George.
the size of the geometry of the Earth that the Earth is? Do you know the size? You don't. Otherwise, you wouldn't be doing.
What do you mean the
it.
size? Circumference.
The size of the sphere. Yeah. How far is the leading edge of the sphere with a radius of 39 miles? Yeah. How far does the Earth needs to be from you? You're
breaking up, George. I can't hear what you're asking.
Hey, let me add this in for George real quick, and then I'm going to go back to mowing. Here's an experiment you can do for yourself. The next time there's really fluffy, beautiful clouds, and you look up and they're above you pretty high, but you look into the distance and the clouds are smashing into the horizon. Pick a highway or a road that you can go in that direction, and by about 14 or 20 miles, you'll reach the point that those clouds appeared to hit the ground, and get out of your car and look around, and it's going to look exactly like it did where you started, because honestly, it's all perspective. Those clouds are not slinging around a curve or smashing into the curvature of the earth. It's just perspective that they're doing that.
Yeah, that's correct. The same thing as an airplane flying over your head. It's not lowering in altitude towards the horizon. It's still at the same altitude above ground. It's just perspective. It appears that it's coming lower to the ground because it's coming towards the horizon part, to the point that you won't be able to see it anymore, even though it's still at the same altitude. Just perspective. Shit shrinks.
Another thought experiment that I've enjoyed doing lately is this. So they tell us with the globe, you can stand on the beach and about 3 to 4 miles away, the ships will disappear bottom up. They'll go over the curve. But if you take your imagination and get into an F-16 flying 10 feet off the ground at, 1,000 miles an hour, imagine in just 3 miles or 4 miles having to maintain 10 feet off the water. It would be an astronomical amount of drop per second, and that's not what happens. If you're in an F-16 pilot going Mach whatever, 10 feet off the water, you can do that indefinitely over the ocean with no need to crank the stick forward.
Oh, you mean like the Blue Arrows? When they fly in formation like 7 jets, and they go in level flights, and no one accounts for curvature or incoming objects because they are flying very low altitude. So it would be easy for I don't know, a tower or something, to come towards them. But no one accounts for those things. There is nothing to account for.
That was excellent. The two of you, George and the other guy, they're excellent points.
Yeah,
doing flight
there's nothing to
10
account
feet off
for.
the water, 10 feet off the ocean.
But listen, but that is
Stupendous.
anyone is
Love
going
it.
to study navigation. Anyone is going to study navigation. If it's a pilot or a skipper or whoever, someone who's learning navigation. The very first thing that they need to learn is that the world needs to be accounted as flat and stationary for these things to to happen.
I
You
wonder
know,
why. I
you
wonder
cannot
why they
you
have to
cannot
do
be
that.
thinking that your destiny, your destination, that's the word, your destination is coming towards you or away from you or going sideways. No, no. The distance between you and the destination is this one. That's it.
I
Flat,
wonder why all that is.
horizontal
I wonder
plane.
why. Why do they have to consider Earth flat and stationary? I wonder why.
Because that's what it is. That's how it's presented.
That's it.
That's reality for
Obviously.
you.
Maybe it
Obviously.
makes life easier. Wouldn't that be a possibility?
No,
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 it's
no.
not
If the Earth is
No,
easier.
moving,
That's how it is.
it's not a
yeah.
possibility at all. That they're just trying to
No, no. If
simplify
Not at all, because
it.
no,
if the Earth is moving and curving, you'd have to consider those factors without a doubt. You could miss the target. The Earth is moving. You could hit somebody else, kill another person in another house, calling it collateral damage. No, that's not good. Sorry, no.
Yeah, but I mean, this is what they would just do in training. You know, when you're out there really flying the thing, you would take these things into consideration. That's not
No,
a
they don't.
possibility.
They don't. We're
No.
talking about in battle, in anger. They do not. In anger, the longest ballistic shot is 4.5 miles, right? And that didn't take into consideration curvature at all. Okay, that's the current world record
How do
for a
you know
sniper.
that? How
It's
do
in.
you
You
know
can
that?
look it up. You can look it up.
Wait,
Look it up.
what do I Google?
Look it up. You
What should I
Google it.
Google? I'm asking.
Longest. Just Google it
Longest?
up. Longest 4.5 mile sniper shot. Okay, there's no
Longest
curvature
sniper
being
shot.
considered. It took 24 seconds from muzzle to target. 24 seconds, ladies and gentlemen. And they
you're
didn't
wasting
take
your time, man.
Coriolis. They didn't take Coriolis or curvature or the
Yeah, but
speed into consideration.
a sniper shot example would be nice for someone who actually done shooting in their lives. Not for someone who never done shooting.
Yeah, I know, but
You
you've
know
got
what
to
I
look at
mean?
the
I
facts as they
understand
are.
your example. I understand your example because I did shooting, obviously, and many of
Yeah,
us here done shooting. Yeah. If you
yeah,
see the
me too.
target, you shoot at the target. You don't point at
Right.
A to hit B.
You did
You know,
you aim at something 2 miles away, George?
2 miles away, it doesn't matter how far away it
No,
is.
no, no, just answer the question. Did you
If
aim at
I'm
something two
aiming,
miles
hold on
away?
a second.
4 mile. 4 mile.
If I'm
Four and a
aiming,
half miles.
hold on a second. If
Yeah,
I'm
but I
aiming
mean,
at
I
the
just try to
target,
make it easy, and I said 2 miles. I wasn't even trying to go that far.
yeah, but if
So it
you're
seems
aiming at one target, you are aiming at that target. Yeah. If the target was on a moving surface, you couldn't aim at that target. You needed to aim ahead of the target in order to hit the target when the target reaches that destination that you are aiming at. It doesn't happen, man. Yeah. So whatever time the bullet takes in the air, it's still gonna hit the target because that's what you're
you've
shooting
never
at
aimed
because
at
you're
something
looking
two
at it.
miles away.
There's the
You've never aimed at
target. You
something two
shoot at
miles away.
it.
You've
You
never
can
tried
see
to.
if you failed, if you hit. The target is not moving.
All right, but you've never shot at something 2 miles away. Interesting.
It doesn't matter. The target is not moving. It's still there. I'm aiming at it, and guess what? It's still in the same place. And the bullet hit
How much
it
does the Earth spin if you
eventually.
shoot
So
4 miles? How much spin do you have to put on that English? Because of the rotation of the Earth? How much? How many
I
feet?
like this. Spin on the English. You play ball, Godric?
Some.
All right. But
Sorry,
yeah,
yeah.
off the top of my head,
With the
I don't
sniper
know. I
target.
don't have
With the
the answer for
sniper
your
target
question.
anyway.
Hang on, wait.
With the
Clarity.
target.
If you don't know this, how can you be a glober? You need to. This is a science. You should know
Because
exactly how much.
I need to calculate it, Godric. Off the top of my head, I don't know what that answer is. I'd have to calculate it for you. Come on,
Now,
man.
admittedly, the sniper would have to make slight adjustments, but that would be after getting the radio message from the spotter 2 miles, 3 miles, or 4 miles away. He might say that your bullet hit left of the target, left of the bullseye, or right. So then you'd adjust your sighting and then make a final adjustments and take another shot. Okay? You have spotters at the other end telling you whether you hit, where you hit on the target, and then you can fine tune that. And that would be due to wind variation as the projectile is heading towards the target. Okay? I mean, you know, we know this stuff, man. The earth is not spinning, it's not curving. Government agency documents, I have 150. I can give you them if you want them. 150 government agency documents stating that the earth is flat and stationary, plane, not moving. Flat earth. Words flat earth are used as well. Do you want them? Would you like them? 150.
Imagine,
Yeah, post
imagine
them.
you're,
Post all of them.
imagine, yeah, you're in the front line with your enemy, yeah, and you are being hit heavily, and you ask for air support, and you give the coordinates of your enemy, but you account for Coriolis. Now imagine that, yeah, you would be in big trouble. The coordinates of the enemy is the coordinates of the enemy. That's it. That's where they need to hit. Cannot account for anything. It didn't account for anything. This is where this is where the enemy is. This is where you need to bomb this area. It don't account for anything. It's like the guy in the submarine. Look, an enemy boat. An enemy boat? How far away is it? 10 miles away. 10 miles away? No. What we see is a mirage, so that's not the enemy boat. It's pointless to send a torpedo because it's not going to hit anything.
Now, worse than that, if you did have a spinning Earth, you'd have a different Coriolis going south, east as you would north south. So this makes it even more confusing. A sniper would never survive in a war because he would have to recalculate every time he changed his direction, wouldn't he?
Yeah, but not just a sniper or coordinates in that sense. Any sport would have to have a stadium built in the same orientation. Imagine a football game, you know, where the spin of the earth would affect the game, or the throw of the javelin, or the high jump, or any sport, you know, a marathon run from east to west versus west to east would have a big influence, you know, or I don't know, the cross Atlantic in a regatta, you know, would be taken in consideration, not just the curvature, but the spinning of the earth too. It doesn't exist.
It's no impossible.
How would a football, being thrown 10 yards need to account for Coriolis?
That's a Neil deGrasse Tyson claim, isn't it? That
I
the
don't
goal
know,
was
but
driven of
you
the
guys,
spinning of the earth.
like worship and listen to Neil deGrasse Tyson more than I do. I don't know what he says, but I don't
Well,
rely
it's
on
one of your priests. You're not listening to your priest.
He's not one of our priests, and I don't listen to him. It's like me saying QE is one of your guys' priests, and you should agree with everything QE says. That's just
I agree with
ridiculous.
everything that he says, but you know, it's not agree or disagree. It's about evidence.
Yeah, but then why does it apply to me and not to you? I got to agree with my priest, and you don't.
Chewie is not that famous. Neil deGrasse Tyson is very famous. So
Yeah, but
Jew,
within
the
flat
culture
Earth
says, right?
circles, Yeah, but God, within flat Earth circles, you would be hard pressed to find a flat Earther that doesn't know who Kiwi is.
Yeah,
Yeah,
but
but
Kiwi just opened our eyes to things that we already knew. Every single one of us, I'm sure, went through the educational system, and we all learned the globe model. We all learned the claims that are on the table. The majority of us did. Maybe not all the
Tyrell,
claims.
remember the football game where Neil deGrasse Tyson said the spin of the Earth made the ball go into the goalpost? Did you
Yeah.
hear that? Do you agree with that?
I've never heard of this claim. I would need to
Oh
see
my
what he's
God,
talking
you can't be serious.
about. I don't watch Neil deGrasse Tyson. I don't listen to him. Like, this guy's never published anything in his life.
Yeah,
Yeah.
I didn't hear about
45.
him once while I was in school. You know?
So in this case, you know that you live on a sphere just because you learned in school.
No, what I'm saying is I don't listen to what Neil deGrasse Tyson says.
So
No.
what evidence
He
do you have that you live on
heard
a sphere?
about Neil deGrasse Tyson. You've heard that claim because we've mentioned it to you before. Before you're lying because we mentioned it to you before a number of years ago, a couple of years back, maybe stating that we'll go over it in a rugby game. Okay, and we discussed this with you. You've heard it before. Now, I know you're lying now, man.
I'll be right back. I'm getting a phone call.
So, you know, and I don't forget the meetings we have. He's putting the wool over your head, guys. He knows about Neil deGrasse Tyson because he follows him. What is gravity? I have no idea. Okay, next question. What is gravity?
That stuff is flat.
That stuff is flat. He's not up looking at the level of the earth from 2 inches off the ball. Come on. That stuff is flat. Yeah, man. We got
Felix
it.
Baumgarten's jump. Well, the camera was a fisheye lens, he said.
Yes.
Because at that altitude, that stuff is flat.
Yes. That's his edge of space shot. And everybody laughs. And why he would jump out of a perfectly normal balloon, who knows? And everyone started cracking up.
And why would
Yeah,
you
man.
jump after hours of climbing? Yeah, why would you still jump to New Mexico? What happened to Coriolis on that day? Day off?
Yeah, exactly. No, he's not. Come on. We're just the champions at this now. At this rate, they're hemorrhaging blood, man. Their ship is sinking. The heliocentric model is drowning in the flat Earth water. That flat water
Yeah, but
that lies across the Earth.
let's face it. Let's face it. They've been eluded. Yeah, the same way we did back in the 50s and 60s and moon landings and stuff. You know, because the things that they've been achieving today with today's technology, yeah, is the same we achieved back in the 50s and 60s and 70s and so on. You know, I'm talking about these flights to the edge of space. You know, these parabolic flights. All of these things that what's the name? The Virgin Galactic and Elon Musk have been doing.
Common
You know,
line.
all of these things they've done it back in the past. We all fell for it, and this youth is falling for the same tricks, exactly the same tricks. It's amazing things that you know, if you
You
manipulate
know what really is
somebody's
amazing,
mind.
ladies and gentlemen? You know what really is amazing is that today's technologies, where we got cutting edge technologies, mind you, can't find the curvature, but a man supposedly 2,300 years ago in a loincloth and some smashed up sandals managed to prove the Earth's curvature to 24,855 miles with some sticks, the sun, and the well. No technology at all, but we can't do that today with today's cutting edge technologies, ladies and gentlemen. We can't. That is amazing. That is amazing.
But we lost the technology.
Yes. We
Well,
certainly
let's
have.
not forget with that another man with similar background from a cave, yeah, he managed to plan the the destruction of these massive
Oh, the
towers.
Osama bin Laden. Yeah, sorry, yeah.
Yeah. So a man
Yeah.
connected to the dialysis machine, yeah, managed to control from his cave, and manipulate the US. I mean, it's amazing. But we still lost the
Yes.
technology to go to
And
the moon.
got NORADs to stand down. Yes, that's right. There you go. He managed to get NORADs to stand down, by the way. That's an feat in itself. Wow. What a man.
The cave
I'd like
power.
to know what Wi-Fi system and that, because that was super. Cave. There you go. Jones came to Britain. So Alex Jones went to Britain, okay, with his loud halo, his microphone, like that, and he says, "Do you think a man in a cave, a fucking man in a cave, can have NORAD stand down, down, down? A man in a cave?" He was shouting out right outside the government building, right outside Parliament, right next door to Winston Churchill's statue, and he was saying, "Wake up, everybody! Do you think an Arab in a cave could have a man stand down NORAD?" And I thought it was classic. Yes. It's absurd. It's an absurdity. The heliocentric
But
model.
anyway,
The more
Alberoni is the one who claimed to have measured the radius. So yeah, great mathematician. Math magician in this case. He managed to convert a
yes,
flat
that's right.
plane into a sphere.
Magician.
Math
Yes.
magician, yeah. Math magician.
Ladies and gentlemen. Okay, I am posting those documents that you asked for. I've given you 40 Act. Double. You need to be as close to God as you possibly can. Bloody hell.
Hey, Jen, I don't know if you can hear us, but you're breaking up. Your connection's real bad. We could hardly hear anything.
I thought it was me.
Yeah, sorry about that, guys. I've got very bad Wi-Fi. It's raining a monsoon here. I apologize.
It's raining, you say. How did the water reach to the clouds, I wonder?
George,
You're not serious, are you? About the whole water getting to the come on, man.
George, I was just asking about you like yesterday.
Yeah, how does the water reach the clouds? I mean,
Come on, man. Come on. This is what is this, like elementary school?
I don't know, man. Just I think it's a fair question with gravity. I mean, but how does it go up?
It's very simple. It's evaporation.
So the gravity then. Oh yeah,
No, it is
I
gravity.
see.
No,
Oh, I
it
see. Okay.
is gravity. It is gravity.
No. With gravity, yeah, you don't have evaporation ever.
No, you can have
No.
evaporation with gravity.
With gravity, yeah, with the force of down, you will never, ever have evaporation. Will never
No.
exist.
Okay, you could
No,
saying it doesn't make it so. You want to
all
make an argument, or do
gases
you
will
want to
be
just
attached to the ground. All gases will be attached to
do
the
you
ground. No.
do you want to make an
You will
argument, or
never
do you
have.
want to just talk past you? Like, you know what I'm saying? Like, you want to actually talk with me, or do you want to talk?
He's talking at you, boy. He's talking at you.
He's talking at me. Yeah. So this isn't really a conversation. Come on.
Yeah, it's for what
Whatever.
you're
No, well,
supposed
you're
to
ignoring
learn.
his facts. Yeah, you're ignoring his point.
No,
You're
and
not listening
I'm
to what he's
trying
telling
to bring up a point for why it works, but If you don't want to hear it, then I mean, okay. Then
Why
what's,
works what?
what's the point of me
Let us
talking? Then
have
I
Why
mean,
let us
works
have
seriously.
what? As to why it goes up, no gravity then.
No, you can have things go up with gravity. I mean,
So
I'll be
down
happy to
then.
explain it to you.
So there is no force of down then. If
I'd
things
be
go
no,
up,
there would be. You want me to explain it to you, or you just
not
want to
would
talk
be. If
at
things
me?
are going up, there is no
Okay,
force
you're
of down
talking
then.
at me, so there's no point, man.
Okay, yeah,
You
go on.
acknowledging
Let him
things
explain
going
it.
up. You are acknowledging things going up, so there is no force of down then.
Look, if I'm telling you that it can, but if you don't want me to tell you, then it's on you.
Evaporation is not going down, my friend.
Okay, man.
What do you mean, okay, man? Are you telling us? Can you please tell us that evaporation is going down? Please tell us in plain English. I want to listen to. I want to record it as well.
Relative to the ground, it isn't. No, but there is.
So
the
it's
force
not going
acting.
down evaporation then. So there is
Look,
no force of
I'm not
gravity
talking
then.
to you, all right? If you're not gonna talk to me,
So there
I'm
is
not,
no force of down then. If it's not
I'm
going
not
down, there is no
talking to
force
you,
of
man.
down.
I'm not talking to you, bro.
I see.
They can't reason with common sense. They
Well, you
have to
didn't
get
tell us
opinion.
No, I
that.
can reason with common sense, but the thing is, you guys don't want to listen to me. So, like, what do you
You
want me to
didn't tell us
do?
evaporates up
Armor, we
and
don't want to hear lies though.
What, man? You have nothing to say.
I don't want to. That's so
There's
stupid,
nothing
though.
to
How?
say. Evaporation, it doesn't go down. There's nothing you can say to contradict that
Yes,
statement.
there is
That's a
actually.
statement of fact.
Well, if you let me talk, I mean, maybe I can show you how. But
Okay,
I mean,
yeah.
Armor,
Let him have his way. Let him have his say. Let him have his say. I
not really,
apologize
Jen.
on behalf of my friends. I apologize on behalf of my learned friends. Can you please explain your position, please? I'm
yeah,
interested.
Why, Jen? Why would you do that, Jen? We already know the lie. We know the motto. We've been through school decades ago. We already know what he's gonna
Yeah,
say right now.
no,
We
you
don't
don't.
need to
yeah,
hear the
yeah.
What the
lie.
fuck am I gonna
Let him
say?
say it. Let him
Yeah,
say it and then teach.
No,
exactly.
what am I gonna
Let
say?
him
No,
say it and
he
then
knows
teach
what I'm
you.
gonna say. What am I
You're
gonna
gonna say
say?
evaporation is
What am I
gonna go
gonna
up.
say?
You're gonna
What am I?
say evaporation is
Am I
gonna
gonna
go up.
say?
You're not
Is it
gonna say
apocryphal?
anything else.
Who's saying that? What am I gonna
It was
say?
me. It was me. It was
Yeah,
me.
what was I gonna say?
You're gonna say a lie. That's what you're gonna say.
That's
But
not.
we're
Get the
trying to
fuck, come on,
stop you
man.
from lying right now. We're trying to
I'm not
prevent
lying
that.
though. It's provable what I'm about to say. You can literally prove it yourself.
No, you can't. You can't
You
prove
you
gravity,
you
bro.
no. I'm not trying to prove gravity. I'm just trying to prove you can have things falling down, and then the thing, thing lighter than it moving
Let
up.
him explain how
It's still
water goes
moving
up
down. It's just
in the
okay.
clouds. Go ahead.
Okay.
Give him 2 minutes.
So I've said this example. I've said this hypothetical plenty of times. You have a pit, and in this pit you have a bunch of balloons. All right, roughly indestructible balloons. All right, but balloons nonetheless. You start dropping bowling balls in that pit. What happens? The bowling balls, which are heavier than the balloons, are going to seek the bottom of that pit, right? And as you fill that pit up with bowling balls, the bowling balls are going to push up the balloons, all right, upwards, all right, because they're less heavy, all right. So as you fill up that pit, all right, even though the balloons are also falling down, right, because you have the heavier bowling balls that are in that pit and occupying the bottom part of that pit, the balloons have to go up. All right, it's the same thing with gases and whatnot, right? You have the heavier gases on the bottom. The light gases literally can't go down because the heavier stuff is down there. It's super simple.
So you're saying. So you're
So
saying
not
that.
everything is falling at 9.8 meters per second, according with your description just now.
I don't know about that. All I know is that things are falling.
What do
It's
you mean
just
you
that
don't
you
know
have
about that? That's the claim of
all I
gravity.
know. Look,
Everything
all I
falls
know
at
is
the
that
same
things
rate.
are. Look, all I know is that everything is falling, but the thing is, the heavier stuff has, they pretty much have first. They have dibs on the bottom.
Oh, okay, Arma. With that logic, can I take a gas net and just swipe it on the floor and pick up nothing but heavy gases? Is that what you're trying to imply? That all the heavy gases are on the floor because all the bowling balls would stay at the bottom of the pit, right? They're never going to go up
Mm-hmm.
because they're heavy, right? But only the balloons will go higher in your logic pit because those are lighter than the bowling balls. And guess what?
Mm-hmm.
And that means when you go and dig that pit up, all the heavy bowling balls will be on the bottom. But you know where you're wrong though? Because not all heavy gases are just laying across the city and across the land everywhere. There's not just heavy gases, you kick on the floor and you're only kicking heavy gases. This is where you're wrong, and this is where your logic is in the Baltard, realm, which is what I was trying to prevent you from going to, because I knew you were gonna say some dumb shit that was gonna make no sense in the world that we truly live in, which is logic and reason and understanding. But go ahead, I'll let you try to rebuttal me, real quick. Maybe back out, maybe even recant your statement, because now maybe I pointed out how stupid you sounded by saying all the bowling balls are on the bottom and then all the heavy gases are on the bottom. So go ahead, I'll wait.
Well, okay, the bowling ball obviously.
Hold on a second, guys. Come on. It was addressing as to why vapor goes down, or condensation in this case.
Well, look, listen. All I was saying is that it's not impossible for you to have things falling down, right? But having
Like
to move
vapor,
up because you
yeah?
have a heavier thing occupying the space, right? That's all I was saying. If you have a pit of balloons and you start dropping bowling balls in there, right? The balloons are going to go up, right? They're still falling down, right? They still want to go down.
What about
right?
the vapor and the condensation we were
So
talking about?
that's the main point of that.
As to why the question on the table was about the rain. How did the water got up there in order to be falling now? Yeah.
Well, from my understanding,
the claim of gravity. How did the water got up there?
So from
to
my
do the cloud formation in the first place, condensation.
So
and you were saying about condensation going down or vapor going down. Can you elaborate on that, please?
Yeah, so it's been a while since I've really looked into the whole fucking water cycle or whatnot. But from my understanding, though, the idea is that the water that that pretty much evaporates, whatever, right? Pretty much.
Can you describe that process of evaporation? Which vector would it going to go?
So yes, I mean it's essentially going to be going up, yeah. But
it's going to go up. Okay, so there is no force of down then.
No, but I already told you though. That's why I gave you the freaking balloon example. All right, there's still a force of down, whatever, for the balloons. They're just going up though because the heavier stuff is in the way.
You have the water on the ground, and it's going to go up. You said evaporate.
Yeah, same thing for the balloons. The balloons are going up, all right, but they are trying to fall down. So
there is no force of down then. So when you
but there's force of down in the balloons. But there's force of down in the balloons.
When you say everything falls down, and there's a bias as to why things fall down at 9.8 meters per second. That's not what you're describing. You're describing things going opposite direction.
Okay, same thing for my balloon example. Then are you going to tell me that there is no downwards force in my balloon example? No, the balloons are still wanting to go down.
You just said that the balloon is going up.
Because the heavier stuff below it, like you literally
either goes up or goes down. You cannot have both.
I think you could also try this yourself with just like, I don't know, a container, maybe like a bunch of like heavy like rocks or something, and then maybe like sand or something. If you start shaking that up, the things are going to start settling.
No, we're talking
more properly.
We're talking about condensation.
I know.
Vapor.
Look, I know. I'm bringing up my point. I'm bringing up my point because I'm trying to show that
cloud formation. Yeah. How did the water got there on the top in the first place? If there is a bias force pulling everything down, how did the water reach there, the clouds, in order to be raining in Japan right now?
Stronger than the other forces, making the water
stronger than the other forces.
The bias force that pulls everything down, what we call gravity, in this situation might not be stronger than the forces making this water go up in the air, depending on the state of matter the water's in.
I almost agree with you, man. But only one thing bad on that statement. We used to think like that. Yeah. We passed on since 1915. We passed that notion that there is a force of gravity. I could agree with you if we still had the old point of view, but it's not that view that we hold anymore.
Yeah, I mean, both points of views are still valid. One is just more accurate than the other. But if you want me to, if you want me to do it using relativity, I could.
No, they moved on from the heliocentric model because
the sun is not in the center anymore. The explanation using relativity or what?
Explanation of what? As to why the world is flat. You're going to prove your ball.
As to why the water molecules, when in the gaseous state, go up into the air as opposed to falling.
It goes up into the air, so no vector of down then.
Yeah, Chirality might know this more than I do, because I mean I just know every
I think we are in agreement, though, because you guys are all saying that it goes up. We all agree with that. I don't think anyone here we're going to disagree with
But
that.
the same thing for the
But
balloons in my
that's
hypothetical,
not,
at
though.
the same tone, at the same tone that you are saying that it's going up, you want somehow to insert a vector of down when after you said it going up.
Yeah, same thing for my balloons.
The vector of down is still present because these molecules are made of mass, and they do. I mean, they have mass in them, and mass is affected. Or,
Sorry, can you say
mass
it
seems
again,
to have
please?
this interplay with what we call gravity.
Sorry,
whether you want to see gravity as a force or not, maybe you want to see it as geometry. It doesn't matter. Mass has a connection with this. As long as these things are made of mass, gravity is present.
What's mass?
Oh, you know what?
You really want to go down that road?
Go down that road, George.
What's mass?
Mass is a type of energy.
You don't know what mass is. Nobody knows what mass is.
I just answered you.
Let's cut short. Nobody knows what mass is. Don't invoke mass, please. Even if you find mass, even if you would find mass, he's still not going to prove. He's still not going to prove that vapor is going down, or gases are going down, and your sphere even less.
Yeah, chirality was answering your question, and you spoke all over.
He does that a lot, George. George is like that. I don't know why, but
well, let's just go one at a time. Nate, you did kind of pause, so I don't. You did sounded like you were just Was there more, Nate? To what you were going to say?
I answered the question and I stopped, but George didn't care for my answer. He just started saying, "Let's cut to the chase." No one knows the answer. No one knows the answer.
So do you know the answer?
The answer to what mass is from chirality, if I heard correctly, is it's just energy, which is extremely non-specific and non-explanatory.
It's a type of energy. I would have said more.
Is that the definition of mass?
I'm not trying to.
Is that the definition of mass?
Say more, actually, but
what is the definition of mass?
George did kind of run you over.
It is a type of energy, mass. Yes. There are many definitions for what mass is.
What's energy?
Couldn't I say that for everything, though? I could literally say, if you asked me any single object, I could say it's a type of energy. So that's a kind of non-specific answer.
I hear you. It wasn't specific at all. And as I said, I would have added.
Yeah, I wasn't asking what you think it is. I was asking for the definition of
chirality explanation for a fucking second, dude. He's tried to fucking give me the explanation 3 times, dude.
He doesn't have one.
Mass is a type of energy. You could call it inertial energy. It basically comes about when certain types of elementary particles interact with a special type of quantum field, and this interaction causes the energy within these particles to
Can you post that, please?
To decelerate.
Can you post
below.
that definition so we can all read it together,
Dude, that's
please?
fucking ridiculous, dude. We've been trying to clear the floor for chirality to give his fucking explanation every single time you interrupt him.
Yeah, George is doing it on purpose.
It's just bullshitting, you guys.
But yeah, let me just
bullshit?
post something.
Post the definition of it, please. Definition of mass, please. It's not your definition of mass. We want the definition of mass.
As I said, George, there's more than one definition for mass.
More than one, so you cannot have more than one. So you have something that is not defined. That is not acceptable in the scientific terms. It's not the scientific. In scientific terms, you have to have definition of things. Things need to be clear. When you talk about mass, you cannot be saying mass is like gravity. Just another band-aid in your model that you cannot present. Not even the model. Yeah, you don't have any of that. What you have is stories. I'm still waiting for this demonstration of vapor or what we were talking about, the condensation going down.
So, Nate, how much of gravity is theoretical and how much is physically tangibly verifiable? Because the way that they claim to measure mass is using a reference weight and then comparing it to that reference weight. So where's the validation of mass in the physical world outside of the theoretical conceptual? When
You mean
measuring
like-
it, when measuring it has to do with comparing it to a reference weight.
Like on a balance scale?
Yeah, that's how they measure mass. Other than calculations, that's the only tangible form, is just to equate it to another known object.
Yeah, but then you would ask, how did they get the mass for that known object?
They don't. They use the weight of it to compare it. It's the weight
Yeah.
that they're using it for.
Yeah.
So that's how they measure it by. So you see how that's an issue?
How's that an issue, Jew?
Well, like if I said, we all love unicorns. So if I said, you know, I have this thing called unicorn mass or whatever, and then I say, oh yeah, there's these calculations and we can do this and that and all this stuff. We can plug it into all these other things. And you say, okay, well, how do you know that this unicorn mass thing exists? And I say, well, I just compare it to another weight on a scale.
Mm-hmm. That weight on a scale is also made of mass or unicorn mass, you know, and you did a calculation to find that original unicorn mass. You basically did the same thing we did. You just decided to call it unicorn mass, which is fine.
Yeah, but where's the tangible validatability? Is that a word? Validatability? Is that a word?
Wait, can I
Validity?
say
Yeah,
something real
what do you
quick? Yeah, okay, so you're just repeating fucking Geo. So I'm gonna say something real quick. So we have putting objects on a scale and getting its weight. That's the tangible, real life thing that actually happens that we all do and can experience. Now, if I were to claim then that what causes the weight on the scale is a magical fucking force called gravity, or let's just use the word magical force called downward accelerating ether, just so you guys know how fucking ridiculous it is, so you guys can put on the ridiculous shoe for once. So we all do this weight on a scale and we find its weight, but then I come in and I say, well, the ether fucking downflux magical force is pushing it down, and actually there's a magical pixie dust inside the object itself that we're going to call mass. We could just call it pixie dust. And so the weight is actually a combination of the downward ethereal magic force and the magic pixie dust interacting together. And you said, oh, well, I understand the weight is real life, but how did you get to your conclusion about the pixie dust? And then I just didn't say anything afterwards. Is basically where we're at right now.
Could you say it again? No? So sorry.
Yeah, so I'm just going to make an exact same claim as you, but instead of using the word gravity, I'm going to call it magic ethereal force. And instead of calling it mass, I'm going to call it pixie dust. And so you and me are going to stand next to a scale, and I'm going to prove to you that magic ether force and pixie dust are real, because when I put this weight on the scale is going to register weight, and then I'm going to claim that the magic ether force is pushing it down and using its pixie dust to push it down. And now I have proof of pixie dust and magic ether force, just like you have proof of gravity and mass. Thank you.
I would say you have evidence for mass or for magic, ether force, and pixie dust. I don't know about proof, but yeah, that I wouldn't have a problem with that. You would definitely have evidence for this concept of what you would call mass. You know, inertia. This ability for energy to be slowed down below the speed of light to resist other forces acting upon it. You know, yeah, I wouldn't have a problem with that.
We're talking about momentum, conservation of momentum, pushing
He's talking
heavy
about speed of
objects,
light.
billiard balls.
That's one type of momentum. We also have momentum within light, for example. You know, light can also be used to push and pull things. But I'm just talking about, really inertia, this ability for an object to resist forces acting upon it, right?
Don't you find that kind of funny?
To accelerate
momentum in
below.
light?
Why is that funny?
Well, because isn't momentum mass times velocity?
Oh.
And light has no mass. Don't you find that kind of funny?
That's
something.
a simplified.
Okay, wait, real quick. Mass times velocity equals momentum, but you have zero mass. So 0 times any velocity would be 0. So how do you have momentum in a photon? Go ahead.
Because that is a simplified equation for momentum, and we only use that equation to determine momentum within mass.
We're not talking
When
about
you look
mathematics,
at
though.
the actual expanded equation for momentum, It's used to determine the momentum within all forms of energy, even electromagnetic energy, even nuclear energy. So you can't figure out the momentum for light, and light carries momentum within its energy, within its wavelength, not within its quote unquote mass. Since light doesn't have mass. Mass is not
Just like
something
vapor is going
exclusive
up.
to things made out of matter. But what I will do, Noah, I'll post a few equations for you to see how light
Thank you.
can have momentum. Yeah.
Yeah, I appreciate that. Thank you.
Meanwhile, can you post also the momentum of vapor and the fact
Let
that
me
he's going to
just
go, please?
log into Discord on my phone because I have these saved. I wrote it down for someone a while back, so I'll show it to you. I'm not doing anything for you, George. Like you ain't being nice right now.
I would like to have the explanation for vapor as to why he's going
Oh, you
down.
just want to over talk me. That's what you want to do.
Because no one answered my question.
I tried to, and then you just rammed through me, bro. No homo.
Yeah,
I'm not
I mean
doing this with you.
that's what George does. He's likes to ram people.
Arma
Yeah.
knows what it's like to get rammed.
Well, no, I know what it's like because I ram people, and they told me their experiences of being rammed. Yeah, don't get it twisted, right?
The more you talk, the more incriminating it seems.
Well, I mean,
You're justifying your ramming, people ramming you.
But come on, we
I'm
all
gonna say
love to have an
something.
explanation as to why condensation and vapor is going down. Come on.
Oh, don't take that lying down, bro. I mean bending over. I mean no, I'm sorry.
I'm waiting for
Really? You ran
the
out of
momentum
words?
of a photon equation. I think I've probably seen
Yeah.
it before, to be honest. But
Yeah, I'm sure you have. It's basically E equals MC squared expanded,
I have seen it before. I know exactly
Yeah.
what you're talking about now.
Okay. All right. Well, I still need to post it, or you good?
I mean, if you have it, yeah. I mean, I was gonna go look it up myself, but if you could post it, I'd be
I
grateful
hope
for
you.
that.
I hope you can read my handwriting.
But he still didn't define what M stands for. What mass? You said yourself you have more than
So
one
there's the
explanation.
original
You have more
equation.
than one definition for mass.
Yeah, yo,
So in which context?
George, please fall back, man. I'm just trying to talk to Noah quickly. So you see under where I scratched something out with orange pen? That's the equation: E squared minus
Yeah, but
brackets
in which context
EC.
is
Oh, come on,
mass
George,
to be
man.
taken into account in this context?
It's not about you right now, George.
George, you got to let him
Uh,
finish. If you want to respond, you got to let him finish because he was right in the middle of saying something. So everyone listening at least wants to hear what's being said. So if you want to go next, you can go next. But let's let him finish. Go ahead, Nate.
All right. So E squared minus P C raised to the power of 2 MC equals MC 2 squared. So that simplifies to E equals MC squared. But you can also use that to simplify to C equals F. I forgot what you call it. Wavelength, But yeah, it's all there now. Use all of that. And then there's the actual, if you look on the right page, P equals H over Planck. That's the momentum of the photon. So it's all there. What was your question, George?
well, you rented a lot there, man. Mass in this context. What's the definition of mass in this context? And what is it?
In which context now?
You said M. So the M stands for what?
M stands for mass.
What's that?
Oh, I've already told you, George.
No, you told me there is different definitions for mass.
And
Now
I
I'm
gave you a
asking
lot of
you
them.
in this context, what is that thing that you're calling mass?
In this context, you mean within the context of E equals MC squared?
Exactly. See, you're clever, man. It's like pulling teeth. This is hard work, man.
All right. In that context, mass is just rest mass.
Mass is what?
Rest mass.
Rest mass. So mass is rest
Or
mass. What is
invariant
this?
mass.
What is this
Invariant
mass
mass.
thingy?
Intrinsic mass. Mass that doesn't
No, no,
change
no. What is
with the
that thing? You
change
still
in
say
an applied force.
you still saying different things of the same thing. Mass. The thing you're calling mass. What's that?
Mass itself is a body's resistance to forces acting upon it, inertia. If you want to get deep down into the gravy, it would just be an ability or property, elementary particles, some of them, not all of them, seem to show when they interact with a specific type of quantum field. This quantum field is called the Higgs field, and this interaction is called the Higgs mechanism.
Do gases have mass?
Gases, yes. Anything made out of atoms has mass.
Does it conform to your explanation of E equals mc squared?
Gases, yes. Why wouldn't they?
Can you elaborate on that, please?
Whatever the mass of the gas is, you substitute that for m in the equation. I don't understand.
Okay. How do you measure the mass of gases?
How do you measure the mass of gases?
That's correct.
That is a good question. I guess you would put that mass maybe in a
Go on, you can say it.
maybe in a box on a scale, and you see
Yeah, in a box
if
on
you
a
already know
scale.
what the weight of the box is, and you fill it up with gas,
So,
and you see the. I'm trying to answer the question you asked me though, right?
okay, go ahead.
Yeah. So if you already know that your box weighs 10 pounds, and you fill it up with gas, and then the scale tells you it now weighs 20 pounds, you would know you've added 10 pounds of gas, right? That would be one way to weigh it.
So you're telling me that on E equals mc squared, this is referred to a container with gases.
Oh no,
The
I
box.
thought you were just asking in general, how do you weigh gases?
No, because E equals mc squared, you said. The mass, yeah, of gases, for example, because you say this is applicable to gases. So the masses of gases would require a container. So how do you explain that the gases that we are breathing are not expanding to a vacuum of space if the volume is required?
Someone's hot making. You're like, is it me? Do you
Hold on,
guys
I
not
got
hear
it.
that?
It's left lane. Left lane is hot marking.
I got it.
All right. Sorry, George. If you could ask your question again.
You said equal C equals mc squared. E equals mc squared. That's what you said. Mass. Yeah, I asked you what mass is, and if gases have mass. Then I asked you, how do you establish the mass of gases? And you brought in a box. In other words, a container for gases. Don't you see
You
a
want to?
problem with your? Don't you see that is a problem for your equation? Because your
You want to?
equation, when it comes to reality, it requires a box.
No, yeah. I was confused, George. I thought it was two separate questions that had no relation. But if you are asking how do I use E
The
equals
heliocentric
MC,
model is a complex model. There's there's many ways of killing a rabbit, if you know what I mean.
yeah, I'm just trying to clarify here, George. I thought you just wanted, you asked one question, E equals MC squared, and then you asked a totally separate question. How do I weigh the masses within
Yeah, I asked you
gases?
for the
But
definition of mass, and if gases
yeah,
have
but
mass.
yeah, it sounds like what you were actually wanting to know is how do I use E equals MC squared to measure the weight of a gas? But E equals MC squared is not a measurement, it's a calculation. You would need to input your measurements into that calculation.
Of the universe with masses of
What?
gases. Yeah, of the universe with gases. Yeah, with masses of gases. attached to what they call planets. You need to go steps ahead, man. You way steps behind.
Now you lost me, George.
Check the
Yeah,
text.
because you steps behind, man. E
Chirility.
equals
Yeah,
MC
I'm
squared is
behind.
applicable to what, man?
Chirility. Check the
Equals
text.
it's applicable to a lot of things.
Check the
It
voice.
applies for the Riemannian for space, depending of space time. That's what it refers to.
No, equals MC squared doesn't work
Space-time.
within curved spacetime. Equals MC squared is an equation within special relativity where masses really aren't involved. It's more used to
Like gases.
to come up to determine energies, because we're looking for E being the speed of
Like
light. Yeah,
gases.
we're looking for E for energies. We're not really. That's why whenever we do a E equals MC equation, we just substitute M for 0. Because
Are
we're not
gases
expecting
energy?
masses to be. Yes, but E equals MC
So?
squared isn't really used within general relativity. It's used within special relativity. And the idea in special
Oh, it's
relativity is you
special.
are working within empty space-time in special situations where locally you wouldn't really have a gravitational field,
Empty space-time. Can you elaborate on that? What's that? Empty space-time.
Empty space-time
I'm
is
gonna-
just it's a hypothetical scenario where you have space-time void of any gravitational fields, but it's hypothetical. There isn't
Oh,
a
I
place
see.
within space-time where there isn't gravity because energy is always present.
Another concept like the bending of space-time and all of this nonsense. Yeah. It's just a concept.
Yeah,
Not
if you
reality, though.
think so. If you think so, George, I'm not gonna.
Not that I think so. I
I'm
know
not trying
so.
to
I know
change your
better
mind.
today. Today I know better. Trust me. Maybe I was in your shoes a few years back, but not today. Just a concept.
I hope I do not grow up to be like you, George. But who knows? Who knows what the future holds, right?
I hope you won't grow up to be like me.
Well, I'm just teasing, man. But yeah, I mean, you asked me
Yeah, I know.
questions. I'm answering, but I'm not answering with the intention of changing your mind.
I understand, and I appreciate your answers because you are answering correct within the heliocentric model, things that we've learned in regular school, and some people got in debt because of it. But that is irrelevant at this stage. Thing
I'm one of
is
those
that
people,
it's
George.
just a concept. It's just a concept. It's not reality. There is no physicality to it. Nothing that
I
you can
have
apply in real life to it.
I half agree with you, George. I half agree with you in the sense that on its own, these things are just concepts, but they are concepts that help us understand the physical world. They give us a very good understanding or explanation of what
I
happens in the
disagree with
physical
that
world.
part.
But it's
No.
okay. But just let me finish. It's not a one-to-one representation of the physical world. Because as I say repeatedly, we didn't create reality. We just found ourselves here, and we're trying our best to understand what's going on. Unless we had the creator's eye view on things, we would never really know how everything works. It's
Who's
impossible
we?
to know how everything works. Us, humans.
Who's we?
Us, humans. Do you know how
Obviously,
everything
I'm
works,
not
George?
part of that we because I have a different opinion than yours.
So you think we know how everything works?
Yes, we do know. The thing is, we tend to ignore the things that we know.
So we know everything already. We've got it all
Yeah,
figured out.
pretty much.
Wow. Okay. So there's no mysteries out there, nothing for us to we should just stop developing because we've developed everything that could ever be developed because we know everything
That's
right
not what
now.
I'm saying. That's not what I'm
It
saying.
sounds like that's
It's
what you're saying.
it's obvious that there is more out there. Yeah,
So we don't know everything.
every pond has a shoreline. Yeah, so there is more land out there beyond the pond line. Yeah, so we know that that must be a fact, and we know
So we
that
don't know
ponds they
everything.
don't curve. We know that ponds don't curve. So we know reality for what it presents. We know better,
Okay,
even
but
even beyond what some books say, because some other books say otherwise. So it's down to you to which books you're going to guide yourself with. The one that says that level is straight, or the one that says that level is curved.
hmm,
If you have to level yourself a surface, how would you do it? Which tools would you use? Would it be acceptable by other people as being accurate? That is the question you should ask yourself, because that is the reality of the world that we live on.
well,
Only when
it
it comes
seems.
to the ball, yeah, we assert that level is curved.
Hmm, I hear you, George. I hear you. But at least we agree that we don't know everything, and the mysteries out there to still be discovered. And because we don't know everything, and tomorrow we could find out something new that we didn't know today, it's impossible within the context of science, at least, to prove things. And it's impossible to know everything. And to ask me what exactly is mass, give me one-to-one physical representation or answer or whatever would be impossible for me to give you because we didn't create mass. We don't even know how to create it. We just have this concept which
We just
works
have a
really
name.
well. Yeah, we have a name, a concept, a model, an idea that work really well, but they're not 100% because there's still things about mass that our ideas don't answer.
Yeah, but you should be asking yourself, where did I heard that one before? We have a name for something, yeah, and we don't know what that is. No one can no one can actually describe, but beyond description, give us an example of what that thing is. Because if it exists, yeah, and we are naming it, it should be easy to demonstrate that. Look,
Yeah, this is
this. Whatever it is, this is a glass or this is a cup. We should be able to show it for what it is, not just to have a name, and that name will flow depending of the conversation with different meanings. It's a band-aid for anything in the heliocentric model.
yeah, but I think
Gravity.
it's easy to define what a glass is because we create glasses. We make them, so we know intrinsically, extrinsically. We know everything about glasses because we make them. But the things we use to make glasses, like we don't really know what those are. Mass, they're made of mass. We can manipulate mass to make a glass, but can we make mass ourselves? No. And because we don't have that
Yeah,
full
but what is
100%
that?
ability to
What
manipulate
is
and
that thing
control
that we
it,
cannot? What is that thing that we cannot make ourselves? What is it? You have a
mass. And I've
name for
given
it,
you,
but what is
yeah, we have
mass?
a name. I've given you the best answers I can give you,
No,
George.
you said that
But
there's more than one answer. You said there's
Yeah, but yeah,
multiple
yeah,
definitions for the same thing.
George, you're being a bit silly now because I've conceded more than once that we don't 100% know what mass is. I cannot tell you 100% what mass is the way I can 100% tell you what glass is. I can't, George, Neither can you. You don't know 100% what mass is. So to sit here and ask me a question, over and over when I've already told you, I'm trying my best to give you the best answer I can give you. Like, you're just
And
being
that
ridiculous now. And now you're breaking up.
is why you go along, why you go around in that anyway.
And yeah, where'd you say?
You don't know to still doing mass.
You're breaking up, George. Why don't you tell me what mass is, though? Really, I mean, you know
Mass, I
better
don't
than
know
I
what
do.
that is. I don't know
You
what
don't know
that
what it
is.
is.
No.
can you try? Can you make an attempt? You know, it doesn't have to be a 100% foolproof answer, but just make an
Why
honest
would I?
attempt at it.
Why would I?
Because
Nobody
I'm
knows what
asking
that
you.
is.
Because I'm asking you to. The same way
It's
you
just the
asked me
name
to,
of
George.
something that we don't know what it
You
is.
know?
We have a
Yeah,
name.
but please make an attempt. You asked me, and I tried my best to appease you. You know, like please just do the same for
No,
me. No,
I'm
okay.
happy that you reach the same conclusion as me. We don't know what mass
I
is.
haven't reached
So
the same conclusion
once
as you.
that we don't know what mass is, let's stop talking about this thing that
No,
nobody
that's
knows
not
what it
how it
is.
works, George. Just because you don't know what something is doesn't mean you give up trying to figure out what it is. It doesn't mean you just stop
Shouldn't you be
and
asking?
bury
Shouldn't you?
your head in the sand. You make
Yeah,
an
but
honest
shouldn't
attempt
you be asking
and
those
you
who are
discuss
preaching?
it. You know, you try
Shouldn't
and
you
make
be asking?
experiments and models to try and figure out what is it. Even if you know you'll never figure out what it really is, you still
Yeah,
make
but
that
Yeah, but we
pursuit
never
because
made
it's
that claim.
worthwhile.
you
Look,
should
look,
be
look,
asking
going
those
on.
who are
Hang
preaching
on,
for
hang
these
on.
things. The
We've
same
never
way
made
I'm
that claim.
asking
If you let me
you.
get in here. Yeah. We've never made that claim, yeah? We never made the claim to have any models or anything. We never made the claim that we know what the Earth is. We're trying to understand it. What we know is it's not what it's been given us. The heliocentric model does not exist. Copernicus himself didn't release the solar system as it's being taught today because he couldn't prove it. It was a hypothesis. But as soon as he died, they produced it and said it was the real thing. They postulated it and they made it as a real thing, and it's not been proven. Okay, so
Yeah, but
you talk
it's even
about like
beyond that
everything
today.
is real. It's
The
not.
sun is not in the center
Sorry, yeah,
anymore. Come on.
yeah,
The sun is not in the center anymore. So
that's right.
Copernicus is irrelevant in today's understanding of the
That's
nonsense.
right. That's
The
right.
sun is
Yeah,
not the
so
center of
The
anything.
cosmologists realize it now. That Earth is center. Cosmology, the principle. Scientism Exposed 1. Scientism Exposed 2. I posted them there 2 weeks ago. 2 weeks ago, I posted all three of those. You obviously didn't watch them. Obviously didn't watch them.
So, Jin, I'm still waiting for you to post the 150 documents from the
I
government
did.
saying the Earth is
I
flat.
did.
You posted them?
I did.
Oh,
If you
I
look
missed it.
under,
I'm so sorry.
well, just scroll back. I'm not going to do it all over again. It took me age enough to
You
get it.
know,
Scroll
yeah,
back.
I
I
didn't
made
know.
an
I'm
announcement.
scrolling.
I
Scrolling.
posted the documents. You were too busy being emotional with your heliocentric model that you can't prove that you lost it.
I apologize, Jin. I'm scrolling.
Yeah. So you scroll back. It's not that far back. Scroll back, man.
Is it the YouTube video you posted?
I posted 2 YouTube videos. One with 44 documents, yes. One with Richard from Boston, 150 documents. Get on with it. The
So
information is
are
in
the
there.
links?
It doesn't
Are
matter.
the links?
It doesn't matter what wrapping paper, but the present is within.
But are the links to the documents in the video? Because I'm sure the video is not going to. Okay.
Yes.
Thank you.
Yes. Each document is highlighted, and you can actually check it. Especially the one with 44 documents. You'll love it. You're going to love that one. All the documents are laid out for you to go and check. Freedom of information. It's all there.
Yeah, Jin, where in the video do I need to go for the documents? Because all I want is the documents. I don't want to watch the video.
Well, I've given you my best. That's how I learned. That's how I learned.
No.
Endeavor.
All right, cool.
You're
Thank
a
you,
truther,
Jin.
aren't you? Endeavor. That's how I
Thank
learned,
you.
my friend. I had to do it the hard way. I've done my job. I've actually done due diligence and brought it to you. You're busy arguing emotionally about something you can't prove. Huh? Come on now. Talking the Gene CBR1 here, not the cronies. Not that we have any in our community. Everyone's honour and integrity. No cheating. I'm getting ready to go out in the rain now because it's pissing down, but I've got to get out there. Do my exercise. Rainy day. Maintain that what you value.
Hey, Jen,
Destroy the globe.
did you know that the globe is flat?
I'm beginning to learn now. Yeah, I was shocked in 2015 to find out that the globe is flat. I was really shocked. You know, how did I get it wrong? How did I get it wrong? The globe is flat. I love it.
It's not funny. It's not funny.
Well, I mean, George brings it in good though. You know, you're funny, George. You're funny, man. And I see you taking my position in ramming them when they're not listening. Yes, keep on ramming, man, because that's good. Got to shake them up. Don't give them any room. Give them no room.
Where you headed off
No
to,
room
Jim?
to lie. No room to lie. Yes, I'm
Well,
donning.
truth
I'm
is only
donning my
one.
flat Earth t-shirt. It's early in the morning. I've got my flat Earth t-shirt on, the one that's in the avatar there. I've also got the azimuthal equidistant one as well. The other one that we use, but I'm using the UN map or the WHO like one. Yeah, that's what I'm wearing now. Black lycra shorts. It's raining, so it's Gore-Tex boots, so I don't get wet feet, and then we're off out there to go and bus only 3 miles today. Yeah, yesterday it was 15 miles. Today it's only going to be 3 miles. Well, there you go. You know, I don't just sit here and teach English and go to the schools and teach English and then sit there and do the discords. No, we're out. I've done the laundry just now, finished. I've done my children's. I've done mine and my kids together. My wife's separate. She was sleeping, so I thought, let me get that done. So now, and it's now, what time is it now? It's coming up for 5 a.m. So whilst I'm here talking to you, I'm doing other things, so I don't have to do them later on. Yeah, man. I'm enjoying it. I'm enjoying destroying globes.
Yeah, but whatever journey you're gonna do, yeah, please go from east to west and not from west to east.
That's
It's
right.
harder if you go the other way.
Thank you very much. Yeah, I've got to take the easy path. Absolutely. Absolutely.
I mean, if we like actually lived on a sphere, you just needed a bicycle and a little push, and everything will be downhill.
Thank you. Absolutely. and your fuel economy in the car would be excellent. You know? Going down, that is.
I mean, it just go down in every single vector.
Yeah. It's just a little costly coming back up. But you save the money anyway, so it doesn't matter. Okay, let's see now. I've got that. Check the time, coming up at 10 to 5. 10 to 5 a.m. Japan time. Just see some guy go past the window with the umbrella off. That means the rain is stopped.
Hold on a second. Which day are you? What's the date?
Oh, we are now. It is now the 30th, Tuesday morning. The 30th, Tuesday morning.
Jin, can you give me the lotto
Five.
numbers then? Because you're living in tomorrow, dude.
Yeah.
Yeah, man. I'm already here. It's wet, but it's warm. It's the rainy season. Tropic of Cancer.
You time traveled. You are ahead of time from us.
Yep, I'm in the lead. I'm destroying all the globers, so you don't have to have too much of a difficulty meeting any globers this morning.
At least I know the world's not going to end today because it's tomorrow by you already.
Yeah, thanks.
The time traveler.
Yes. So now I'm going to be listening to the Flat Earth podcast, as I'm wearing my Flat Earth t-shirt, so it's fitting to be listening to the Flat Earth podcast, and it's the one where it's called Convexed Earth. Now I like it because the music is compelling, and minute for minute, second for second, everything is facts. The globers just get smashed to smithereens. Smash. An hour and a half. Boom, boom, boom. It's bloody, but it's nice. So I'll be listening to that as I do my walk.
Nah, if I was you, I wouldn't do that. I would put a NASA shirt, yeah, and I would go around and just laugh with the mates. You know, isn't that funny that we lost the technology to go to the moon? Isn't that funny that the first man to walk on the moon said, because we didn't went there.
Yes, that was
Isn't that funny?
Buzz Aldrin.
Because if we have a leak in outer space, well, we have a leak.
We have a leak.
Yeah.
That was Don Pettit. That would be Don Pettit.
And why is that incorrect?
Isn't that funny?
What's funny about it?
Yeah, I love to go out with a NASA shirt, and go to a bar and have some fun with NASA.
Some people don't get comedy. We understand. It's okay.
There it comes. There's me signing off, guys and dolls. This is the beginning of the video. First 60 seconds is so destroying for the Globers. First 60 seconds. Let's listen.
Various civilizations have questioned the shape of the planet.
Hold on.
According to their level of knowledge.
Let's go, Jin. Show these guys what's up, Jin.
Even today, scientists around the world question the truthfulness of the sphericity of the Earth. Because even though it's presented as a truth, there is no unquestionable scientific evidence in this regard.
No scientific evidence in this regard.
On which science bases itself are only
Scientific question, anyway.
evidences are not proofs.
You hear that? Not proofs. Bang.
It is kind of a conundrum. They'll say science doesn't prove things, but the word prove means to establish something as true. So they're claiming that their science thing that they're calling that does not establish things as true, yet they claim to have all these evidences that are establishing something as true, but they're not proving, but they're still establishing it as true. They're trying to assert that. It's a huge contradiction.
Well, basically what they did is they walked into a murder scene and then they saw that some cookies had been eaten on the murder scene and assumed Santa was the murderer. And then they say, well, look, we have evidence Santa was here. There's bites out of the cookies. And they're like, I don't know. It's probably not Santa Claus. He's not a real guy. And they're like, nah, it's for sure Santa. It couldn't be anyone else. That's what they're doing, right? Because they're going to give us real evidence, but then they're going to give us their conclusion off of the actual evidence.
Yeah, like a biased particular. Yeah, exactly. That it was Santa instead of being someone else who ate the cookies. Yeah.
I
Yeah,
think
like-
you guys kind of have that backwards.
As if Jack the Ripper couldn't eat some cookies. No, it had to be Santa that did it. I mean, there's bites in the cookies. It had to be Santa. Couldn't have been just a murderer who decided to have some cookies on the way.
I think it was the Cookie Monster.
Like, just like
Hey,
with
you guys,
yesterday,
you have that
dude. When we were-
backwards.
Just like Jesse Gordon the other day, we were pointing out that he's just assuming that the cause of what he's observing is the warping of the ground into a sphere. You're just adding in an assumption and saying, "Oh, we're observing this, so therefore it has to be this." It's just like saying we're observing fucking bits and cookies, therefore it has to be Santa. Like, you can't just add it. You just add in assumptions, and if the assumption matches the data, which literally the assumption is crafted to do, then your assumption is right. It's just exposing.
No, but that's not what happens.
That's what I'm saying. It's an incomplete form of truth.
But that's not what we do know. We would first see that the cookies are missing and there's crumbs on the floor, and this is the naturally observed phenomena. We don't know what the fuck's going on, what happened, and then we would throw out educated guesses as to what possibly could have happened. Someone might say it was Santa. Someone might say my dad dressed up as Santa. Someone might say it was mice that did it. We don't know. These are all of the different guesses, hypotheses that we've thrown out there, and now we subject them to tests.
Until someone comes in.
George, come on. It's like you only interrupt me when Jin was talking. Like you didn't have a word to say, bro. Right? So we now want to prove all of these guesses wrong, though. We don't want to prove any of them right. We want to show that they're all wrong. But the more we struggle to show that they're wrong, the more evidence is built for one guess over the other.
Until someone comes in and says, actually, there is no cookies whatsoever. That's not cookies. Yeah? And that is the problem here.
All right, now we're in the weeds.
We're all talking about the curvature
Yeah.
of the Earth, and the curvature is not existent. Yeah. So let's stop talking about this globe non-existent curvature. Yeah, because the globe measures to be flat.
Yeah, but we've kind
There
of
is no
moved away
cookies.
from. Yeah, we moved away from that, Joe. You know, we were kind of talking about science and sorry,
Oh,
George.
I
We're kind
say,
of talking about science in general now.
yeah, but science doesn't deal with measurements. The shape of the Earth, it doesn't fall under the umbrella of science.
What? How does science not deal with measurements? Like, how can you say that, Joe?
No, yeah,
What?
He wasn't
measurements is
moving
with
off topic, by the way, though.
mathematics.
He was just
Measurements
stating
has to
that
do with
he
mathematics
said,
and geometry. Yeah, not
Which?
science. Science is the empiricism.
So
Yeah,
there's no measurements in science. We don't measure the temperature of
that's
things in
not what I
science.
said. I said that measurements are
No,
not
you said
science.
there's
The
no measurement.
claim
Sorry.
of a sphere is not a scientific claim. It's not cause
Yeah,
and effect
sure.
relationship.
Yeah, it's not a
Yes, it's a
scientific claim. I agree with you.
geometrical claim. It's a measurement claim that is
I
not
agree with you.
repeatable. Yes.
Those
So
are not
not science then.
repeatable. You can perform the measurement over and over and over.
Can you? Which measurement can
Yes,
you? Of
every
the Earth?
every surveyor agrees. Every geodetic surveyor agrees on the shape of the Earth.
Agrees with what?
That the Earth is a spheroid.
Well, but this is not about consensus, is it? Every
No, it's
surveyor,
about people who measure the Earth.
every surveyor surveys above sea level. From sea level above. That's what it is survey. They know for a fact that the sea is level because they themselves are using instruments to establish different level claims. Yeah? So they know for a fact that the sea is level. The surface of the earth must be level. Over.
Breaking up.
Someone is hot micing.
Me? So what, Nate? What's your favorite subject to talk about? Come on, you laid back New Yorker, give me an answer.
Someone is really hot micing.
My heart mic
Yeah, somebody sounds like they're reading a book.
Yeah, it's me.
Yeah, it's
But
chirality, yeah.
I didn't think it was a flat earther.
Flat earthers don't read books. Come on, bro. We're too
That's
Yeah,
correct. We don't even go to school. That's correct.
No, did you get what I meant with regards to how science goes about doing what it does? Like with the example of the cookie crumb?
like the process of elimination, basically.
Yeah, but where I do agree with you is that even though we eliminate everything else and we're left with one hypothesis standing, the evidence we get from that is still sort of in a way open to interpretation. You know?
Yeah, that's what I'm saying. Is I think the actual
So not a
Fugazi.
hypothesis then.
Sorry, what were you saying? What were you saying? Okay, I guess you're saying nothing. That's what I think the Fugazi is, though. Is I think they purposely kind of left the back door in the scientific method itself, so that they could have you do a bunch of experiments and believe the particular conclusion from these experiments and say, well, I know firsthand that I have proof of this. When you don't really have proof of any of these models, you just have a conglomeration of evidence where that evidence could even be put towards a different theory if you could come up with one.
Okay. Provide a theory that matches all the evidence then for the shape of the Earth.
I don't know. I was making like a legit point on the philosophy of science. I don't know. That just seems like random bullshit script that you fucking guys repeat every single day and put no thought into.
That's not specific at all? Okay, how is it random?
Well, I was talking about the philosophy of science and how the scientific method could be hijacked. And your response was a script that you guys come here with every fucking day that I've heard every single day I come here.
And then you brought up the fact that you could come up.
So it's like I'm actually thinking of things. I'm like actually, like pondering ideas and things, and you're just going through a script.
Okay, so why didn't you stop there and instead you went on to say that you could give a competing theory of the shape of the Earth with all the evidence?
No, what I said was you could have some fucking bullshit idea. Like I could have some fucking bullshit fucking idea. And then all I would have to do is go around and come up with different neat little tricks that I call experiments. That kind of maybe would seem like it supports my bullshit idea. And then I could pass my bullshit idea off as true and have an army of people do these little tricks or experiments and believe my bullshit idea. You could hijack the scientific method. That's what I was putting down. Like an idea of how the scientific method could be. Yeah, I was giving the fucking groundwork for how a scientific method could be hijacked to give off bullshit ideas, and you didn't really respond to that. You don't need to. You don't need to.
Example of that being done.
I'm just pointing out you didn't really respond to that. Like you just gave
I'm asking you a question in response. Can you provide an example of the scientific theory being hijacked?
I mean, yeah, the Piltdown Man. That's another one, right? Oh, we know.
And how?
Wait. You asked me a question. Please don't interrupt me in the middle of what. Yeah. So the Piltdown Man, right? So it goes with some bullshit idea that people come from apes. Then I can go out around, go find a monkey fucking head and a human jawbone, attach them together, and say, "Look, proof that humans came from apes." Meanwhile, you're all fucking sucking on a bullshit straw.
And who disproved that theory?
I think it was pretty mainstream when they found out that Piltdown Man was just a straight up hoax.
But was it scientists that debunked it?
If you don't know about the Piltdown Man, I suggest you go onto wikipedia.org and type in Piltdown Man, and you can read about it.
Okay, let me answer you. Yes, it was scientists that debunked it. So it's actually a self-checking system. So can you give an example where it wasn't corrected?
Flat Earth, I guess, would be one of them. I mean...
Oh, it's been corrected, yeah.
There's all kinds of shit, but the fact that you need... it was scientists that debunked it. You need... Like, there's no actual thing of a scientist, right? Someone who does an experiment, like, it's not a title. It's not like a regal title, like, oh, you've descended from this bloodline and now you're a scientist. Like, that whole word is kind of bullshit. There's a method that you can practice. There's a method that you can practice. It's a self-checking system, which, I mean, it did check itself once, but what's to say that there aren't things that slip through the cracks? That's like saying the government, oh, there's no corruption in the government. It's a self-checking system. We caught all the corruption in the government.
I never said that.
Right, no, but it's directly analogous, right?
No, absolutely not.
The government's self-checking, science is self-checking. Government can be corrupt, science can tell lies. Just because some lies have been exposed in science, some corruption has been exposed in the government, doesn't mean that all of it has been exposed. That's a ridiculous claim. You're claiming you have a perfect system.
You're correct when you brought up flat Earth. That mistake was corrected several thousand years.
Yeah, he obviously meant to say the globe.
You're not even responding to the content of what I'm saying. It's not really a conversation. It's just you fucking mocking me. Yeah, it's you mocking me while I'm actually thinking and actually speaking what I'm thinking. You're just mocking.
Well,
so it's not really a conversation. It's just you wasting everyone else's time.
So far, the two things you brought up, flat Earth and Piltdown Man, were both disproven by science.
So far, you've brought up nothing. So don't talk about what I've brought up.
Well,
You're wasting.
I asked you to bring something up, and
talking to Nate, because at least Nate is trying to actually like speak from the heart what he thinks he knows. You're just here to fucking waste our time, dude. And please stop.
That's true. Yeah, he doesn't make you look good. But all you brought up is that science is corrupt. But
dude,
you
haven't brought up anything.
I mean, you could bring up the example of. You could also bring up the example of vaccines causing autism. That's also been debunked. So,
I mean, you can claim it's been debunked, but you haven't brought up anything. So,
well, it's not my claim.
All right, don't say the V word, though. Don't say the V word, please.
What was I saying? Sorry. I apologize if I was swearing or something, but it's just like.
I mean, but with this whole topic,
Victor, I said a word that we're not.
Me and Nate have a legit conversation. Then I bring up something I think is legit, and this guy just sits here and mocks it. It's just a waste of time.
The thing is, though, on all the topics we're talking about, time will still tell, because who knows, in 100 years, they could double back on the topics we're talking about. Just like smoking, smoking is healthy. Smoking is unhealthy. Who knows, in 20 years' time, they're going to tell you it's healthy again.
Well,
they rarely double back, though. When do they double back?
Yeah, at any point, they can double back on any theory and say it's science. Oh, we're going with something exactly opposite to what we said before. So it's literally like you can't. There is no goalpost in science. You can't say anything is definitively true.
Outside of dietary science, that we have.
By the way, no, Jeremy was just talking about the jab, that V word. That's all he was saying. Because Chucky always finds a way to say it, even though he knows that that's that whole topic. So he's just a troll.
Then,
well, I actually didn't realize it was in result to that. Sorry, in that context. So I apologize. Sorry. But yeah, other than dietary science, where we don't have a very good understanding of it, what have we doubled back on?
Now he wants me to go fucking Google shit for him instead of just doing his own research.
Well, you brought it up, so if you didn't have anything to back it up, why would you bring it up?
Yeah, I mean, what? Let's see. The transition between, bro, even just with the solar system model and shit, it changed multiple times.
Yes.
What was it? Fucking Copernicus, then Kepler, then Newton, then Einstein. That's 4 different fucking models. Now the previous one is bullshit. Now we have to go with this new one all of a sudden.
Yeah.
So yeah, that's an example right there of science changing. I mean, I can't believe that you don't know. I can't believe that you don't know science has the ability to change depending on whatever.
Science progresses.
I can't believe
you said science doubles back.
And you make my talking points.
I said that.
You make my talking points 3 minutes longer every time you fucking interrupt. I still can't believe it.
Okay, well, the person who said science doubles back, can you give an example of when science doubles back? Science absolutely progresses.
What I said was not that it doubles back, that it could. I'm saying in 20, 30 years from now, things could change. I'm just saying, like, we don't live long enough to really test whether things have doubled back.
But we don't have to live.
Really? In 100 years from now, water is not going to boil with heat? Really, it's going to change that much? In 100 years from now, if I want to put the kettle on, I won't? Because the science is going to change? So heat is not going to boil my water anymore? Maybe one day will change?
I'm not saying facts will change. I'm just saying that
Facts.
you can
That's
erase
science, man. That's
you can
science.
erase
If you
memory
if you
of the
prove it,
population within a
if
few
you prove it,
generations.
yeah, but if you prove it systematically, and that is the ultimate goal of science, isn't it? Systematic experimentation. So every day you can actually do the test, and every day you'll have the same result. You apply heat to the water will boil. You know, it would be ludicrous to say that one day someone is gonna apply heat to water, and water is not gonna boil.
Nobody said that.
Even what SE brings up, SE bring this up before, that like now they're doubling back on the Big Bang and saying, "Oh, we see galaxies too far back in time," which already is an absurd claim in and of itself. They make.
They're not.
I'm gonna fucking mute you, dude. You have a fucking issue. People are making actual points. You're just
I
talking.
paused and I'm waiting for you to finish.
All right, yeah, that's it, dude. That's it. Next time you fucking choose to speak while someone else is speaking, I'm gonna mute you.
I think hold on. I think it's because he wants to really
fucking finish the fucking single point because you keep interrupting me. It's dishonest debate tactics, Chucky Brad Boy or whatever.
Go ahead.
Yeah, SE fucking brings this up constantly. That now they're thinking of doubling back on the Big Bang Theory because they see galaxies too far back in time. I've given you examples of how they changed the model of the solar system, what they think it is. Science constantly changes. If you knew anything about the basics of science history, is that science changes. It's not fucking constant.
Is it good now?
Right, yeah. I get that you probably are after a really specific double back, like as if they were going to like say Pluto is a planet again. That would be a complete double back, right?
Yeah, that would be, but that's just a classification and nitpicking, sort of. But in regards of the Big Bang, this is not science saying that the Big Bang didn't happen. It's progressing our understanding of the Big Bang and the time it takes for galaxies to form. I already mentioned that to SE. He thinks it destroys our entire cosmology, but he doesn't understand it.
But with cosmology being mostly theoretical anyway, how can you say it's progressing? How do you judge the progression?
I mean,
well, when we make a mistake,
another example of science changing is the distance to the sun. It's been distant. It's been a different distance, multiple different times.
Yes, it's progressed every time. Be more
Yeah, but it's not science, though. It's pseudoscience. Let's call it for what it is, guys. Science, yeah, science. It's observable, repeatable, and falsifiable.
Are you progressing knowledge, or
if it follows that pattern, it's science. Anything outside of that is not science; it's pseudoscience. So let's call it for what it is. It's pseudoscience. We guys are talking.
But when we're talking about the sun. We're talking about an angle measurement.
You're not talking about science, then. Not repeatable, not falsifiable, not observable.
When we're talking about the distance to the sun, the observation, not science, we're talking about an angle measurement. And as our tools get more advanced and more precise, we're going to get a more precise answer. That's why.
Well, first of all, it's not science, and second, it required a flat plane to do that.
Millions of mile differences between what they thought the sun and how far it was. And then you're going to sit here and tell me, science doesn't change, and I can literally go get any fucking history book and see, oh, it was 1 million miles away. Then it was 100 million miles away. Then it was 70 million miles away. Now it's 93 million miles away. Wait, that's called changing numbers. Oh, it looks like what science said changed over time, which you're directly saying doesn't. I have direct evidence of it happening, direct historical evidence of science changing.
But it's not science, Noah.
You're sat here saying it's not changing. So it's like, who am I going to believe?
I have never said it doesn't change.
Wait, who am I going to believe? A random fucking guy who mocks me on the internet, or an actual history book? What am I going to believe?
You're rambling, dude. I'm going to
but it's not science, Noah. In the first place, it's not science.
Do you know what the problem is? The problem is what they're trying to pass off as progression, because all you're doing is progressing your theory. You're not actually progressing knowledge. You know, you're just getting
Well, whatever it is, it's not science.
to the theory is what's called progression, and if it's too far off, they make another theory.
No, that changed. I'll say it again. That measurement changed because our instruments got more accurate. Because we're talking about an angle distance measurement over a long distance, that small angle adjustment is going to make a vast change in distance.
Yeah, it requires a flat plane for that angle measurement.
Not at all.
It does. It's a triangle. It's a triangle. Elevation angle.
You don't need a triangle to make one.
Yeah, but that's what you got to do. You're going to do an elevation angle. Yeah, that's how it's done. Every single day by mariners, yeah, that use sextants and other instruments to determine their position on the ground.
But they're actually,
yes, it's not the distance to the object that is in consideration here. Is its location over the ground. It's a geographical position. It's called GP of a star, for example.
Yes, but they're actually trying to get the zenith angle, so they're only taking the elevation angle to subtract it from 90 to get the zenith
correct. Angle. It requires a flat plane. I'm glad you recognize that.
No, to get a zenith angle, you do not need a flat plane.
You just said 90-degree angle. It requires a flat plane for that.
It does not.
You said a 90-degree angle. For you to have a 90-degree triangle, your protractor requires a flat baseline, the zero line, for your elevation to happen from it.
So why do they subtract the dip angle then?
Nothing to do with that. It has to do with for your angle to the sun, for your estimated distance to the sun, or whatever sizes of the sun appears to have, that requires a flat baseline.
So you don't subtract the dip angle based on your height to get to 90?
Based on your height, not to get to 90, you're always to the 90. You always have a 90 to it, yes.
No, not
you always have a 90 to it. Yeah, it's a triangle. The triangle closes the box. You have your altitude angle and your co-altitude angle. Because what you're trying to pinpoint is your location, because you know the location of the star. The location of the star is given to you in the almanac. And by having that 90-degree angle to that location, obviously it's 90 degree from you as well.
No, there's no 90 degree angle.
Listen, you mentioned elevations to the sun. That's how it's done. It requires a flat plane.
The elevation is only so that, and it's not to the sun. Example for celestial navigation, you use that elevation to get the track from 90 to get the zenith after you correct for dip.
You're breaking up.
All of that is based on a sphere.
So
elevation is from a horizontal plane.
After you subtract the dip, yes.
There is no dip if your height of eye is at sea level. There is no dip. No. If you are at sea level, you are at sea level. There is no dip to correct from. It's level.
If you say so, if you're at sea level.
Not if I say so. The dip correction you're talking about is if you are above sea level. If you are not above sea level, you don't need to account for any dip. And if you use a bubble sextant, you don't even need to account for any of that.
But that would imply that it's only a height correction, right? That wouldn't. If you would need to do that at sea level, if it was a globe.
No, I think you need to swim.
Globes, they don't have levels. They don't have horizontals.
So,
right.
For this measurement, you need to have zenith first, right, George?
You want to find your zenith, yeah, and you have the zenith of a star. So you know that the zenith of the star is parallel to your zenith. That's why you can have a 90-degree angle to it, and it's to you.
It can't be parallel. It can't be parallel to your
It
zenith.
must. It must be parallel. But listen,
Oh,
not
yeah,
just
but what I'm
one. You
saying,
need three.
George, what I'm saying is you can't have parallel lines on a globe if the lines are going towards the center of the
Yeah,
circle,
of
diverging, not
course,
parallel. They're
obviously.
divergent. Yeah. So it has to be a flat. Wow, that's crazy.
It must. It must.
You need a parallel line to do the measurement, but there's no parallel lines on a sphere. It's all divergent.
Not only that. Not only that. If you're doing this celestial navigation during the day and you're using the sun as your only reference point with periods apart, let's say you're doing the same reading to the reading to the sun every 20 minutes. Yeah. In every single reading that you did, those lines, they must be parallel to each other in order for you to pinpoint the duration of and the length of the position.
Thankfully, the amount traveled in 20 minutes is going to make those parallels almost, or those
Yeah, because you're going to use your protractor, isn't it? So you have your baseline, and it was at this point. So there you go. You have your right angle there, and then it was at this point, and there you go. I have another right angle there, and then you go to that other point. You have three. Now you have three circles that you can draw on the same plane to pinpoint your position on the ground. A protractor doesn't work on curved surfaces. It requires a baseline, a zero line, a horizontal line, level, elevation from level line upwards. I mean, it's simple to understand. Come on.
But in their model, they make a fabricated horizontal line that just shoots off into space.
Yes, by correcting for the dipping.
I agree. And also on their model, curvature is below surface level.
Say again?
It is curvature of their model is below surface level. If you go to the Earth curve, if Earth curve calculator, you will have the curve round, you'll have the center, and you'll have a horizontal line at the feet of the observer saying surface level. And then you'll have another horizontal line at eye level saying eye level. And I want to emphasize that the eye level horizontal line is parallel to the other line on the at the ground level. Yeah, so you have two level lines, two horizontal lines described as level lines. Yeah, and they are parallel from each other. One at the eyes, one at the feet. Now, the sphere or the curvature, let's call it like that, it happens below the surface level. Yeah, so if you are at sea using a sextant, where are you aiming? At the surface level.
Hey, don't even try. I don't get it.
Well, if you are aiming at the surface level, regardless how far away it is, it's not dropping 8 inches per mile square in any vector. It's surface level.
You know that they they don't get it. They think they live on a spinning wobbling tilted water ball flying from an expanding universe. Imagine thinking that. Right now, in this very second, they believe they're on a spinning ball that not only wobbles, makes some more magical seasons by hurtling around on their planets, it's shooting from an ever-expanding void of darkness. I mean, can you not obviously see that to be the case? Huge amounts of water forming into a spherical ball. I mean, sea level is basically it means slightly curving in every direction from the point you're standing on, 360 degrees from you, curving downwards. That's level.
In which language?
You know, when you look at this, when you're standing on the shore of the ocean, you know that 360 degrees around you, the next 10 kilometers, the Earth is curving away from you.
Is it?
It's what they believe. Curving
Oh,
huge
I
amounts of
see.
water, curving away from them. It's
what
so
we
stupid,
measure.
man.
And
But
No, it's
you
nothing
said
you measure.
360 degrees
Stop
around
lying.
you. So 360 degrees around you on a plane.
No. They think it's a ball, you know, that it curves 360 degrees in every
They
direction.
think I know it's a ball, but they also they see the horizon as being horizontal. So 360 degrees around you will be a horizontal at the horizon.
yes,
No curvature then.
But it's just too
Apart
big.
from you rotating in your own axis around 360 degrees, the curvature of the
The Earth is a ball, you just can't tell because the Earth is too big. You
no,
just can't tell.
you can't tell.
yeah, huge, yeah, with the radius 39, 59 miles. It's not that huge after all.
The LIGO drawings show you that you can tell.
Drawings. Cool.
The LIGO drawings.
Is that the one that what do you call a official lake next to it on the length of it?
No, canal?
Yeah, well, canal, yeah, on the length of LIGO, they built the artificial canal.
Yeah.
They had to establish a level before they built that length. They needed to construct a level. They know that
Yes.
water does that. That's why.
Right. But the elevation of the arms increases as you get farther from the vertex.
What is so difficult to understand about sea level and a horizontal line that is clearly horizontal, 360 degrees
Talking about-
around you, forming
You're
a
talking about the
plane?
horizon? Yeah, the horizon is a circle.
The horizon, the specific term that was chosen to describe the very thing in front of you that you're seeing, has been clearly chosen because the horizon is horizontal throughout.
Yes, the horizon is horizontal. So what?
Water, when unmanipulated, is always going to lay out flat. It's not going to change magically when it comes to a proportion that you can't.
Well,
You
you're
can't
right that it's not
observe.
magic.
It's just, everything when it comes to proving your globe will always be at a point where you as a normal person would not be capable of doing so. So if water is actually when we observe water normally in the confines of what we can do as normal human beings, it will always lay out flat. But when we have huge amounts of oceans, billions of tons of ocean water in a huge scale, then it will form into a ball. It's
It's not
it's
magic
just
though.
ridiculous, man.
Why?
Because it is ridiculous.
Why does water not is not affected by certain forces?
What is that question?
Well, you claim that water is not affected by the force of gravity or the pseudo force of gravity. Why not? It's affected by other pseudo forces.
Dude, I'm obviously just clarifying the simplicity of the matter. When you observe water naturally, okay, all around you, when you observe its behavior, you will always see it will first of all find the least resistance, and it will always, when unmanipulated, will always lay out flat.
No,
Create a
that's
flat
incorrect.
surface.
When you look at water, it always is affected by the forces that are acting upon it. Same with every mass, really.
Yeah, the force of the spinning ball that creates gravity to stick billions of tons of water to it without a container.
The
Amazing.
fact that Earth spins doesn't create gravity. It's the mass of Earth that creates
Oh, I know it's not the fact that the Earth spins, and I know that gravity is just a word. That's it. Cool story.
Okay.
I mean, sex is just a word.
Yeah.
Well, that has nothing to do with what we're talking about.
Well, as I'm saying, just saying gravity is just a word. It's not like doesn't really say anything about the insignificance of it. It's pretty significant, even though it is a word.
Word is also not only just a word; it is the word.
But anyways, I mean, you can go and go on thinking you live on a spinning, wobbling tilted water ball flying from the exploding universe, but you know, it's just vain fantasies and fables, you know, and you know deep down that it is true that you're lying
No,
to yourself.
so I
You have
needed
been
to.
around here long enough to know that you're lying to yourself.
Okay,
It's
so I
just
needed to
entertainment at
prime
this
my
point.
pump, right? Hey, what's your name again? I forget. Sorry, Waterball.
Hey,
Yeah, I needed to prime my pump the other day, so I got a guzzler pump. It's called. It's a hand pump, and I need to provide enough suction to overcome the gravity. That sucked when that amount of gravity was as much as it was. Why was that?
what are these weird questions that I don't even see
Yeah,
any
so
reason to entertain?
well, yeah, our
And
understanding of gravity helps us every day.
well, please
So
spare me.
it helped the engineers design that pump. And had I got a more powerful pump, it would have helped me have an easier time. But I had to get what was available.
Yeah, when I used a straw as a kid, sucking out the apple juice, I really thought about the gravitational force, man. So
Well,
important.
no, you probably didn't. But if you knew about it now, might you think about it now?
Oh.
Is your brain hurting?
No, not, not at all, man. I'm just amused.
Okay. So do you think the engineers think about that when they're designing
The
water?
engineers, what engineers?
The ones designing the lift pumps for
Yeah,
the mine
who?
we're building?
What is the
It's a
engineer?
company
Tell me.
called Hatch. It's a company
Okay.
called Hatch, Hatch, based out of Canada.
Uh-huh.
So do you
And
think
who's
they're
the
taking into
engineer?
account?
I don't know. I have never heard about the
I could
company.
say Chris McGuire. Does that mean anything to you?
No.
Okay, so then why do
Not
you
even
care
the
about his
company
name?
doesn't mean anything to me.
Okay, well, Google Hatch EPCM, and you'll find a company based out of Canada. What do we have? Probably 50,000 employees or so, maybe 30. And they,
and they think about gravity.
yes, very much.
That's amazing.
Not really amazing. It's just important. Why do you think it's amazing?
You know, I gotta give you one thing, right? Especially all the other anti-flat offers here, but also you, man. You really guys have mastered the skill of somehow diverting away from simplicity into something or that is within your fable of the great story that has been put up onto humanity as a deception. and
What?
talk about it as if it's a sustained foundation, or a true fact. It's pretty
Why do you
weird.
think?
Like,
Why do you
how
think?
about I talk about my dreams I had last night?
No, that's changing the subject. Why do you think reality needs to be simple?
You just prove my point again, man. You're really good at doing that. It's pretty good. I gotta
No,
give you that. You know how to
no.
do it.
I asked you, why do you think reality needs to be simple? Question. That's not proving any point.
Your
That's a
question is
question to
why
you,
does
Waterfall.
reality needs to be simple?
Yes. And I don't think that W equals mg or F equals ma is particularly complicated.
When again, when it comes to water, which was my initiated point before you started tumbling down into all the other things, claiming as if they're true facts, I talked about something that all human beings, everyone who's listening, will and need to agree upon, because it's fundamentally what we will all observe, that when water is unmanipulated, if it's a bathtub, if it's you taking a shower, if it's you putting water into something, a containment, you will observe what I have talked about. That is indeed simple, it is realistic, it is the truth.
We're going to disagree on that one.
You, on
But
the other hand, started talking about vain imaginations of men, good stories to describe what is happening, but
no, we're going to disagree that water is always flat. What we're not going to disagree with, unless I'm wrong, is that water always reacts to the forces that act upon it. Do you not observe that?
I do not observe water curving. No,
I
especially
didn't
big
ask you
amount
that,
of
did I?
water.
Did I ask you that? No, I didn't. So why did you answer that question?
I already
That's for
answered the
you.
question.
No, you answered a question I didn't ask you. Why didn't you answer the question I did ask you? I'll ask it again. Why, or do we agree that water reacts to the forces that act upon it?
I do not think that there is a force that acts upon water. I talk about water being unmanipulated. A force that would act onto water would be something manipulating the water. For example,
So
if I put water into a bucket and I spin the bucket really fast, it will create a vortex.
yeah, so that's great.
That's
That would be
manipulated water.
a centrifugal force, or if you spin the bucket over your head, that would be a or centrifugal
Yes.
force, I should say.
If I put the water into a flour and I put some olive oil in it and baking and some baking powder or whatnot, and I make pizza dough, then that water is also manipulated and will be formed into whatever shape I want it to be formed in. Same as with my body.
My pizza dough makes it hard.
So, but
Stop
again, going back to reality and what we all observe in reality, we all observe in reality that when water is unmanipulated, especially in a containment, no matter what the size is, it will always lay out flat. It is indeed what water does naturally.
When you
It
say
flows.
unmanipulated, is that
Yeah. So the way I hear Professor talking is like if I have a square or a rectangle aquarium that's empty, and then I have a large bucket or a hose, whatever, and I activate water flowing, right? I'm manipulating water at that moment. I am applying forces to it by tilting it over, pouring it out, and then all of that momentum that is involved in the mechanics of water finally finding its level, right? It's going to come to rest. At that point, I would think that Professor would say that at that point, the water is no longer being manipulated by anything. unless you count the walls of the aquarium, which are stationary, right? They're stabilizers, and so they are in a sense limiting water's expansion. But once the water comes to rest, I mean, ultimately speaking, it's never really resting because there's shit going on that we can't even see inside microscopically. So I'm not even going to talk about that. But that's what I'm trying to. I'm hearing a bit from Professor. If that's not correct, Professor, go ahead.
I do agree that if we would go into the nitpicking of precision to what my claim is, yes, indeed, we would need to recognize other things. But again, the obvious statement I'm doing is the very obvious thing we all observe when playing around with water. We know that water will lay out flat. If we fill up a bathtub and we wait 10 minutes until it's completely at rest, that water at rest will lay out flat. And if you put enough water into that bathtub that it flows over, the water that flows over will search for the least resistance, and wherever it's going to end its wherever it's going to end up, it's also going to lay out flat.
Disagree. So
as soon as there's rest.
When you, sorry, I had a call from the ministry. When you say unmanipulated water, do you mean not subject to any forces?
Listen, now, I'm sorry. When I started talking, did you like just totally shut your ears off? Because that's exactly how I started to address your point. I already addressed this.
No, what I said was, if you shut your ears off, is that I had a call from the ministry.
What?
I had a call from the Ministry of Labor, so I hung up on the Discord. And then
okay, so you're saying that as soon as I started talking, you had to hang up?
Apparently, yes.
Okay, so then I'll just repeat myself. I don't mind doing that. I think that what we're talking about, and if you have to go, please let me know because I don't want to waste my breath again. So if we have a rectangular aquarium that's empty, and then we begin to pour water into it, we are exerting a force on that water, displacing it from one container to the next. In that time, until the water comes to rest, as best as we can determine from, being able to detect the motions of the water. Okay, so at that point, nothing's going to be exerting any forces on it. Once it comes to rest, there's no force being exerted on it. It's at rest.
No, there's a normal force on the bottom and on the.
Are you just talking about pressure?
No, the normal force counteracts weight.
The normal force. I've never heard this term before. What does this term mean? The normal force.
Oh, I guess you guys, maybe it was university physics I learned in, not high school.
I have to guess about my education. I have a master's degree. Okay, so that's got nothing to do with the fact that I'm simply asking you to define your term. Are you using a term you don't know the definition for?
No, I said the normal force is opposite to gravity.
And I asked you, what's the normal force? What is that? I said, what is the normal force? I don't know what that term means. Can you define what normal force means?
Yes.
Okay.
It is the force that acts opposite to weight, perpendicular and opposite.
The force that acts opposite to weight. So the only thing that I can do in my understanding is I can see a rock that's relatively large, but I can pick it up with my hand and I can feel its weight. What else is there that I'm not able to? What else is there that I'm not able to determine or detect besides the weight of that rock? And what is that called?
So if you have a 100 Newton 100 Newton force weight, there would be 100 your vector diagram your free body diagram is going to have 100 newtons pointing down. That's FW.
Do you hear how convoluted your explanation is, man?
No, the normal force pointing up 100. So they're going to equal out. They're going to cancel out one another. That's why your rock is not accelerating.
Yeah, this makes absolutely zero sense.
Why did you interrupt me so often?
Because you're not making.
How does that make 0 sense? What did I say? Can you just explain it back to me?
I don't understand the words that are coming out of your mouth because the structure. Hold on, the structure of the words that you're using are nonsense. What you're saying is nonsense.
Okay, so tell me. I'm going to say it one sentence at a time, and then I'll pause, and you'll tell me if you understand that sentence. When you're drawing a free body diagram.
No,
end of sentence.
No, I don't understand. What's a free body?
Okay. A free body diagram is a diagram where you show all the relevant forces vectors in 2 dimensions. Does that make sense yet?
Yeah, so you're just drawing these ideas in your head. You're like, how many relative forces do you have? Is it like 13?
Yeah, you're drawing all the relevant forces with vectors.
Right. I asked you, how many are there? Is it like 13?
So when you have a free body diagram of a rock at rest, let's say it's 100 newtons, you're going to draw a 100
what a newton is. Sorry.
Newton long vector down.
Say that again. You broke up. Newton is what?
A newton is a measure of weight. It's the SI unit for weight.
Yeah, so is a pound. Why don't you stay in reality?
Okay.
I'm an American, so I don't use metric, so it's a pound.
Okay, I'll use metric for you. It's not just metric, it's SI units. So scientists use it. So if you have a 1 pound rock, you're going to draw a 1 pound down vector. They call that FW, force of weight. Good?
Yeah, I'm with that. Yep. Can't hear anything. Am I disconnected?
No, he disconnected.
I mean, I didn't want to steal the show, but I mean, I could not call him out.
No, man, you're doing a great job. What you're saying is objectively appropriate. It's funny how all these relative terms are being used as if they had the authority to stand behind a truth, a wall of truth of a foundation of truth. Sorry. Which is ridiculous.
Is this one lake water too, huh?
What?
Or just city water?
The city water one, I think, is the N one.
Is this one?
I don't know. I don't actually know anymore. If it doesn't have the Culligan on the top, the word Culligan on top, I think it's city water. You know, the sticker?
This one looks like city water. I filled one up with tub water.
Yeah, that one you can tell is gross.
Yeah. But this one looks like city water. I'll make ice cubes with it.
Hey, is it silent in here?
Yes, sir.
Okay, just making sure it's not my headset. How you doing, Jesse?
Oh,
What's up,
not too
Jeremy?
bad. How are you doing?
I'm always good. You know, actually, I was telling my girlfriend this story. I was gonna ask, I don't know. I don't think you were there, Jesse. I don't know if you were there, Jeremy. Were you there that like couple months I was staying with that dude who was ripping me off? I don't know if you remember that, Jeremy. I know a lot of people in gyms because I would come in every day and fucking tell them all these horror stories. Keep opening your mic, Jeremy, and then you close it, dude. You don't have to be scared.
Yeah, I'm not scared. You were staying with a dude. Yeah, we know you love dudes.
Okay, dude.
You put the G in the Freemason thing.
You know what? I'm trying to think of the timeline of the whole thing. And I think that you came into picture, dude, right after that. Because I remember I was staying where I was staying right after I was staying there. So you weren't there for the whole thing. It was a whole fiasco. But anyway, enough about me. What's I'm gonna do a chemo. It's not about me. But yeah. So what's going on here, huh? Oh,
Nothing. What's up?
I was just watching a tutorial video on how to perform a weighted mean calculation.
Oh, right. Yeah. You know what? You know, it's funny. So are you well, Donald, dude, don't trigger Jeremy, dude. You've triggered Jeremy already.
Nah, I'm just sitting in the crib dreaming about Learjets and poops.
Hoops and jets? Dude, you must have taken acid today, dude. What's going on? Anyway, now Jesse, you must have because you know whenever we were into that whole 39th parallel arc of the 39th parallel measurement, you know, I'm reading the whole document, and I actually got curious about exactly because you know Jeremy was a stickler for the averages thing versus like the raw data, and yeah, so I was looking into exactly what that entails. You know, taking those measurements, and so because it's basically like a standard deviation type of thing, right, Jesse? That's basically what you're coming across.
I'm not sure. Witsit and Jeremy were telling me that they did some weighted square mean math
Yeah.
on the actual measurements, which Jeremy and Witsit were allowing may have caused a consistent bias towards spherical excess. And neither one of them could tell me what those actual calculations were like or how they were done, or even what a weighted square mean was. So I just Googled it. I was just curious.
Yeah. Well, I think so. Like the mean, I think it's called root mean square. And if I was giving it to somebody in like 1-2 sentence, you know, throwaway explanation, it's not very different than using the standard deviation, and using that to sort of like weigh your data. You know what I mean? Which is a fairly reasonable way of doing it, and it's kind of the way that it's just the way it's the way that most data is collected. And so if it's like outside, I think the way they did it also, if it's outside the 3 standard deviations, then it was considered an outlier, of course, which is also pretty standard. But yeah, the calculations for it aren't very different than what you would use for a standard deviation, where you take like the square of the square of the average and all that kind of shit.
So
And take the root of that.
where would the bias towards spherical excess have come in during their weighted mean calculations?
Literally nowhere.
And I guess that raises another interesting question, because if they did bias their averaging somehow for a given triangle and made some of those corners a little fatter than they really were, or made them measure, recorded them as being a little fatter than they really were. Well, they used that same angles in the next corner of the triangle. So then that would make another triangle skinnier, wouldn't it?
Yeah, if they were actual triangles and not spherical excess, yeah, indeed. And it's not only that, but the triangles. So they wouldn't even necessarily measure triangles. They would measure these webs of interconnected points with like you think about a spider web, or whatever, like with many points, and then after that's collected, they can then compare the angles so that they'll take any angle and create these triangles, because they didn't necessarily measure triangles to begin with, but they did measure these angles at all these different places, and so you can
Can I
create
jump
these
in real quick?
triangles. Yeah, sure.
Hey, Jesse, are you asking a question that's critical of your own position? Is that what you're doing right now?
I'm not sure if I understand your question. I'm just trying to understand the exact math that the surveyors used in arriving at the averages, which they labeled observed angles in their data.
Saying you have people that say they for spherical excess, and you're asking about how they got it.
Say that again. You're cutting out.
You're asking about where they get spherical excess from. Is that correct?
That is not exactly correct. I'm asking what the exact calculations were done to the raw data in order to get the averaged observed angles.
In order to arrive at what?
Well, in the data, they've got this column that they've labeled observed angles, and I want to understand how they average their actual measured angles in order to come up with that number. Does that make sense?
I think it's kind of wonky talking about this as it is, because I don't think you're talking about reality. But I'd be curious as to like just from your own perspective, what's your knee-jerk simple? Like you're gonna try to steel man their position as best as you can, but you don't really know, but you're gonna try to say it as best you can. Like, what do you think they did? How do you think they got it?
I haven't seen the formula yet. I mean, I can tell you what I would do if I were doing it, but I haven't seen what they did. That's what I'm trying to find out, is what they did exactly.
Well, Mike, but I'm asking about Mirage information. They don't have it. Make shit up.
Actually, this equation, the formula is in the. I can try to remember which page it was on. I'll maybe pull up the document and try to find it. I think I have it on top of my head, but they do say it in the PDF. For at least, like I said, the crazy thing is I was so familiar with this at the time, and that obviously I had to erase all that shit from my head. But let me pull it up, and I'll find where the equation is. But yeah, anyways, and also, so this is another thing that they did, is they had these theodolites, these huge, not regular theodolites, like these theodolites with plates that they would basically, be able to stand on. They're like 2-meter plates with angles on them. But they wouldn't just take a measurement from one. They would basically, so if you imagine there being like one in the middle and like 5 or 6 points around that point that's in the middle, they would, when they had positions like this, they would choose one of those points to be a 0 point, and they would basically measure the azimuth, or they measured an azimuth basically from that point, like that's that point being a 0. So they'd get these angles that were all in reference to that point as a 0, and it's these that they have kind of written down, and that they also have to kind of do the math to later establish these triangles, because like I said, they didn't measure triangles outright. They took these big scale. They took these measurements with a large amount of points, and then later constructed the triangles from that. But even each of those points that they measured, they didn't just measure it like one time or whatever. They literally turned the theodolite. I think it was every 30 degrees or something like that, and measured it again just to make sure it's not a problem with the tool itself. And then they did it like several times throughout the day. So they ended up doing like 20 measurements from each location, basically.
Yeah, but that just ends up being calculations of a concept that you're just extrapolating out. That's not measuring anything. Like, what's the very first value that you can establish as verified?
The distances. That's the first thing they did, was measure they had so they had base nets with like a series of points, and they would measure at least one of those distances very, very exact, like by literally taking metal chains or metal rods and walking it out like 37 miles or whatever it is.
Well, I would like to see that documentation, obviously. Otherwise, you're just like making stuff up off the top of your head. Where are you getting your information from, Kosho?
They express it, and they also have pictures of them doing it, but I'll try to pull it up.
So all you're doing, though, right now is just describing distance. I don't have a problem with that.
Well, yeah, you asked about the first measurement. That was the first measurement they do. Is that they take that distance.
That's fine. So we're starting off on the right foot. I can agree that measuring distance is more concrete than abstraction. So then, what's their next value? What other value is physical that they can verify?
Well, then they would establish those points at these stations, and so once they choose which position is the best to gather, a couple of other positions from. So let's say they have 5 points. The point that was most in the middle of those points, they would choose that, and then they would choose.
That kind of makes it seem random at this point. All you're doing now is describing if you've got an axis point, are all of your other points equidistant from that as best as they
No.
can? Okay. All right.
Yeah, the distance. We're not worried about at this point. They're not worried about distance. So now that the distance was for the bigger picture.
Yeah, but hold on. You just said that was the very first physical evidence that they had. Like, I asked you like for a value and you went distance, and now you're saying, oh, but they don't care about distance. But that was the first thing you offered up. It seemed kind of.
You asked me for the very first measurement they took. I'm just letting you know that is the first thing they did when they got to the base station. Then when they took the angles they can gather independently of the distances. But for the big picture thing that they're doing, they would put these things together. But when they're measuring the angles, they don't necessarily need to consider for the most part, they don't have to consider that they're perfectly equally length distances from each position.
Yeah, but all you're doing right now is just describing another facet of distance. So you've got two distances. So, and then you're saying that they're not even that important.
No, I first of all, I haven't. Maybe if I finished what's done next, because like I said, what's done next is they have 5 points. They're not perfectly evenly scattered, but they do pick one that is more or less ideal to be able to take angles from all the other ones. So they pick one reference, the starting point, and then they pick another point to be the zero reference point. So there's a straight line, obviously straight line of sight from one point to some other zero reference point. And what they do is from that zero, they then take an angle to the remaining points from the starting point and the reference point, and they just go around and take angles as using that as a zero. And they record these angles, and they do this for the until they have a whole series of measurements for the entire base station.
Right, but isn't that just going to give you elevation and distance?
Well, no, it's gonna give you the differences in angles from the differences in azimuths from each of the
Okay, what does the difference in azimuth represent?
It's going to eventually. I mean, you can do the thing we're talking about is you can use spherical. You can get spherical access from that.
Okay, don't jump too far ahead of yourself now, Kosho. What is the value of the azimuth? Because you didn't answer my question.
Well, in the case that in the big picture case that they're actually used for, because they're you can get the spherical access from that, and they have
Oh my God.
I'm trying to give you the answer, dude. I'm trying to give you the answer, man.
No, you're not.
I'm trying to give you the answer.
I'm telling you, you are convoluting bullshit on top of bullshit. So I'm good. Thanks.
That's fantastic. Okay, you can be great. That's fine. For anybody else who is listening who doesn't want to be just dangling there, with half the information, what they would do is they would take that initial distance. They would take all those azimuths for each of those base nets, and they would use this information to describe how much the Earth was arcing, because that's what they were measuring, was the arc of that parallel. They wanted to see what the curve was at each of these specific locations, because they knew it was in a perfect sphere. They knew there was some oblateness, and they wanted to, for surveying purposes, get that as perfectly described as possible.
So they already knew that it was a sphere before they took these measurements?
Yeah, indeed, yeah.
Okay, great. How did they know it was a sphere before then? Let's back that part up. Okay, let's start all over. Everything that you just said is absolutely worthless. How did they know before they started taking these topographical measurements? How did they know the Earth was a sphere? Go.
I think they hired surveyors, and I think those surveyors went to school, and I don't know. That's all I know about them, and I think that's enough to be on that page.
No one knew the Earth was a sphere until a surveyor stepped up to the plate?
No, these guys knew that it was a sphere because they were surveyors, and they went.
Okay, Kosho. How did they know it was a sphere before they took measurements that it was a sphere?
They said this took place like 100 years ago, and so all they had to do was go through the education system, and they would have been taught that.
They would have just been they would have just been spoon-fed a mythological story of something that can absolutely defy all known physics, except for the fact that you can hand-wave dismiss all of those problems by simply drawing a nice picture of mathematics. Yeah, thanks for playing, Kosho. I'm good.
Okay, but you're asking like unrealistic, like unreasonable questions, like how did they know it was a sphere? Like, if you think about who these people are, they were people who have these jobs, not questioning if it's a sphere, because they're already surveyors. And the purpose of them doing this test or doing this measurement was to actually correct the model of the Earth that, what was it called? I forget what the other two models were that right before this one. There's two models that were basically more assumptive, and they were pretty close to being accurate, but they weren't. They didn't describe like the uniqueness in the shape at different locations. Like I said, it was more idealized. But even the people who had made that model were using, information that it was a sphere. I mean, these people weren't just making assumptions; they were measuring spherical axis as they're doing this. So it's kind of confirmed in their measurement. So it wouldn't even matter if they didn't know it was a sphere before. So that was a bit. I forget where we were at, Jesse, but.
Right, you were explaining to me the math that they used to average their multiple readings on the theodolite in order to produce the number that they called their observed angle.
Yeah, let me pull that up. I know they used the, like I said, the root mean square in order to get those averages. But let me pull up because it's written in a document.
Hey, Jesse, you didn't have anything on your bullshit meter go off when you were here in Kosho just now? Like all of what he said is you're good with everything that he just said to me when I was asking him my questions, because I would have thought that you could have like said, "Oh yeah, I'm glad Travis asked this question because I'd love to know the answer."
Oh, I'm sorry. I drifted off. I was working on something else.
Yeah,
Well,
right.
I heard, and my right, I wouldn't expect Kosho to know these like extremely specific, minutia kind of details, right? And if I honestly wanted to know that information, I would go and look it up myself. I wouldn't be asking Kosho on Discord and then formulating my worldview based off his answer. Right? That's not really a proper way of going about things.
Oh, so you don't believe in having a conversation? Okay, thanks.
Yeah, who said anything about forming a worldview on what Kosho said? Nobody even alluded to that.
Not that there's anything wrong with that.
Kosho's defending a document that was done in the 1800s. Travis was just asking questions about it, and Kosho was kind of trying to portray his understanding of it. Had nothing to do with changing worldview.
He asked what was the first measurement that would be made in this series of things. That answer was given. He asked what was the next one. That answer is given. And then he asked what the what would that tell you? Like what would what would you glean from this information? And that answer was given. It was given in both the purpose of the document itself, which is to measure the arc of the parallel, and also the purpose that we're using it for, which is to give an example of spherical access being done and recorded. So if you disagree with any of those things or the part of the first measurements that are made in each base stations or any of that, then I don't know what to tell you, but it's all in the document. So
Yeah, I mean, he was clearly just fishing for like where your knowledge about this stuff ends.
No, sir. Thank you. I don't need you to speak for me. I'm simply asking questions based on the information that Kosho does actually say. Like if he says something and I need clarification, I'm going to ask him about what he said. And then when I ask that question, you'll know exactly what I'm doing and why I'm doing it. So don't try to like divine what you think my motivation was, sir. Thank you.
I don't have to. It was quite clear, dude.
No, well then you're wrong, okay? I'll just step up as the self, right? I am who I am, and you are incorrect in your assessment of why I'm talking this way.
So
Sure,
was it the root mean square that was used to produce the average for the observed angle column?
in the observed angle column,
Yes.
I'm gonna have to pull it up because there's different tables, and I have to familiarize myself again with what the columns are in each table, because actually it is I'd be giving you the wrong answer if I didn't do that. So
just be careful, Kosho. When you open up too many tabs, you're going to crash the system. You got a lot of tabs open. You got all these questions you don't answer ever.
all right, well, I'm opening up my folder. I have the document in my computer. I just need to find where it is.
We're all forming worldviews off of what you say right now. Don't forget that.
Yeah, we'll wait, Kosho. We'll wait, but don't make us wait too long, okay? We have bedtime.
Jeremy, do you remember if it was root mean square you were thinking of? Because I think all you said was a square a weighted square average or mean or something.
Yeah, I didn't say any of that stuff. Which it was saying about the Clark whatever model and the weighted mean square least value or whatever. I don't know. I know that the observed angles are not just regular observed angles.
Well, yeah, of course. Yeah, because like I said, they not only take the theodolite and angle it, like and change the orientation and take the measurement again just to make sure that the theodolite isn't set up weird. They also take it like several times throughout the different parts of the day. So they're taking multiple measurements. And I think that the point of the root mean square is it's a sort of, like I said, sort of like a standard deviation to make sure that there's not like any outliers, like anything that's like way outside of the way outside of the measurement, because they're going to throw those out. They're going to average the rest.
I don't even think RMS throws anything out. It just gives more weight to that which is closer to the mean.
Yeah, but I think they do throw out the outliers, though. Well, I guess yeah, they'd say that would happen. Yeah, you're right. That would happen naturally. Yeah, because if they're giving more weight to it, then.
But it doesn't favor. It doesn't add a bias up or down. It just it makes no distinction between an outlier that's too high and an outlier that's too low. So it wouldn't add a bias.
How do you know? That's the point. You don't know.
I'm talking about the root mean square method. There's no bias in
right.
Hey,
but
RMS.
you have to. Right, but you have to verify the math that you're calculating, and that takes physical measurement, which I think Gio would agree with. But it's like you guys don't really get it, the fact that you're operating on a concept that's just an idea. It doesn't matter what you do, square the root, square the whatever, cube it, whatever. It's all mathematical. You can just change the ratio, and it's all mathematical. Like when you said, like Jesse, when you just said something about it being up or down, right? Remember what you were just saying about its position being displaced, right?
I'm not sure you understood what I was talking about. I was talking about positive and negative errors.
Okay, but then you said something about its position up or down, did you not?
No, I was talking about the value, as in a positive or a negative error.
Okay, well, if you go back a minute or two and go back and listen to what you said, you did use the references of up and down in terms of the position, like you said something about it doesn't affect the height of the object or something like that. Because I was going to respond.
No, I'm not talking about heights here. I'm talking about numbers. A number can go up or down even if it's in the horizontal axis. We're talking about averages.
Okay, so when it goes up or down in the horizontal axis, what does the up represent?
Probably to the right.
Probably.
I mean, it could, obviously it's either to the right or to the left. It just depends whether you're referencing positive to the right or positive to the left. It doesn't matter.
Okay, so are you saying that you simply orientate your field of vision to, like, you're looking straight ahead, you think that that's 0, so anything to the right is 1, 2, 3, 4, 5, and anything to the left is negative 1, 2, 3, 4, 5? Is that what you're saying?
Well, that's one way you can do it. It's either that or the opposite.
I don't know why. I'm not looking for a good job, Travis. That's one way you can do it, right? You're trying to find out how your side is doing this. I'm listening to the questions that you have, and I'm having my own questions, and then you're saying, oh, that sounds like a good plan. Like, what the fuck? Do you not know? It's like, this is just crazy talk. All we know, guys, all you ever are going to know is elevation and distance. In order for you to assume curvature, you're going to have to do one thing: assume curvature. You don't know that it's curved. You don't know how to measure curvature, and when you do, you confuse it and conflate it with refraction, which displaces objects laterally, horizontally, and vertically.
The funny thing is, for years, you guys told me. For years, you guys told me there was no refraction involved with this spherical axis.
The root mean square. The root mean square is a way of calculating the average and standard deviation between your predicted model values and measured experimental values. Just FYI.
Yeah, but I would venture to wonder if Jeremy and I were given enough money that we could do this research and also pay for our livelihood and not die of starvation or be thrown out of our homes. Like we would never have to square roots of square numbers and square shit at all. Like it would just be straightforward measurements, up, down, elevation, blah blah blah. We wouldn't have to get into any calculus abstraction.
Well,
Yeah,
all
but they
those
Go
wouldn't.
out, you
measurements
measure.
would
You
have
go out, you measure an
errors.
angle. You go out, you measure an angle. Right? Maybe you do it a few times. You write all the angles you measured down, in case anyone ever asks. Then you take an average, and you see what's what, and you would see what your measurement is. You don't need to be comparing it to different models and doing all kinds of bullshit.
Yeah, so
Yeah,
you
for
take the
me,
average.
it feels like I'm just
Yeah,
not.
you don't have to compare it to a model. You can just
Listen,
look
we
at
have
what
you
the
guys are looking over. Sorry, there's the
measurements
other guy.
are showing.
The other guy was trying to talk. Both Kosho and whatever this guy's name is just talked over the first guy.
Jace don't give a fuck. He's a molecular biologist and some other bullshit. He's thought does it.
That's Jace. I'm defending Jace right now. Never mind.
Yeah, I thought there was no one speaking when I started to talk.
Yes, there was.
Yeah, I think it might have been me,
So
but
now you're not defending me.
I would
Anyway,
just say,
Jesus Christ.
Yeah, go ahead,
Let's just
Satya.
all go one at a time.
I think it's Satya. Satya.
yeah. I typically just listen because I'm in a truck driving a commercial vehicle, but I had a break. I just want to say I've been on the channel for a minute, and for me, it's just I feel like I'm never hearing anything of substance from the globe side, where it's kind of this, like you said, this conjecture about models and the math, but never hearing anything like practically explained. Anytime we get to the nuts and bolts of the issue, it just all of a sudden we trail off into another thing. We never get down to the real explanations. If that makes sense.
Well, it's like Kosho said, these guys use the RMSE, the root mean square error method, because they were correcting a prior model. They were making it more accurate by checking what those model predicted values, the average and standard deviation, was against their experimentally measured results for the average and standard deviation. That's what they were doing if they were using the RMSE.
Yeah.
All right.
So if you really wanted to, go ahead.
So I have a question for you, just like I asked Kosho. What was the first known physical value that they actually had that was verified?
Exactly.
In the document.
I mean, I answered that
I'm
question
sorry, what?
pretty plainly.
No, you did not, Kosho. I'm not talking to you, Kosho. Please don't speak up. I'm trying to keep this as simple as possible. I'm having a conversation with someone else right now. You had your chance.
Yeah,
I'm
and
sorry.
I was just
I didn't
discussing. I
didn't hear what you said.
I was just discussing the root mean square error method, which is the word that's been thrown around for the method that they were using, right? I was just discussing what that is and what it does, what it's used for in most applications in science, right? I don't know the highly technical details of what these guys were measuring and what the specific values were, but I know what the RMSE is
When you're done
used for.
bullshitting, let me
So,
know and
right,
I can
this
ask you a question.
fishing for where
Hold
my
on,
knowledge ends. This fishing for where
Dude,
my
these
knowledge
guys-
ends about this
Guys.
is just rather silly.
Okay, are
Go
you
one
done
at a
now?
time, please.
Are
Yes.
you done with your grandstanding? You're all finished. You got that out. Okay, so I'm going to take that as a yes. You got your grandstanding out. So now that we have heard you clarify what you were saying about the square root, okay, don't need to talk about that anymore. If you're interested in answering my question that I posed to Kosho earlier, I'm not asking him the question again. I'm asking you, sir. What was the very first value that they got that was a physical measurement that they verified?
I don't know. I haven't read over this document.
Okay,
I've only heard the
that's a fair.
word that you guys were
I
using.
didn't ask
And I
you
was
to
just
like
giving my
talking.
input on what that means and what it is. I don't know the highly technical details of this
It doesn't
PDF
have
file.
anything to be.
Travis, hang on, man. Travis. listen, if you're going to engage with this guy, he's going to whine at you. He's going to go on and on for a long time. He's going to say right a lot when he's talking to himself. All right, so you're going to have to just either not engage with him or just let him go, because he's not going to stop for you. He's just talking. He's not going to let him stop and let you break in.
It's almost like a politician where they have this kind of teleprompter response every single time.
Here's what it's actually like. Travis asked a reasonable question 15 minutes ago. I answered it simply, a satisfactory answer. Jace gave an honest answer when he was asked of it because he hadn't read the document. In the document, though, it says specifically, it expresses how what they did was they made up these base stations. They drew the lines on the map, and they decided where these base nets were going to be. And then they took 1 point on those base nets, and they measured exactly what the length was of one of those lengths. That's
Okay.
exactly the first measurement they took.
Okay, then that's all they have is distance. Okay, it's just distance. And then you said that they have 5 or 6 other points, and they choose one for the axis. Is that correct?
No, they split the base net up into different points. They group them up, and so they'll take like a group of 5 of them, and then they'll choose one as the point, and then the other one as an original, and then they will go around and mark all the other angles in reference to that one.
God, I don't know what you mean when you say they choose a point, because I asked for clarification, and when I said what I thought it was, you said no. So when they choose a point, what does that mean?
They take a base net, which is a series of, could be 15 points, could be 20 points. It's different points, and it's different points in local proximity. Some of them could be 12 miles apart from a distance from each other, whatever. It's usually a range of. It's usually a range of, I don't know, could be 100 miles, from east to west.
I doubt they're doing.
Damn, Kosher, why are you so loud today?
Hold on, man. Hold on.
I'm not going to participate in this anymore, dude. You guys have fun.
Nah, my question was why are you so loud? Because the other day you were pretty low. Go ahead, Travis.
Yeah, I mean, again, Coach, you didn't answer any of my questions. You just filibustered and grandstanded. You said nothing. You read the teleprompter. You didn't ask.
I spent 2 sentences answering your simple question with a simple answer, dude.
Whatsoever.
If you don't have the ability to understand it, dude, that's on you.
No, I'm not going to fall for your banana in the tailpipe trick, bro.
Okay, let's all relax.
What we got from Kosho was exactly what I said at the beginning. All they have is distance. If you're gonna add something else, what is that called? Is it called elevation? Because then you have just distance and elevation. I'm perfectly okay with that. Don't need anything more. No more information is necessary than that.
If anyone's interested in,
where it's like,
hey, you got some more stuff to say about the commentary. Go ahead. No more commentary. Okay. Well, if anybody's interested and didn't understand before, that's perfectly understandable. But this is an example of a base net. Okay. It's a series of, it looks like, could be 9 different points, could be 9, 10, 11 different points. You'll see there's a thick line at the bottom right. This would be the line that they actually. This would be Travis. No, Travis. I think you need to wait. Just wait, dude. That thick line is the one that they measure exact. They get like poles and they walk it out back and forth until they're sure that distance is correct. Then what they'll do is they'll take a series of groups of these dots. So, for instance, they'll take that one called, I don't know, tap beer, whatever that's called, and you'll see that it's in the middle of looks like 3 or 4 different other points. They'll pick one of those points and make it a 0. Then they'll take another point and reference that first point.
Like, are you presenting something, Kosho? I'm listening to what you're saying, but it sounds like you're trying to, like, it sounds like you're looking at something and you think I'm looking at the same thing you are.
Dude,
I'm not looking at anything right now.
All right, he posted something in the chat. They'll have to ask if you could please stop interrupting, though, Travis. I know it's difficult to be patient if these guys are saying things you don't agree with or you don't feel like they're answering a question, but for the sake of everybody listening, we can only hear one person at a time. So just please don't interrupt.
I get that, Gio. No, okay, Gio, I get that, but like I said, I thought it sounded like he was presenting something, and I didn't know I was supposed to be looking at something because I'm driving right now. I can't look at anything.
He did post something in the chat, so yeah.
Right, but I'm driving right now, so I'm not looking at the chat.
Okay, I don't know whether he was targeting it at you or just in general, because I think you guys decided to disengage or something. I'm not sure where you guys left that, but do you want to finish what you were saying, Kosho?
I mean, if anybody, if there's still anybody who does understand, I mean, it's pretty explanatory in this image. If you heard everything else I said, that, you know, let's say you take that point that looks like it's in the middle, in the very middle of all of them, you can look at it, all the data is in the document as well. So they'll actually have the different groupings of which point they had at the center and which one they had as the 0. But yeah, so what they'll do is they'll pick another one of those points as the 0. So he's in the center. He picks the point to the left as a 0. He then measures the point at the top in reference to that point that he made the 0. And then again to the second point to the right, measure that with the reference to that 0 point. And he'll go all the way around, and then he'll jot all these angles down, and he'll move on to another point where he uses that as the center point and picks another 0 and does the same thing. He does this until he has all the angles for all the this entire base net.
Okay, can I ask a question?
By all means.
So when they move their base to 0, when they move their 0 base to another alternative, are they doing this all on the same day, or are they switching days and going from one location? Like say, for instance, on Monday, we've got 0 base at this location. We look off in 10 different directions. Nobody else is doing anything else but where we're at, unless you have more information. Okay, so then
They often spent several days. Days at each of the. They spent several days at each of the points.
Okay, but my point is, they weren't at any of the exterior points looking back at the center point, were they?
I think they had like a thing they had to shine back at them, or they had some sort of. I think they might have had to be there, but I forget, because they had something that they had to reflect the light off of. I gotta try.
Yeah, but my point in all of this would be that changing your perspective or changing your relative position doesn't do anything substantially in your favor of understanding what's happening if you're not taking reciprocal angles at the same time in the same condition on the same day. Because if you're only going from the center on Monday and looking out and doing it all day long, or even for 4 days, that's great, that's fine. But you're never looking back across the same corridor from a different position when the sun's in a different location from that position. Like, there's so many variables that I don't think you guys are actually crossing T's and dotting I's on.
Well, they did do all the measurements forward and backward. I know that, and they also did each measurement all throughout the day to make sure that there was no favorability in conditions.
Yeah, but hold on. I made a very clear distinction. What I meant by back and forth on the same day. So if you're looking at zero base on Monday through Thursday, and then you go to a different location to make your new zero base, and you look back at the old zero base, but you're 4 days away from the time when you look from the first zero base, you're not looking over the same corridor at the same time with the same conditions. You can't account for that variability. I'm sorry, you just can't.
Yeah, they probably agreed, which is why they didn't just take the the measurements. They took the root mean square and they took the multiple measurements and did all that to try to eliminate as much of that error as possible.
So is that baseline on the right, is that the actual measurement that they walked it? Is it?
Yeah, I believe so. That's right.
Okay. And then every other point was just optical measurements, yeah?
I don't want to say that, but I know they only did that walking. They didn't do the walking in all those locations. So I think that thick line represents the one that they walked out. I think they did have some kind of I don't know how much more crude of a measurement it was, but they did have some idea of the distances between other points.
Do any of those triangles add up to more than 180 degrees?
Yes.
Which one?
Yeah, most of them do. The bigger ones do. Some of the smaller ones, just based on the raw measurements, they're within. They're actually can be in some cases less. But it's because they're within the margin of error, though.
But just by looking at the diagram that you posted there, if I measured angles on all of those triangles, which one is the one that adds up to more than 180?
We'd have to look at the data, but it could be the case that all those triangles are too small to make a discernible difference, because there's a certain margin of error that they'll they have an error component that they give to each one of these measurements, and a lot of the amount below 180 or even above 180 are sometimes within that error. So,
but if you just gave me this, and I had a way to figure out all the angles just by this, can I discern that there's more than 180 in any of those triangles just by this?
I wouldn't do that, because these like I said, these measurements are too small to be able to make a confident conclusion like that. But it's in the bigger data set, the bigger distances that where you'd see that.
Wait, hold on. You think that increasing distance decreases inaccuracy? Are you kidding me?
No, not that it decreases inaccuracy, but it increases the amount of spherical excess that you would obtain. Yeah, and it becomes outside the margin of error.
Yeah, but if you can't even detect it, like you just said, the distances are too short. We wouldn't be able to ever measure it, and then you're just extrapolating out that, oh, if we go bigger and better, then we'll be able to measure spherical excess. Are you kidding me?
There's distances that you've reached that the spherical excess becomes a measurement that is outside of the expected error. So for that reason, that you're able to see it. There's still the error is it's not going to become some small thing or something like that. It's just that the spherical excess becomes larger than the margin of error.
Yeah, but that's just a calculation. You don't have to measure shit for that, because your geoid isn't ever physically measured. It's just calculated because it exists below the Earth's surface where there's higher elevation than the geoid. So you're always just doing calculations. You don't ever have to measure squat. You just divide and make the ratios smaller.
I mean, I would say this was a measurement, but of course that's what we're disagreeing on right now. So, but
what do you consider a measurement, Kosho?
A measurement when actually determining a value of something based on observing certain aspects of it, recording the,
So
properties
if you
of it,
draw,
and
okay, so if you draw a circle on a piece of paper and you measure its diameter and determine its circumference, are you measuring it?
I'd say so, yeah.
Okay, so in that instance, you know that you're looking at a circle because it has a center of axis that's equidistant to the circumference. So it doesn't matter what the ratio, the ratio is always going to be the same, regardless of whether or not that's a 5 millimeter circle or a 5 meter circle. It's just a matter of ratio after that. So I would love to know at what point when you're measuring distance and elevation that you ever become aware that you're touching or measuring the circumference.
I suppose it could be argued that, you might just be interpreting the data based on that bias and then coming to the conclusion which matches it. However, in this case, there was a guy at Stock Arter. He displayed the data in a way that took like all the base stations or all the base nets or whatever, all the triangles, and kind of put them in a graph. And you could see that there was a linear relationship between the size of the triangle and the amount of access. So the excess always increased as a triangle increased at the same rate as it would on the sphere the size of the Earth. So when you look at the data in that way, that would have to be a huge coincidence that the data, accidentally.
That's not a coincidence. Yeah, that's not a coincidence at all. That's just assuming you're consequent and massaging your numbers so that you can be so relative and abstract that it's a generality and a ballpark figure.
But anyway, this is the data I was talking about. I posted a picture, by the way.
Do they need to account for like refraction or anything on these longer distances?
Yeah, like I said, other than the errors that we had already talked about, that's basically what they try to correct for by doing it at different times of the day, taking these root mean squares and this kind of thing.
In the long run, no one ever accounts for curvature when you're making small projects like building a house or whatever. So you're always behaving in the real world as if the Earth is just simply elevation and distance. You have an area across the property that you just bought. You've raised the area. You've leveled it out so that you can establish your foundation. That's just area, right? So you've got distance. And then once you go above ground level with your foundation or whatever it is that's going to be your living quarters, you're now dealing with elevation. So at no point ever does anyone ever practically ever think about curvature. It's only in a conceptual model, and it doesn't even matter. It has nothing to do with what you guys or what happens in real life. It's always just a concept that can be proven mathematically because you can't demonstrate it physically. But because it's mathematically provable, you have to believe that it's actually there, and everybody just assumes that it is, but then ignores it when they build houses.
They build houses, yeah. Build houses or tables or pictures. Yeah, they ignore that, but there's plenty of applications where you can't ignore it. And actually, if you ignore it, the whole thing will be messed up. And we know some of the examples like LIGO or the Large Hadron Collider or large suspension bridges. A lot of tunnels.
Those are just mathematics, and you have to start, like choose one, Kosho, and then make your case, right? Don't just be listing shit off that none of us are ever going to look up.
And LIGO had to account for the curvature of the Earth.
What about this Panama Canal? I've heard that it was built along like a datum line that there was no curvature accounted for. Is that correct?
Could be correct. Because I mean, they're worried about the actual elevations and stuff like that. I would assume so. I don't know why. I don't know why the curvature would need to be considered in that case.
Oh, but it needs to be taken into consideration with bridges.
With some bridges, certain bridges, those
Yeah, but
suspension
those bridges
yeah.
are. Yeah, but those bridges aren't as long as the Panama Canal. So why is something larger not concerned with curvature and something smaller? Wouldn't it be less significant if it was smaller?
I think it's because suspension bridges might be, or some of them might be taller, and because of how tall they are, even at the the range, I mean, they might be smaller than the Panama Canal, but the distance between the bottom of the bridge and the very top of the bridge, where the cables are going to be, coming from, are going to be, not the same thing. So you wouldn't be able to use the surface distance to.
Suspension bridges, Kosho, are just given the. I'm trying to think of how I was going to say this. Suspension bridges aren't suspension bridges because of curvature. It's weight distribution. So all of those numbers that you're talking about are just conflated on top of, like, again, the curvature aspect on a suspension bridge means dick. The thing that matters on the engineering of a suspension bridge is making sure that you can fucking sustain the weight that you intend to put on it when you got mass transit going across. It's got nothing to do with curvature ever.
Yeah, well, I've heard several people talk about the construction of them. For example, like the Golden Gate Bridge, but really any long suspension bridge, and the distance at the base and the distance at the top. If it were on a curved surface, they wouldn't be the same distance, and so you wouldn't be able to use the surface distance to determine the amount of cable you'd need.
No one's ever going to measure that. You're not measuring anything. You're just calculating distance, and then you're incorporating or imposing the curvature of the Earth for whatever reason, even though it's insignificant because it's only a bridge after all, right? The distance isn't as great, so it's not going to be that significant. No one's ever measured the base of one of the legs of the Golden Gate Bridge, and then measured the tip top, and then measured the nearest one closest to it or the farthest one from it. No one's ever measured those distances between and said, "Oh, that's an obtuse angle from the center of Earth's axis." It's absurd, man.
Well, that's just what I've heard. I mean, I know an even smaller structure like the Large Hadron or the LIGO, for example, which is also smaller than the Panama Canal, would indeed have to account for it if it were curved. Because
it's absolutely absurd. You are decreasing the scale and saying that when you decrease the scale, you increase the need to account for curvature. This is absurd.
Fun fact, bridges bend upward in the middle because they're stronger that way. If they were flat, it would bulge down. This is not happening because the Earth is curving. This is just how you make bridges.
Well, are you still there, Kosho?
Yeah, I'm here. I'm just pulling something up. But yeah, go ahead.
Well, if you find in the survey that those old survey documents where they describe the specific math they did to get the average from their actual measurements in order to create the data for their observed angles column. I'm very interested in that. If you come across it, definitely tag me.
I have it pulled up now. I was just pulling something else up real quickly, but and honestly, I think I even remember the page number. I think it was like page 58 or something. But let me just pull it up. Because I have to read it real quick just to take out the part that describes it. Actually, I think it's expressed at the beginning of each section as well. But let me just pull this. Okay, I'm gonna post a picture, Jesse. This is just an example because this is from the first base net, but they have it written at the beginning of the of where they express the triangles. But let me post it. Hold on.
All right. Did you say you're gonna post a picture?
I'm posting it now. Hold on. So this is the part right before they describe the triangles for this section. This is the first. This is the first base net actually, and so this is the equation that they give for it, and this is what they. I guess this is where they derive the error for this specific set of data. Just to make sure that the variables make sense. Hold on. I remember where those variables made. So give me a second. I'm gonna pull that up. Okay, so actually, let me give you this table above that too, because that might help. It may not have made sense on its own, but and also ultimately the whole document, like the whole part before this, where they come up with where the data is coming from, probably make even more sense too.
This looks to me, without me fully understanding what's going on here, like it looks like this is relating to the calculation of the corrections, which was something that was done after the observed angle was arrived at, right?
Well, yeah. So the actual observed angle. Let me see. Hold on.
Right, because basically there was multiple steps. The first step was to make a whole bunch of raw measurements with the theodolite, like you said, rotating the base so many degrees every time to compensate for nonlinearities or eccentricity in the dial, the plate. Then they did some averaging on those just to average out whatever error, whatever random errors the theodolite had and the atmospherics might have caused. And that
Okay, so yeah.
what's that? That may have involved some weighted averaging. And then, but that gave them their observed value. And then they had to take and apply sub-arc second corrections to the observed values to make it fit the ellipsoid that they were trying to make it fit.
All right. So the yeah, see, that's why I wasn't sure because okay, so what I posted just now is the original. Like this is the data you're talking about, like the observed. This is the angle you're talking about, I guess. The observed angle, the one that they actually are, measuring and jotting down. And on the top of my head, I don't know where that's explicitly stated how they took those averages. I think I overheard Larry talking about it, and he did say something about the standard deviation. But I on top of my head, I think these were just as simple as taking all the measurements at that location and then taking more or less an average. Don't quote me on that one because I'm not 100% sure. I don't know where it states that in the document.
Okay. Yeah, because that's what I'm interested in, is because the allegation that's been presented here by the other side is that the averages with the raw data were somehow consistently biased towards spherical excess before being written down as observed angles. And I'm trying to find if that's true.
Yeah, from like I said, from like everything in the document and the way I've understood it in the past was that certainly is not the case. Like they don't, like that's not like if you read the document, this is the very first data that is introduced as what they've collected, and then they show how they go through and make those sort of the corrections and the root mean square, all kind of stuff, and then they obtain the triangles, at the end of each section. So I don't think there's anything at all that goes into coming up with those observed angles other than basically taking the average. So I'll look through the very beginning again to just make sure. That's why they have the probable angle or the probable error in that initial part. Stock Arter posted something.
Right, and the probable error, because if you watch a surveyor do it the old-fashioned way with just a theodolite in his little tablet, he'll take a face right reading and a face left reading and write down the angles, and he'll do that he'll do like 10 sets of those if he needs good high accuracy, and then he literally takes the standard, gets the standard deviation and the probable margin of error, and that's what he gives. There's no bias in it. It's just an average from that set of readings.
Yeah, you see, Stock Arter is posting because he knows more on this than I do, but he's basically saying that those are the considerations. Is they take the two sidings, which is what they're so basically they get that from getting that single position and using it as a reference, and then the only thing they add to that is the reduction to sea level, and they use that as the initial observed angle. Yeah, so they just subtract the reduction in sea level from the observed angle.
Oh, they're mentioning figure adjustment.
It's so funny because in the document it says the least square adjustment to satisfy the conditions among the measured angles generally proceeds by the method employing correlate equations. And then there's an asterisk, and at the bottom it says the process is so well understood as to need no further remarks.
That's not very helpful.
Yeah.
What process is it though that they mentioned?
The root mean square. It says so again. It says the least or the least square. Sorry, the least square adjustment to satisfy the conditions. So it's not the root mean square. It's the least squared adjustment to satisfy the conditions among the measured angles. Generally proceeds by a method employing correlate equations.
So is that the one they were using on the raw data from their actual raw measurements?
Yeah, I
of
believe so.
angles?
I believe that's it. I believe that's what it's stating. Yeah. And this is where Starkadder had. He said he just wrote in the chat that this is the part of the document that explicitly describes it, and that's exactly the first part of this part of the document. Starkadder is like an expert with this, whereas like I dove deep into it a few months ago, but I purposely forgot everything I ever learned. Oh yeah, I forgot there was that example. Yeah, so yeah, he's posting there. There's an example in the document that shows how it's processed. So I don't know if you can read it, Jesse, but it's a perfect example of exactly how it's processed.
Yeah, let me read this. I'm a slow reader.
Oh, so Starkadder, I don't know if you're here listening, but when you say hundreds or 131 series for that station, does that mean that that's how many how many measurements were taken for that one station? Hmm.
Hello.
Yeah, that's right. I do remember hearing that they use equal weights. Yeah. So I guess it's not explicitly stated, but that whole outlier thing, I think, goes without. I mean, just is kind of like obvious. I would think that if it's, if they're taking the, well, no, sorry, they're taking the least squared, the least average, or the least square. I mean.
Oh, so I'm just reading what Stark Goddard wrote.
Yeah.
Each station has a table of sightings from that station in the PDF. For each angle presented in the observed angles column, they have taken the difference of two sightings in the table belonging to each station. Does that mean they actually set up the theodolite and they pick one of the targets and set it as 0, and then they measure the angles to all the other points that form triangles with that point while they're all set up there? Why not? And then to get the corner angle of each of those triangles, they just take the difference of two readings from that point, right?
Yeah. That's in the document too. They show like there's like an equation, but it's not really an equation. But yeah, it shows you like, take this angle from this angle, But yeah, exactly like you described it though.
So, and this is done with the averaged observed angle. In other words, literally, if they skewed one of these angles to add spherical excess to one triangle, it would literally subtract it from the next one over, right?
Yeah, but what like he was talking about these series, like you saw what he said about the series. So they did like 131 series, and each one of those series they did a complete, 360 degrees, measuring, a majority of the points each time. So if there was 5 points around them, they, more or less measured, 4 or 5 or as many as they could, but more or less they got like 100 or so. But they did each of those in the same circle. So each of those circles, so the way I'm thinking about it is if there was like, let's say one of the circles, one of the measurements there was an error that was caused, it would be equal. It would be the same error in the average of all the other ones. So kind of just like, I don't know. It doesn't seem like you would end up with a access that way. It seems like it would kind of correct itself.
Right. I mean, right. Let's say you were doing 4 triangles and you were in the middle and they were each 90 degrees for you. If you added if one of your heading measurements was off, it would add spherical excess to one of those triangles and remove it from another. Remove it by the same amount.
Yeah, for that cycle, yeah, like for that series. I mean, like because you're going around, you're using the same cycle to take more or less all the measurements. Like you said, like you would skip whichever ones weren't favorable for that specific series. Is what he's saying, which makes sense. But yeah. So, but still though, that error that you got from there would end up somewhere else in that circle, that series, right?
What if you have error in the edges of the circumference of that
My
circle?
My fucking god, dude. Leave it to Bacon, man. That should be a new show, a new fucking sitcom, family sitcom. Leave it to Bacon.
Yeah, I missed you too, Kosher.
Yeah, what's up, man? Is your girlfriend gone?
No, she's right on my side.
Okay. Well, I was just curious because I didn't know. You know, that's why you were spending quality time with her. You know.
Yeah.
It's good, man. Repeat what you said though about the edges of the circle, because I was
Yeah,
kind
like
of thinking.
if you have an arrow in the center of that circle, then you're adding to one triangle, you're removing from another. But that's only if you're in that center, right? If you're in the edge, you can have an error that only adds because you don't have triangles being removed where you're removing from. Right?
Yeah. Well, yeah, that's true too. Is like the triangles that are actually expressed later in the document. Like we can talk about these things as circles. Like each of these points, they make these circles. But the triangles that are later formed are never formed from just one circle. Like there's always like you're always using points, you know, from several circles in order to make that triangle. Yeah.
Get it.
So yeah, what you're saying could be true. So okay, Bacon, keep giving some ammunition to the other dudes.
I'm trying to strengthen your side.
Okay, man. What are you eating right now, bacon?
It's better if I find the flaws first, right?
Yeah, I guess. Although it's not really that big of it's not like a flaw or something. It's just what Jesse said is true, but that wouldn't that wouldn't correct for all the problems just by doing that, which of course it doesn't. But yeah. But then again, we're talking about, like I said, according to this graph that Stockharder posted in the past, there's a linear, there's a linear relationship between the data of the size of the triangle and the amount of excess, which you would think wouldn't be caused by just this random, these errors that pop up.
Yeah. Yeah, I wanted to do something like that. I started getting data by hand from those PDFs, but it's just too many. And then I gave up. Mainly because he already did it.
Usually a discouraging reason. That's right. Looking at my pictures, I have fucking the data for Jeremy's 4 points in this in the celestial navigation thing. 4 GPs, I mean. But here's the his data.
Yeah, that's a beautiful graph.
I sat down for 1 second, literally 1 second. And I was just gonna say what's up. Jesse says what's up and asks about this transcontinental document. This takes me 3 hours. That's stuff I have to do.
You don't have to do.
Okay. I'm gonna end up being homeless, dude, and like I'm gonna be homeless with like a computer under a bridge somewhere. I'm like, hey guys, what's going on, guys? This is like my worst vice, coming in here.
Yeah, it can be productive sometimes.
It can be
But-
productive, but it has to be moderated, like time managed.
Yeah. I can't manage. I either spend too much time or I don't spend time at all. It's one or the other.
Exactly the same here. Oh wow! So yeah, earlier, I think Travis had asked, was it the same day or whatever? But yeah, they spend in some cases months at one station.
Why did he do this, by the way? What was this measurement originally meant for?
Because there was a map of the world. Surveyors, dude. They're surveying the world. If it wasn't for them, we wouldn't have GPS, for instance. But anyways, they have this map of the world, and they're sticklers with perfection, and they weren't happy that it wasn't perfect because the Earth is an oblate spheroid, and it's not even like a perfectly
Symmetrical
predictable one.
one.
Yeah, exactly. There's like fucking lumps and bumps and benign, you know what I mean. There's all sorts of stuff going on. There's growths going on.
There's gravity changing verticals.
Exactly.
In such a way that it changes latitude, sky-based latitude.
Yeah, we wanted to get a more perfected data set, and I think we have one because there's the WGS 84, but isn't that for the globe? WGS 84. There's also the one that we use, which is like we use like in America. And I forget it. So there's two of them. There's one for the world and one for America. And the one for the world is actually less exact, is less correct in America, but it's more for the whole Earth. Whereas the other one, and I forget which one that is, it might be like.
It makes sense. If it was better than the one specifically for America, then you wouldn't need the one specifically for America.
Yeah, that's right. I just forget what the other one is. Hold on. WGS makes sense. WGS, World Geodetic System. And then the NAD 83, that's the other one. I think the NAD 83 is the other one. National Reference, whatever. I don't know what it stands for, but. But yeah, obviously GPS uses WGS 84.
Does it? What does it use it for?
Why does it use it for?
Yeah.
You can usually switch them to any of several different datums.
I guess, yeah, that's true, because you would just use you have to use the ECEF just coordinate system, and yeah, you could just plug in whatever datum, yeah.
Yeah, but like when you say GPS itself, you mean the satellites use the model for something, or?
No, well, I think so. I think that, well, hold on, because I have so much shit in my brain, I gotta remember exactly. They use ECEF, and I forget exactly how they established it. Give me a second. I was just reading about this the other day too.
All right. What happened?
Well, we were unable to find any evidence of bias being added to the measurements between being measured and being written into the observed angles column.
What measurements?
The azimuth angle readings.
All right, let's see the measurements before we go any farther, because we're not going to know if they were messing with it or what happened with the measurements until we actually see the measurements, right? So let's see them, and then maybe we can go on with this.
Well, even if we could see them, we wouldn't know that they weren't messing with them, because they could have just all been sitting in a smoky back room making up fake numbers and claiming that they had been out on mountains measuring them. We don't know that.
Sorry. So you said you had no evidence that measurements were being messed with. Can we just see the measurements first? How do we know if they were messed with? We haven't even seen the measurements yet.
I told you I don't have those. But even if we had a list of what
I don't have them either.
Even if we had a list of what was purported to be measurements, we wouldn't know that they were actually measurements. They could have just been numbers that they made up in a smoky back room.
So you want to figure out if the measurements were messed with, but we haven't even seen the measurements yet? Aren't you like going, this feels like out of order.
I mean, if you want to say you just don't trust the publication, the book, whatever, that's fine. But to say that the book actually says that they added a bias to their measurements when it doesn't, that's not cool.
What measurements? There are no measurements. You don't have them. I don't have them. Neither of us have a measurement. Like, I don't know what we're going on about when we don't have any measurements in the first place.
And lower your voice, young man.
I'm just saying it's weird, bro. What measurements?
Hey, don't upset Jeremy like that. Give back his ad hoc.
Yeah, I mean,
I'm not
so
upset.
measurements
I just feel like we're skipping a step. We're trying to figure out if the measurements have been messed with. I don't even have a measurement yet.
Right, because like I said, if they gave those, then it could go be replicated. They don't give them; it can't be replicated. So it's just a mess of averages and claims and just a shit show. It's just a clogged up mess. It's like trying to unclog a drain, and there's just all kinds of hair and scuzz in it. Like you can't even. It's just a mess.
No, it can be replicated, of course.
Okay, so no one's done it since the 1800s?
Well, done this exact thing, done exactly the way they did it. Probably not exactly the way they did it, but we have, because like I said, the NAB 83, which I don't know exactly how that was done. That's the updated one.
Well, how could it be replicated if they only give a mean averages in terms of what they even claim to have seen through their theodolite? If we went out and replicated it, we got a bunch of numbers. How could we actually replicate what they did?
Well, I'm saying you can replicate it, and let's say you do a different mathematical equation to determine what you decide as your fixed angle. Like you're deciding this is the angle I'm thinking is the most correct. You know, whatever means you do it. If you get the same angle they get, then that's verifying it, even though they used a different way of averaging their data, which I don't think they did anything that strange. They like I said, they just went around like 100 times and took the angle and then took the average of it. I didn't realize they went around 100 times.
Why wouldn't they just do it once? If it's an accurate method to measure a very precise angle, if they're claiming it's an accurate method that you're measuring this very precise angle with theodolite at mountain peaks, why couldn't they just shoot it once and get it? Make your triangle that's supposed to be bigger than 180, one triangle, 3 angles, done. Why can't they do that?
Fear of false positives, false negatives, or false data.
So it's a terribly ineffective method.
No, just doing it once would be, you know, you'd have the fear of that, but you know, that's what you get confidence in the multiple measurements and.
Yeah, but if I have a good method, like let's say I have a meter stick and I'm going to measure the size of my table, a table. Yeah, I understand you might put the meter stick on there 2 times, 3 times, maybe even 5 times to double, triple check it, but you're going to get one number. If it's a good method, you're measuring one thing. I'm not just going to put the meter stick and get 10.5 inches, 10.2, 10.6, 9.4, 9.9. That's just a mess of a method to begin with, and then start averaging and plugging in all these corrections and calculations. Sounds like just an absolutely ineffective method to begin with, if that's what you're doing.
Well, what if you were measuring the table down to the micrometer?
Well, then I should have a tool that should be able to do that, and measuring it once, twice, maybe 3 times at most, just to make sure you have it right. That should be it.
Maybe a 10th of a millimeter.
You can always increase your accuracy as a general rule by averaging multiple measurements. That's why even though some of my 36 measurements were off by 100 feet from the globe's prediction, the average of them was only off by 6 feet.
Yeah, it's because this whole method involves atmospheric effects, and you're shooting something over very long distances. It's very, very inaccurate, and it's just an inept method to measure the shape of the Earth. And the ineptness is shown with all the wide range of results that they're getting. I mean, if they're going out and having atmospheric effects that are moving things around and changing the position, of course they're going to have all kinds of. It's all over the place. It's like throwing darts at a dartboard with a blindfold on.
Well, in the image that Starkcarter posted, like this says there's 131 circles they went around. None of the actual individual points were measured 131 times. Some of them were only 60 times because, you know, the other 70 times, you know, when they were going around that circle, that one position would have been unfavorable. So they immediately didn't even measure anything that was in a particularly unfavorable, you know, weather conditions or whatever.
I mean, I don't know if they did this or not, but one thing I would do is leave the crosshairs on the thing, wait an hour, go back, check, see if the crosshairs move. Go back an hour later, see if it moved. An hour later, I would do that for, I don't know, a day or two maybe. See how much it moves off the crosshairs, left or right. Then we could see, all right, this is the maximum, the maximum thing. I don't know. I was told there was no refraction involved with this for the longest time. To even measure to the arc second is crazy, right? We barely do that today. And then to measure over, 50, 60 kilometer, I don't know how far they were going. Some of these are over 100 miles. Some of these supposed measurements that we don't have. I mean, I talked to Larry about replicating this. He said it would be a major, major, major undertaking just to do 3 angle measurements, 3 mountains. Because I'd actually like to see what the crosshairs say, what the deviation is. Go up there, spend a day or two, see how much it deviates from left to right off the crosshair. Doesn't that seem like the right thing to do? Did they do that? I mean, there's no reason you couldn't have left to right refraction here. This is on the side of a mountain, on top of mountains and shit. You got valleys and shit, different climates on either side. Like, I don't know. I feel like this is a perfect setup to have a left to right refraction thing going on.
Right, but even if it did cause somehow a consistent skewing of a certain angle to be greater or less than it should, that would add or subtract that equal amount from the corner of a different triangle. So there wouldn't be a consistent spherical excess. Whatever was excess in one triangle would have to be an anti-excess in the other, in another.
That's true. If we could see the measurements, we might be able to figure something out.
Do they have these measurements?
They don't have a single one.
Wow. So what's the argument then?
We're arguing over if the measurements were calculated or the observed angles or whatever. We're arguing about the measurements, but they don't
But
have.
if there is no measurements, they can't claim measurements of a spherical axis.
It's weird. I know it's weird. They got an average, so.
Elbow, what would you think if I told you I'm
Average
gonna
of
go?
what?
Yeah, what would you think if I told you I'm gonna go measure something? All right, and then I don't give you the actual measurements. I just give you these weighted averages. What would you think of that?
Dude, I have an average of $1 million in my bank account.
You can weight. You can put some weight on it and average it any way you want.
Yeah, that's just weird.
And how much would they be upset if a group that they disagree with about the shape of the Earth went out, claim they took a bunch of measurements, don't actually give the measurements, but just give these weighted averages, don't really give the information as to how they got those averages, meaning they didn't show all the numbers, and then, okay, these are the ones we threw out. They're just throwing some out. This one was off range. I mean, who knows what they actually did? That's the point. We don't even have the evidence to see what they even did to the numbers in the first place.
Was that Hitchens' razor?
Yeah, this would be a lot better if we had the actual measurements so we go over and see it. See what they did, what they threw out, the actual numbers they got. I'd also, like I said, I'd also like to see how much it moved off the thing without, you don't move your crosshairs. Keep your crosshairs still and see how much the thing moves off at left to right in either direction at any given moment. I mean, that would be like a good thing to do, right? You're looking 100 miles, 50 miles. It's got to be wavering or something. Like, that'd be a good test alone. Just go to the top of a mountain, look at something dumb far away, leave the have something with crosshairs on it, and see how much it veers off left or right.
I mean, there's no point, man. What can be it's just razor. What can be asserted without evidence can be dismissed without evidence. I mean, all they have is just anecdotal evidence. I think Kosher agreed. I think I heard Kosher say that. Yeah, it's practically. I think he agreed on that, right? That it's pretty much. It's just. I think he didn't. He wasn't he agreeing a few minutes ago that that telling Jesse that this is it does says assumed or whatever. Not assumed, but it's pretty much is in the beginning of the document or whatever. And they have no evidence. Is that right, Coach? What were you telling Jesse earlier? And not so little words, you can just throw this shit out.
I don't know if Coach was here or not. Either way, I think we all agree this would be much better if we had the actual measurements. I mean, it's a 900-page document. How many more pages are the measurements take up? Another 900?
Can you drop a link to that document, Gio or Jeremy, that you're looking at?
I can't even open it up on my computer, so it's the transcontinental arc of the parallel, some shit. It's like 900 pages. You've never seen it? You posted me a page from it once. I thought.
I've posted a lot of pages to a lot of people. I may have seen it, but I just want to be looking at the same one you're looking at right now.
I don't have the link right now. My computer can't even load that up. I've only seen pages here and there.
Okay, is it the transcontinental triangulation in the American arc of the parallel?
That's it. It should be about 900 pages. That's like some biblical shit. How many pages is the Bible?
Depending on which Bible you're talking about, because a book can be really big or really small.
Is it close to like 900 pages though, or what's up? Those are some thin.
I think it's
That's some thin.
excessive.
They'd be using some thin ass paper in them. I know. The Larry GPS said he was going to try to give me the numbers, like I don't know, 8 months ago, maybe a year now. I don't know. We've been on about this for a long fucking time. This started for me about 2 years ago, maybe 3. And they told me all kinds of wrong shit throughout those 3 years. They told me those were the actual measurements. So I brought the shit to Bev. Bev's like, "There's no way that's a fucking measurement," because it was like 3 digits past the arc second. He's like, "There's no way that's a measurement." He's like, "You're guessing after 1 or 2." So then they told me there was no refraction left or right. But there is left or right refraction. So that's actually a thing.
But it is considered to average out to 0.
I know you guys always think the refraction averages out to 0. I know. Get a whole bunch of not actual positions, a lot of not actual positions, and think it averages out to an actual position. Yes. Like that would really be something to do, Jesse. You should think about doing this. Getting one of your theodolites or whatever, going up to some shit where you can see like 100 miles away or something. Throw your crosshairs on it and just wait. Wait an hour, wait an hour, wait an hour, and just keep checking it. See how much it goes off the crosshairs. I mean, the tiniest amount is a lot of feet. I don't even know how many. At 100 miles, how much feet would an arc second take up?
Oh, hold on, I can tell you that exactly.
It's got to be like 100, I'm guessing. It's a wild guess.
So 1 arc second at 100 miles is 2.5 feet.
That's it?
That's it.
No
1 arc
way.
second. That's what you said was 1
Arc
arc
second
second
is
at 100.
yeah.
Yeah.
Arc second
And
is a
100
tiny
miles?
amount, yeah.
Yeah,
All right.
that's actually it's 2.55981, but it's about 2.5 feet.
Oh, that's not bad. I thought it'd be a lot more. Well, I mean, don't you think that's a good idea to do that though? Go up to a mountain or something over a day or two and see how much the shit wavers.
Yeah.
Like just camp out there. Camp out. Don't even touch the theodolite. Just set up a tent and just stay there for like a day or two, and just see how much it ever moves off. From left to right. Obviously, up or down doesn't really matter. I guess it doesn't really matter for you. You think it's going to average out anyway, so it's like whatever. It doesn't really matter. What if one day it's way to the left? What if you put on the crosshairs and it sits there for like 2 days, and then the next day it's way off to the left because there's some kind of weird shit happening in a valley below or something? This is why we need to do a tangible measurement. CGO, that's what I'm saying. When we make those triangles, how do you get the angles to them? What are you doing to measure the angles? That's why I like the square with the X in it, because that's like a distance thing. That's like tangible to the ground. We're touching shit. You know what I'm saying? But with the triangles, you got to measure the angle now. It's got to be a square with X in it, bro. It's like two of your triangles. I need your two biggest triangles. Like, guys, we're just looking for some definitive shit, man. And this will all be over with. Let's all use our heads together. Think of something definitive. No refraction. Anything that uses refraction, I mean, let's not even go there.
Gio, are you in there?
What Oh shit, head's cleared out. Everyone's doing a cookout maybe. I got a math trick for you, Jeremy. All right, what do you got? Uh, pick any three-digit number that's like a repeating number. 111, 222. Pick one. We'll go with trip 5. Okay. So
It doesn't matter which one you pick, but to explain it with fives, the answer is always going to be 37 when you divide it by the sum of the numbers. So like 1 plus 1 plus 1 equals 3, 2 plus 2 plus 2 equals 6, right? Whichever 3-digit one you did, divide it by the numbers added up. So like 555 divided by 15, or 111 divided by 3, like the 3 ones added up. The answer is always 37.
37, huh?
Yeah, 999 divided by 27, 37. Always.
It's crazy.
Here's another one. This was weird. Said take any 3-digit number and write it twice to make a 6-digit number. So it doesn't matter. Then you for some reason this has to be in order. Divide it by 7, then divide that by 11, then divide that by 13, and you're gonna get the number, like it's like 371371. Whatever you do, as long as you divide it by 7, then 11, then 13, you're gonna get that number cut in half visually. Like you're gonna get the thing that repeats itself, the 371. So what I'm saying is like 371,371 divided by 7 divided by 11 divided by 13 is going to be just the first 371. All right, it doesn't matter which 3 numbers you repeat though. If you divide it by 7, then 11, then 13, it's always like the half version. Why does it make a difference? Wait, you can't just take the number and divide it by what is it? 31, you know? Why does something divided by 7, then by 11, then by 13 not the same as just dividing by them as a whole added together? I guess I know why. It's just a little unintuitive because multiplication doesn't work that way, does it? Does it? It probably does, I guess. I don't know. No, I guess they compound either way. My bad. But yeah, the trick still works though. I have no idea why. 552,552 divided by 7, then 11, then 13 equals 552. You could do like 999,999 divided by 7, then 11, then 13 equals 999. Yo, you ever done any amount of ones on a calculator, like squared? Like 1,101,101 or whatever times the same number. It just goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. But you can do it shorter ones. Like if you do like 1,101 times 1,101, it'll be like 1, 2, 3, 4, 5, 4, 3, 2, 1. It'll just count up and then count down. Or like 11 times 11, 1, 2, 1. And then the next would be 1, 2, 3, 2, 1. You found any more 273s anywhere interesting?
Nah, I see no good ones really.
I haven't even been looking.
Yeah, me neither. I'd love to try to link all the megalithic structures together. Honestly, if I was gonna do anything, that's what I would spend my time on. Because that would just blow the whole. That would blow the whole shit out of the water, really.
Oh, hey man, there's before I was, hanging around these parts. I was into solar system research, but not like nerdy shit, like a cult design to the solar system. Like you know all the ratios you find in there, right? That was my jam. And the channel who probably does it best is named SGD Sacred Geometry Decoded. And if you're trying to tile the megalithic structure, I mean, he's done it, man. Like the same ratios, the same everything, they're all there. Same as the solar system, same as all the Capitol buildings for each state in America. They all get the same like numerical essence going on. He's made videos on each of them. That's more of his older stuff, but I mean it's still uploaded if you want to check out that channel. I'm sure you'd like it. He's a glober, but he's like, guys, don't you see that the solar system was designed by God? Because there's no way that all of these ratios could happen naturally in a Big Bang cosmology. So you can take all his stuff and just be like, can't you see how fake the solar system design is that they try to sell us on because of all these fucking coincidences?
Yeah, man. I'll have to check it out. Send me a link to his shit.
Sure, man. Bet he's got some sort of old playlist or something of his old work about that stuff. He was inspired by one of I've had conversation with him, and he said he was inspired by one of the first videos that ever tipped me off too. It's called it was actually a series, but he took all the series and compiled it into one long 4-hour video called Secrets in Plain Sight.
Oh yeah, hell yeah, that's the fucking shit right there. You know what? I came
Yeah,
out with a second one, right? You see the second one?
yeah, man. I think the first one just has a special place in my heart, though. Taking you
Oh
on a
yeah.
tour all around the world from place to place, inside of buildings, showing you like sculptures outside of them. Just all over the place, yeah. Good
That
shit.
was put together. Yeah, that was put together. Like the information was concise. That was good shit right there.
Yep. So that's what started Alan, the guy from SGD Sacred Geometry Decoded. And I was like, oh yeah, I can totally see how that inspired you to like take it even further.
Oh, I'm sure that sparked the interest in a lot of people. That Secrets in Plain Sight movie, yeah.
Yeah.
Because if you don't know that, like no one's gonna tell you that. You know what I
Yeah.
mean? No one's just gonna tell you that information. It's out there and it's easy to get, but like you got to put it together. If you don't put it together, like yeah, you could go look at how tall and the shape of stuff and how many feet high it is. Like okay, great, but if you don't synthesize all the data, it's just like random noise. It's not anything.
Right. All right. I posted it in live stream text one, live stream one text with you tagged. That's his channel. I'll see if I can find a good playlist of his videos from probably about 4 years ago. Lately, for a while, he's been on debunking people like Brian Forrester and Jimmy from Bright Insight and the people, the Tartarian people and the ancient alien type people, you know?
Oh my god, you ever see Chris White Ancient Aliens Debunked?
Oh man, yeah, it's so good.
That's so good. You ever see the thing he did with Zeitgeist?
No, I never
Same
saw
did
that
with
one.
Chris White. Oh, bro. Zeitgeist did a thing. He debunked it. Zeitgeist made a rebuttal, and then he rebutted that. It was fucking dope. Nice back and forth. I mean, he absolutely destroyed the Zeitgeist people, but
They're asking for it.
they were because they were wilding at that whole their whole religion thing. I mean, they got the Fed shit on the Fed was looked good to me. What else did they do? I did like their idea of a resource based economy. That was some good shit they did. They just fucked up the whole religion part.
I never actually watched any of the Zeitgeist films. I know they're like sacred scripture to a lot of conspiracy theorists, or what kind of tipped them off at first.
Well, they got a
But I
lot of
never seen
stuff
them
right.
myself.
They got a
Yeah,
lot of
I'm
stuff.
sure.
I mean, I don't want to say right, but I liked a lot of the stuff they did.
Uh-huh.
It's kind of like arbitrary if it's right or wrong. Some of the stuff is subjective. But anyways, the whole religion thing with the crypto religion shit, they got it wrong. Not crypto religion, astrotheology shit. It didn't work for them. They made a lot of shit up. They fabricated some stuff or posed it as in a very disingenuous way. The back and forths were dope. That Acharya S chick was getting interviewed, trying to rebut all the points, and Chris White just ripped that shit to shreds. Because they made this Zeitgeist thing. Chris White debunked it. Chris White made a lot of valid points. When Zeitgeist did their rebuttal, like they didn't address, or their addressing of it just sucked. It just sucks. They suck. I was on that astro theology thing too for a while. Like they had me gassed up. I believe that shit was true for like at least a decade.
Well, I mean, there's a lot of I mean, astrology and theology, things in the scripture, like, are definitely metaphors for just celestial movements and relationships and stuff. So, like, well, maybe some people take certain things too far or make false points. But what do you mean? Like, you're done with astrotheology? To me, that's like one of the cornerstones of like all understanding of. I don't know. It just ties into so much. Well.
Well,
So
the pagans did. This was specifically on Christianity or Catholics or whatever, the whole Jesus story. So
sure.
this was specifically on that. Obviously, the pagans were heavy into that. That's why it's in Christianity right now. Roman had this thing called the mystery religions or some shit. They would just like pick and choose parts of religion, and then they were trying to merge to get the pagans to become Christian. So they were like, "Yo, we'll do Jesus' birthday on December 25th, and we'll do Easter on the solstice or whatever the hell it is." And yeah, that's why
Sure.
it's
Right.
like.
Right.
But as far as like the original like
The
biblical
scripture.
the biblical shit, yeah, nothing matches with any
You.
astro. Nothing.
Oh, I think so, man.
There's nothing you can do it. I mean, if you got something, I'd love to see it, but I haven't seen anything yet. And Zeitgeist tried like hell.
Okay. Well,
Or
I
no,
mean,
no, no. Oh, hold on.
Okay.
The whole Zeitgeist thing was it was a copycat religion, the Bible thing,
Oh.
and they threw
Sure.
some astro shit into it too. But
Okay.
I don't know. Do you have any astro theology stuff that links to Christianity specifically?
Yeah, man. To be
What we got?
impactful, I'll have to. Yeah, I'll see what I can collect. Because one or two examples off the top of my head it ain't gonna be too much, but no, I'll see what I can do, man.
Yeah,
I mean, I've never. Oh, go ahead.
I'd be interested trying to find information from Santos or anybody else, and all I hear is conjecture. And I'm very open-minded to have my mind changed. Now, I'm not denying astrotheology. I'm just challenging the claims that the Bible is an astrotheological text as a whole.
Yeah, I've never seen anything that was well linked to it or anything. It's definitely not that whole copycat religion, though. That's not. I haven't seen any evidence for that one either.
I guess it'll take me then. Someone's got to do it right, because I know what you mean. A lot of people just aren't good at making their case on a lot of subjects. That seems to be the case for a lot of people. But I've been planning on this for a while, so I'll let you know when I got something you can check out. Not even like a final version, but when I get some information together for like a rough draft. I've been wanting to like make this point as strongly as possible, because a lot of people talk about it, then it doesn't really get settled, and maybe that's because people don't come.
Yeah, I mean, it's kind of like my position on the Bible with flat Earth. I'll go toe to toe with anybody who thinks that the Bible is a flat Earth textbook, and I'm going to argue that it's not. So I'm just waiting for, like, I want to help the discussion to go along, because I came from a traditional Christian experience where astrotheology was not a part of our understanding of what the Bible was about. So if I hear someone who's open-minded and who changes their mind about truth saying, oh, the Bible is this, I'm like, oh, great. Like, what do you mean? And then when they don't have anything, I'm thinking, okay, well, I'm not jumping on board with you yet. So I'm still trying to figure it out. And either I'm going to debunk it in terms of just saying, look, the Bible's not doing what you say it's doing. Now, again, I do agree that astrotheology is one of the most, if not the most important fundamental aspect of our realm.
All right, man. Yeah. Yeah. It's something that's definitely not going to be settled right now. But I am I don't know. You can say passionate about like making this point as strongly as possible. And yeah, I should really get my shit together, make a presentation.
Ask you, like, if you wanted to take my feedback into consideration. My biggest thing is like, okay, let's say I want to start reading the Bible, and I'm going to start at Genesis 1 or whatever. In the beginning, God created the heavens and the earth. Like, how would you suggest that be decoded astrotheologically? Because most people are just going to read it straightforward as if it's a literal story.
Oh, right on, man. Well, I'm not saying the Bible is strict, like every sentence should be deciphered astrotheologically, right? I think there's probably about 7 different areas that it or 7 different like themes that it speaks on metaphorically, and sometimes in like double entendres when things line up that well, because I think a lot of systems were just like I don't know, either designed intentionally or retrofitted to sort of like be an associate, like you got a constellation that is about like it's the keel of the Argonaut ship, and it has this name, right? And the keel is like this. It's like the spine underneath the water that runs from the front of the ship to the back, right? It's like this like it's like the strongest backbone of a large boat, right? And there's a part of your esophagus where like either the air goes to one side of the lung or to the other, and it's like this really hard bony cartilage right there, and it has the same name as the constellation. And then I'm not making any sort of serious point here. I'm just saying. Good.
I hear what you're saying. Yeah, I hear what you're saying, and I do appreciate, you know, the correlation between the human physiology and then also the way they understood the dynamics of our realm. I
Yeah,
think it's
there's like a myth, there's like a story, there's a constellation, and there's an anatomy. And I think those are three really big ones where like the double entendres can really take place commonly, where it's like it's talking about the sky and the human body at the same time in a very poetic way. But one reason I think that it's hard to explain any sort of particular astrotheological like segment of the Bible is that you kind of gotta explain a ton about astrology in the first place for them to get it. It's like, how is this talking about
right,
the sky? Well, it's like, well, let me
right.
first walk you through the movement of the lights in the sky, section it off to the tropics and the ecliptic and the north and the south and the zodiac and then special
Then check this
asterisks
out,
like
right?
the Pleiades, and let me tell you their lore and their relationships and which ones are opposite from each other and which ones are fixed, cardinal, and mutable, and let me tell you the elements they're associated with, and then it's like, okay, if we can get through all that, then I can explain how the fiery bull that fucks the king's wife is really Taurus in April, who's ruled by Venus. And it's like, oh, well, like, you know, that's never going to happen over Discord. So it will take like a 5-hour video that I make to make a strong
Yeah,
case for this, you know?
yeah, and absolutely, I can appreciate everything that you're saying because I feel the same way in terms of when I'm making my presentations on refraction. It's just like, and I actually said this in one of my recent videos. I said, you know, the reason why my videos end up being so long is because the details are absolutely essential. If you're like just coming to my video for the first time and I just hit you with a shotgun blast, you're not like going to understand everything that went behind my explanation. So what you're saying is completely sensible. I totally get it.
Yeah, that's just how astrotheology is. I mean, you get it. It's just most people, even in the truth community, it's like even the ones interested in astrology, maybe they just haven't really even thought of like about asking certain questions like is there, I mean, you can learn the system, like you can memorize it. It's the same thing as the months, right? It's like this one's December and this one's October. And say it was back in the day when it really was like the 10th and 8th months, right? Let's just forget before it got messed up. You know, some people could just know the name. Like this, you know, this is the time of year called December. And then never once thought like, oh, December 10, it's the 10th month. Man, I never even thought of, you know? And it's like right in your face. And so, like, you can learn astrology in the same way. Like, oh, this is the bull, this is the fucking goat, you know? But like, why? Like, why is that the goat? Why is this one a girl? Why is there a scorpion, a bull, a lion, and a man as the fixed ones? You know, what is there any rhyme or reason to the arrangement? You know, why is this one fire? Like, you know, why does the sun rule Leo? You know, you can just know it does, right? As far as anyone will tell you. Who rules Leo? Oh, the sun rules Leo. Yeah, but why? Right? And so there, even the people who are into astrology don't like haven't really thought about uh trying to put themselves in the shoes of like someone who designed it, because no one really knows where it came from. That's one of the other funny parts about it. It's like, like who invented the zodiac? As far as we know, a lot of what we have goes back to the Babylonians, but we're like, okay, well, so did one guy in fucking Babylon just all of a sudden, you know, or is this part
Well,
of an
yeah,
older
but
tradition?
right. But the thing that place where I'm at right now is to think about every culture that expresses its astrotheology in their cultural stories. So that's where I see similarities that go across the extended plane, where you have these different cultures that understood astrotheology, understood the importance of the stars and the zodiac, even if they had different names and different stories. they all understood that it correlated to our human physiology, and their stories were expressions of how to understand that esoteric, hermeticist alchemy. And when you have that kind of attitude about it, it doesn't have this competition between religions. It rather has this artistic participation, and we're like, oh, that's how you understand the sun through Leo. Oh, that's interesting. This is the way we understand it. And then you both like, oh, that's sort of like, well, what if we put both of ours together? Maybe that'll be something even better. You know what I mean? It's like a a companionship rather than a competition and conflict, which is what I think the powers that be have intended.
Yeah, yeah, and then sometimes I think there's been organic or setup, I don't know, but there's been just what do you call it? Like irreconcilable differences in opinion between cultures, perhaps. Because just today I was listening to this video about a creation myth, and it had some sort of name. It was the first god that came out of chaos, and it was like Euripides, right? I'm like, okay, so that's Uranus, maybe an older version, or down the road, these people over here call it Euripides or something, right? Instead of Uranus, and it was a female, and I was like, okay, so then everything's already off, if you were to compare them, because now you got like a woman at the top of the pyramid, and then she's gonna have sons and then also like her partner was a snake, and then you can associate with like Lilith and the serpent and some Gnostic myths, and everyone's got a lot going on, at the same. And I don't know if it came down to just a matter of opinion back then, or someone got their hands on it and intentionally like turned things around from the original.
Yeah, I think that if we even go before the Babylonians, you've got the Egyptians. The Egyptians had their own astrotheological hieroglyphs, that were pretty explicit, and we just don't understand what the symbols mean, but they seem to have these symbols that represent the electromagnetic nature of our world, and how the human body and the human physiology can be expressed in depictions of human beings with animal heads, because that's their correspondence with the human body and the zodiac. And so they have goats and bulls and hawks, or raptor birds and whatnot. So I just think that, again, that these are just cultural expressions of spirituality, and in order to remove that narrative from us and our ability to participate in it, they just started mocking those cultural make-believe fairy tale stories that weren't scientific. And oh, look, we can tell you a story about this vast expanse of space out there with just nebulae upon nebula upon nebula upon nebula upon galaxy upon galaxy, and then all we have to do is show you pictures, and that's a hieroglyphic. And so instead of showing us writings on an Egyptian hieroglyph, you're just showing us fucking pictures from Hubble. Still a fucking hieroglyph.
Right, right. But have you? You're totally right. But have you noticed that how they've carried the torch? That it's just their turn, and they're doing the same thing. But I mean, even in like their naming schemes, you know what I mean? Like if you just think about like the associate, like the godly names our planets are given, and then the order they come in, like just the first three are exactly the same as Greek myth. Okay, who's up top? Uranus. Who's next? Saturn. Kronos. Who's next? Jupiter. Zeus. Right? They even keep like the father son uh, order correct. In their story about the heavens, right? And I mean, they play along, man. They absolutely play along. Uh, whether it's the spot on, I mean, it's pretty wild. Mars is a big one. Aries. Yeah, I won't go into that. I'm about to fix some pizza. I know it's not wise to like try to be convincing right now to anyone with doubts or even go into it with someone who like wants it to be true and has no doubts. It's just such a subject that you don't just get taught, just like on the spot, you know. And I've tried enough times that I know I just need to get a big collection together, really think about how I'm presenting it, and try my best really. If I because this is something I'd like other people to know about, and I know a lot of the people I learned from, I wouldn't recommend someone else going to those same sources to pull information from, like Santos and all the rest. It's like, you know what? I wish I could be better for anyone who's interested in that material, because I don't want you to have to sift through the haystack.
Well, yeah, I mean that's the way I try to teach too. I try to alleviate as much confusion with people by giving them all of the like the way that I changed my mind about the Bible. I'll just kind of say it this way. Let's say, for instance, I read 10 different scholars, and each scholar has something to contribute to the discussion, but neither scholar mentioned what the other 9 scholars mentioned. So they each had 1/10 of the truth. And so then, from my perspective, I just syncretized all 10 and said, look, these guys, I'm going to say what all of these guys are saying, but I'm going to say it at once. And that's the way I look at my responsibility, so that somebody doesn't have to do what you said. Like, I was just as confused watching Santos. Why would I send you to Santos if I was confused? Why would I do that?
Uh-huh. Here's a fun example you might not have heard before. There's some part of Revelation talking about Abaddon or Apollyon, and he's gonna open up the pit and unleash some woes. I guess those are like attacks or like I don't know. You know what I'm saying? Woes. He unleashes some woes, right?
Yeah.
Those are bad, and uh, and it's just uncanny that the description of this animal that's his like first woe he unleashes on the world in the end of days says like okay, there were I'm gonna unleash some horses from hell, but the horses actually have the bodies of insects. It's like, okay, well, I guess maybe we're at Scorpio there, right? And then it says okay, so we went from like okay, so it's like there's horses, but they're actually insects. It's like, okay, so side by side, that's Sagittarius and Scorpio, a bug and a horse. And then it says, and they had the face of a woman. And I was like, oh, okay, woman. Well, that's literally Virgo in order. So Scorpio, Sagittarius, Virgo, right in order. You got a horse, but it's really a bug or really a insect with the face of a woman. And then it says, and then it had the teeth of a lion in the next sentence. And I'm like, okay, well, that's just uncanny, right? Scorpio, Sagittarius, Virgo, Leo, like in perfect order in this description of what something that you're gonna take seriously. You really think there's bug, horse, woman-faced lion teeth creatures that are gonna come in the end of days, or do you think that's just literally astrotheological in nature, and you'd be crazy to not think that's the most likely decoding of that passage?
When you
When
say,
it,
correct me, but when you say that they're in the perfect order, are you saying that the way that they're listed in Revelation is the chronological or the order on the zodiac?
yeah, like I'm saying, like 5 o'clock, 4 o'clock, 3 o'clock, 1 o'clock, on a clock. Yeah,
Okay. So
and actually, that's my preferred. Go ahead.
yeah. So okay. So now we have those 4 zodiacal positions. What does it mean though that the beast has all 4 of those characteristics? What's your Like, what do you extrapolate that out to have in terms of like, what does it mean?
Well, that is the end of a day, like noon, and like I said before, it's like, okay, how much of an astrology lesson am I about to give to try to explain the details of one thing, and you know what I mean? But one thing I could say, just as a shallow answer to your question, is starting at uh, Leo. That is sunset and dusk, and then the first hours of night. So like, if it's talking about the end of days, as in like the end of reality's days, well, sounds perfect to pick the two above the western horizon, sunset, right? Pick the two above and the two below the sunset horizon as your monster that comes at the end of days. Well, those are the creatures of the zodiac that come at the end of literally every day.
So you're saying that the end of the day, two of the zodiac positions are below the horizon and two are above?
Yeah, here's one crucial element. There is in order for doing a decoding, there is a proper orientation, like clockwise, counterclockwise, and a rotational position needed to be understood to understand the zodiac. And when you Google, if you like Google image, Pinterest, whatever, right, some sort of image thing, or buy a book or whatever, like 19 times out of 20, they're gonna give you a version I disagree with. Like, it's going to be backwards and upside down, or one of the two. Like, they never give you the version that allows you to decode the symbolism. So,
Right, which would be intentional misdirection, right?
yeah, but it's also practical. So they have a very good excuse. It hides the symbolism, but it does make it practical for like learning more physical operations. Like stargazing, right? So what I'm talking about is the chart you're gonna get normally. The chart you're gonna get normally when you Google like or buy a book and it's on the cover or whatever, right? The chart you're gonna get normally is upside down and backwards, but that's because that's how the sky looks on a flat Earth, with your feet on the ground looking up. But where the symbolism can be understood is from the perspective of God looking down at the zodiac wheel from above it.
You know, have you come across a YouTube channel called Psy Cosmos?
By the way, I didn't hear that clearly, but I don't think so. Could you get closer to your mic or something?
So much the Bluetooth for the car.
Oh, you're in the car. Go ahead, man. Yeah, you're fine. Just continue.
Hey, I asked you if you heard of the YouTube channel called Psy Cosmos. It's PSYCOSMOS. Psy Cosmos.
No, I never heard of that. I like it though.
Yeah, check them out because they do a lot of really good fundamental basics on syncretism and astrotheology. But every once in a while, the main host will ask his TikTok group or whatever about flat Earth because he just wants to have an answer for how the zodiac works on a flat Earth. And even though I've directed him, numerous in different directions for him to come back, he never seems like he's actually interested in learning. But the content in terms of spirituality is really good.
Hey man, let me look him up right now. I know you said it was Psy, and then did Psy Cosmos.
Yeah, I'll get the link for you. Hold on real quick. I'll get it.
I think I found it. Psy Cosmos. Like Cosmos, like okay. Let's see.
Right,
He's
it
got.
has
Go ahead.
it has that winged Ankh.
Yeah, that's right. I found it.
The image, yeah. Okay, right. Yeah.
Thank you. Yeah, yeah. That's his thumbnail. Here's just a few. I don't know. Here's just a few things that come to the top of my mind. You know how? Okay, so again, it's like the orientation everyone gets is wrong. But if I could just describe it real quick, the orientation I like, it's looking at the zodiac, circle from God's eye view, from above it, and but then uh, another perspective is flat Earth cutting through the middle. So like if it was a vertical circle, the top half of the circle, if you sliced it like a burger bun, right? The top half of a circle would be spring and summer, and then the bottom half would be fall and winter, right? And the flat Earth relates to that in just like the day cycle, pretending the sun like went underground, right? The left side, so 9 o'clock of a 9 o'clock position on a clock, that would be sunrise, right? And then noon would be 12 o'clock, straight up, and then sunset would be 3 o'clock on the other side, right? And that'd be sunrise on the left of the circle, and you just make a cross, right? Just cross in a circle. Left side, sunrise, top, noon, right, sunset, and bottom, midnight. And then of course, like, the day is a cycle, the year is a cycle. And so, you know, and then the clock is a cycle too, and that complicates things because here's the thing, man. If you have a 24-hour clock, right? If you have a 24-hour clock and you point the 00 or the 24 sideways, then and you're on the equator, then the hands will literally point at the sun like forever. You know what I mean? Like like you can be indoors, know where the sun's at in the sky if you have a 24-hour clock, and the days and the days, or I'm sorry, not the 12, whatever time it would be for sunrise, and that depends on time of the year, of course. So I guess it'd be like 6 a.m. So if like 6 a.m. was like on the left side of your clock, then the hands would always point at the sun throughout the entire day, and they would rise from that from that left position associated with the eastern horizon. Anyway, the clock actually, this also seems kind of intentionally like confusing, the clocks they've given us and the orientation you normally see the zodiac drawn, and then also the month and the zodiacs being off by like 23 degrees. They've almost done everything they can to like make three things that should be aligned with each other like out of alignment. But you can still work with it very easily. Like once you understand the discrepancies, it's not hard at all to just work in the system they've given us. But I think they really all should have just been lined up from the beginning, though, instead of these 12-hour clocks and yada yada.
Well, let me ask you this question real quick because I've just started thinking about this again recently. Our time designations where we measure the day, minutes, and seconds is actually a
Oh, I was there,
nautical
man.
measurement.
I was there. I listened the entire day at work to you having this conversation. So I remember it very clearly.
What do you think?
But you can go ahead. You can start it. You can start us off though. Like just know that I heard everything. But if you want to start us off with a specific question.
Well, I mean, it's just going to be, expressing it again. I'm just trying to understand how we got from nautical measurements of degrees, minutes, and seconds to sidereal measurements of hours, minutes, and seconds, and why they changed it from degree to hour. That part I'm just still posing it just to have a kind of discussion. I still want to think it through because I don't have the answer, but there's got to be one.
Right. Okay. So. Well, the question you were asking the other day might have might have been putting one historically before the other, and I'm not sure you chose the right one. So I think probably time. I think the units were probably designed for time before they were designed for degrees of angles. But then again, it's like what culture begins designing degrees for measuring the sky or time without all already establishing geometric units? So
Yeah, I
yeah,
mean,
it's tough, man. Where do we even start with this to unravel like the connection?
yeah, I mean, I think your comment's absolutely fair. You know, it's a reasonable suggestion to say, okay, well, maybe it was originally always about measuring the measurement of the day, and then it just went over to the other direction towards nautical.
So
Either
here's the
way,
question.
yeah.
Oh, go ahead, man. Here's my
Well,
question. Why divide degrees into minutes? If a degree is I'm sorry, if a minute is a 60th of an hour, why divide degrees in and call it the same name? It is the same amount, right? It's a 60th of something. But the word minute doesn't necessarily mean a 60th of something. So why should a 60th of an hour and a 60th of a degree be called the same thing? You know what I'm saying?
well, but argue that same statement, if I understand you, we shouldn't have an equivocation between seconds and minutes either. So in nautical terms, there's degrees, minutes, and seconds. But when we measure the day, we should call it hours, something else, and something else. But we don't. There are two correspondences, minutes and seconds. Those are the same.
Right.
And proportionally, they're the same. It's a 60th both ways. 60 seconds, 60 minutes. The degree is a measurement of movement in the sky, but that's the same fucking thing as an hour. It's measuring something in the sky that's moved a degree or 15 degrees or whatever.
Well, the thing is, man, let's throw out 12-hour clocks, right? Just from now on, let's just refer to clocks as 24 hours. If you don't mind humoring me with
Yeah,
that,
we'll go.
okay?
I can do 13:30, 15:45. You know, I can go along with that. That's fine.
I don't know what.
Well, you know, so when you say
Was
24
it?
when you say 24 hours, right? You have to get up to 24. So 1 o'clock in the afternoon is 1300.
Oh, sure, man. Yeah.
That's all. That's all I meant.
Got you. Cool. So the thing is, man, minutes and seconds being 60 partitions or whatever, like units of something being divided into 60ths, that fits a lot better with 360 degrees than it does with 24 hours. So the oddball out here, you know what I mean? Like the thing that is kind of sticks out is like, well, who the fuck, right? Like minutes, seconds, cool, 60ths of whatever. But the weird thing is why divide the day into 24 sections? And because 360 degrees and even 360 days practically, you could live that way for a while, treating the year's 360 days. You could live that way for a while without your holidays being too off or whatever, and then you could reset it every once in a while. But like it's fine to think about the year, the degrees 360, and then that's evenly divisible by 60, the minutes and seconds, and even months, right? Would just in pairs of 2 or whatever, like 30-day segments, right? It's only the clock that stands out. Like, okay, 24. I mean, where's even the reasoning behind that? Like 24. See, well, here's the no 12 and 24 aren't aren't factors of 60. Like they're not even divisible of each other, And it's strange. Why 20? Does anyone know the answer to that? Why 24 hours?
Yeah, I'm trying to.
No, I don't get that at all. Why?
Can you not hear me?
No, you cut out. No, you cut out.
Okay, sorry. Am I back yet? Am I back?
Yeah, pretty well. I can hear you pretty well.
Okay, I'm gonna say that I think that the 24 hours has to do with the rotation of the Earth and the measurement of the alleged circumference and how fast it has to turn within a certain time period. That's where the 24 comes from.
Okay, so like the alleged 24,000 mile circumference.
Right. And then
That seems so late though. Like
I know, right. Exactly. That's part of the narrative that, it's just you and I. I mean, that's one of the earliest things I remember about learning about the solar system was the rotation of the Earth happens in one period. Half of it's 12, half of it's 12. That's 24.
Right.
We know the Earth is 24,000 miles in circumference. That means that the Earth is spinning 1,000 or rotating 1,000 miles an hour at the equator. I mean, it's all just mathematical. So yeah, it's recent. But I think that it had to be back engineered into it. And I think they removed the degrees because removing the degrees from our understanding of the sky, I think would have possibly been more evident to us that what they were telling us wasn't going to match up with reality. I think it would have been.
Let me tell you this, man. I see your point, and that's incredibly plausible, but also speculative still at this point.
Sure. Yeah.
But what I can tell you is that the Egyptians are said to have divided their full day cycle, the entire sunrise to back to sunrise, complete cycle of a day into deacons, which were 36 10-degree segments.
Okay, so that's 360. Okay.
Yeah. And not that I encourage anyone to get lost down the rabbit hole of archaics, because I don't really approve of the person or even most of his information. I don't know. I keep an eye on him. I get for some reason. Maybe I could get some of that, but he's got this whole narrative I've heard him speak about every ancient culture using like a 60 and 360 base system for everything they did.
Right. Well, I think that would go back to what we were talking before, that the ancient cultures understood and knew the zodiac had a relationship to the realm, which had a relationship to the human body. So that was, to me, they're just introducing something that's going to break us away from that correspondence, and we're not going to understand who we are or where we are.
Yeah, I think one of the best things we could do would to just kind of reinvent the wheel here, and whether it's getting back to our roots, or, I mean, I'd like to have a child soon, and I'd like to, regardless of what else I have to teach him or her to like operate in the world and get along and communicate with everybody along their standards of communication and conventions and stuff. I would like to equip him or her with just a more natural and logical, straightforward system. Whether it's like a calendar, a clock, a celestial, just everything like that, because it's such a mess we're thrown into. it's nonsense.
Yeah.
The months aren't correct. The fucking yeah, it's all crazy, and that sparks a lot of conversation. Like just the other day, like one of my close friends here, illegal on Discord, he got hoodwinked by some person saying that they know the perfect calendar system, and there's tons of con artists out there fooling people that they have some sort of better version because everyone sort of already realizes the one we have is broken, and so when someone comes along and says, "Oh, this is the way we should be doing this, is the way the ancients were doing it," it's like, well, there's I don't know, there's just a vulnerability and a desire that a lot of truther channels take advantage of people. Like, oh, you got something broken? Well, let me fix it for you. You know, and it's like, no, the one he offers is like, no, we shouldn't just follow the moon. You know, we should like there's something better, and I don't see anyone uh, propagating it out here. I think maybe there's a little bit of work to be done. I think we all need to put our heads together and come up with the best system we could possibly imagine, and it might take a little bit of balance work going on. I know that I know there's like a Chinese calendar system, a Hebrew, a Christian, a conventional American Gregorian, Julian, whatever, and you know they're all lacking something. And then of course there's like sidereal and tropical, and but then also you got to learn these things to stay in touch with how people were operating, so you can understand what they were saying. It's tough, man. We're in a pickle. Like a lot of astrology people, they're like, fuck tropical. If you really want to do astrology correctly, you got to do sidereal Hindu, uh, real proportion astrology. And it's like, I feel you. That's more accurate to the sky it today in and of itself, but you're gonna miss out on all the symbolism. If you don't do if you don't learn the tropical system, you're gonna miss out on all of the references and like codes that people encode into things. We've been given a tall order as truthers, man, and it seems kind of never ending. Maybe the hermits got it right. Fuck everyone. I'm gonna go live in a cave in the mountains and grow beets and radishes and have radish stew every night. Because all this
Well,
stuff that we're involved in, it's like, god damn.
I mean, even talking about that, you know, you don't have to eat every day, you know,
Well, you don't have to.
and your body can acclimate to it and be very comfortable with it. And there, you know, I had a buddy of mine who went on a 40-day water fast. He had no problems whatsoever.
That's incredible.
You're setting the time.
Hey man, did did you ever come across any information about like toroids and hyperboloids, whether it be from like Ken Wheeler or Santos or some other place?
Watching more of Lindsay Harris, who does the Tomb of Illumination. He does a lot of spiritual, electromagnetic, toroidal applications to the flat Earth system. He's much more, for me, he's much more graspable and understandable than Ken Wheeler is. But he does talk about Ken Wheeler a lot in favor of Ken's insights and research. But I personally haven't spent a lot of time outside of just watching generic videos, because my field that I'm looking into has to do with mirage and refraction for long distance observations.
Right, the plain truth on YouTube, right?
Yeah.
Yeah, I watch your shit, man.
I've got something really special from today. I was out on Lake Michigan. I think that I could say that I've seen farther today than I've ever seen in my life, and it was pretty amazing.
Oh, holy cow.
Yeah,
Well,
I'm gonna try to make it as palatable as possible, but you almost have to watch the entire thing. It's almost like you have to have the entire slow build, because I was watching a sailboat, and when I first started filming the sailboat, you could clearly see the full sailboat with the hull and whatnot out in the distance on the horizon, and it just kept going farther and farther and farther and farther away, and it just kept going, and it kept staying there right in front of you the whole time. It was just crazy amazing.
is that have you uploaded that footage?
No, I just shot it today, and I've been traveling all day, so it's not going to be. I'm not going to have it ready by the weekend, I don't think.
Yeah, okay. Well, I'll see it when it comes out.
Yeah.
Well, I only brought up the toroidal hyperboloidal stuff because that subject, I don't know, I'm pretty passionate about it, and I saw a video today. It's always, I don't know, it's always really good when you're like into a subject that you think is extremely profound and like universal in its application, and you're not even thinking about it. You're just, you're just like, I don't know, exploring some fun other thing, and then it just pops up, and like you notice it, but it wasn't like the person who even uploaded this thing, like they don't even know what they just revealed. They're just like having fun, but like you see something, you're like, oh wow, like it's just very reaffirming. And there's this fun video that I came across just about a billiard ball bouncing around inside of an oval. And I don't know, I just really enjoy these simple things. I'm gonna post it and tag you in it. It's just a fun video, and it's not I mean, it's not even like the most super special deep thing, but it's just fun, man. And I just feel like sharing it with whoever wants to watch it.
Yeah, post it. I'll watch it when I'm done driving.
Right on. I'm surprised I don't know this, but there's probably a reason why you're driving a lot, right? You're a trucker or something like that?
Used to be, but right now I was visiting a friend in Milwaukee, so I'm just driving back to Maryland now.
Oh, hell yeah, man. Let's see. No, wrong save playlist. I know where to find it. I'm gonna post it real soon. Okay, so you're driving right now. Be careful. And I guess you can't watch any videos right now either. But when you take a break.
I'll be done driving in like 15 minutes.
Oh, righteous, dude, righteous. Okay, well here's a cool video by a cool channel I just discovered, and I'll tag you in it. And it's just like you see the like, I don't know. Once you're like into this subject, you just start seeing the toroid and the hyperboloid everywhere you look. It's just one of those things. And this was one of the funner examples that I came across in the past 2 days. It's just a ball bouncing around inside of an oval, and I won't spoil it for you, but it's a fun video. Good music, good presentation, and he has no idea what he's revealing. He just thinks, oh, here's some fun reflective properties of an oval. He just thinks it's interesting. He likes doing little like physics simulations. And it's like, you don't. I'm like, he doesn't even know I'm about to use this as like a main example to make a big point in a video of mine. I'm gonna rip his video off and download it, and absolutely use it as just like a hardcore piece of evidence towards a much greater point. It's like, thank you for your service, because I don't know how to make these sorts of animations, but I'm glad he does, and I'm glad I came across it, because it's brilliant. The same with this dude who was like, here's how you build a fire starter out in the wild with only a piece of rope. He's like, all right, you tie 2 sticks together, one horizontal, one vertical. You twist the twine from the 2 ends around the vertical stick, and then you just pump it up and down. And oh, look at that! You pump one thing and it spins the other. And it's like, yeah, because there's only 2 types of motion. There's only 2 modalities of geometry. There's linear and there's curved, and that's like lines, right? I mean, lines can either be straight or curved. There's no other option. Going once, going I'll give it a 10 count. Is there anything that a line can be besides curved or straight?
Yeah, I would say you're right. Yeah.
Right? It's simple, but it's profound. It's like there really are only two options. See, I call myself fundamental, and one of the things I love most is finding things that come in specific amounts, like the 5 platonic solids. That's it. There's 5. There was never, will never be any more or less. I absolutely adore things that come in specific sets of numbers where there's no arguing it. That's just a fundamental truth about this particular thing. It's like, yeah, there's 2 options of lines, and they're like modality. There's 5 platonic solids. You got to have 3 sides to a polygon. That's the minimum. Nothing smaller than a triangle. And these things, they just apply to so much in the universe. But the toroid and the hyperboloid, it's just another one of those things, because that's just like 3 dimension. That's just like, well, you take it a step further from like curved and straight, and you involve it in like motion and 3D space, and or I could ask anyone, like if I give you a lump of dough, Play-Doh, bread dough, what, it doesn't matter, some sort of putty. There's only 2. Like I can just say this, and I don't know. It feels like powerful. It feels like a powerful position to just be able to claim this about the universe or a material. Because what material could do more things than any other? A free flowing solid material. It can do whatever it wants. But really, there's only 2 things you can do. There's only two things you can do to Plato. It's like, what do you mean? I can do all sorts. Yeah, but fundamentally, there's only 2 things.
Is that?
You can turn it, and you can okay. So you know how you can turn like left or right. So there's kind of 2 types of turns, and so when the other thing has 2 options, that kind of just keep in mind what I said about turning left and right. You can expand and contract, or in other sense, separate and combine. So you can turn, and just the word that I just summarized, like outward, inward, or further, closer, like that. I call it pulse. So you can turn something and you can pulse something, and those are the only 2 options for Plato. You can take apart, rip it off. Oh, okay, so you separate it. That's the outward. That's the expansion. And then, I mean, what's your other option? Keep on going further and further, or come back together. There's nothing you can do besides that. Or you can twist it, you can spin it, you can stretch it, this way, that way. There's nothing you can do to Plato besides turning and pulsing. But I use that word pulse in a very like expansive way in its definition.
Right.
You could stick a straw into the middle of it and like blow it into a bubble, right? But that would be like pulse. You can expand it, you can contract it, you can separate it, you can combine it. To me, that's all the same thing. That's all pulsing. And then you can twist it, you can spin it. I mean, same thing. That's literally it. There's only 2. There's you can. In fact, that's the only 2 motions anything ever does. You think about a car, right? Okay, the steering wheel turns, the pistons pulse, the tires turn, the axles tilt. That's turning and pulsing. I mean, there's literally only 2 motions that anything has ever done: pulsing and turning. And the toroid and the hyperboloid are they're like, I don't know, they're like the mascots for that in 3-dimensional space.
Isn't there one of those old kind of like gimmick toys? It's like a top, and you you can you can
There you go. Yep. No, I got
it,
you, man. It has a little lever on
yeah,
top that you like. Yeah. Yeah,
yeah.
exactly. Yeah, and you think about it like a screw, a screw and a bolt, right? Or a
Right.
nugget or whatever you want to call it, right?
Right.
One is the hyperboloid that fits through the center of the toroid, the ring, the donut, the bolt. In fact, even driving something into wood, right? You can either like thrust it like a nail, or you can turn it like a screw. This is literally how this is the geometry of all motion. If motion is involved, it's either pulsing or turning.
Yeah, that's pretty good.
It's crazy, man. It's deep as fuck. That's why when people there's all sorts of people talking about, oh, the toroid this, the toroid that, right? Well, yeah, because it's so universal. It's such a deep fundamental truth. Well, it is, yeah, because if motion is involved, there's only two options. This understanding applies to literally everything. And so when it comes to a subatomic level and atomic level, it's not doing anything other than turning or pulsing. Probably both. Now, what's doing what? How do you want to divvy it up and name the different components or whatever? Well, you can be rest assured there's only two motions that could ever be taking place, all the way from the top to the bottom. Everything works the same way. There's only two ways anything can move. And then I guess like a spiral would be like a combination, like getting contracting and spinning, right?
Yeah.
Are spirals one of the most profound things in nature? Of course they are. Every fucking fruit's design. Every flower, every plant, every tree, every fruit. Yeah, it's all tor and bull. Even okay, so why is a bulldozer called a bulldozer? Is it because it has something to do with the animal bull? Well, it almost seemed like that because it's like strong and tough or whatever. But really, the bull and bulldozer just the root word bull just means like thrust, to like push, right? Bull means thrust. That's why you call it like a
Bull market.
ballistic. Well, that's why you call it like I don't understand that comparison. I know there's like a bear and a bull, but but even like ballistic missiles, right? Or bowling,
Well,
stuff like that.
I'll explain the bull market, bear market. The bull market is when the bull thrusts its head up, so it's a positive, and the bull market is up. Then the bear swipes his paws down to kill his prey. So it's the market is down. So that's the concept.
Okay, so even there, you can connect it. Bull means to thrust, and and so if bull means thrust, I'm sure another truth or thing that just a lot of people aren't asking themselves, like why all these words, all these etymologies, right? Well, the key that everyone needs to be given is an understanding of phonetics. When it comes to consonants, when it comes to consonants, there's voiced and voiceless pairs, and P and B are called like the bilabial consonants. And how many times I've gone through this?
I remember talking to you about this like a couple of years ago. It was a good discussion.
That's a great one, man. And so like B and P, they're called the same place of articulation, and like the place of articulation when you're speaking is what part of your mouth shuts and squeezes. in order to make your sound. And so it's like, okay, so if bull means to thrust, well, we're gonna need to invent a word for the opposite. Okay, so if you're pushing something away and we call it bull, well, what do we call it when you do the opposite? It's like, oh, we'll just flip that B upside down. And then here's the thing: even the design of the alphabetical symbols reflect like this association with this relation with each other. Yeah. Well, what's the opposite of bull? Oh, it's pull. You know, and that's just another one of those secrets in plain sight. And phonetics, I mean, that a big reason why there's all this wordplay and these similar words and like these codes. There's a key to understand it all. There's a key you can be given that just allows you to be like waiting in line at the DMV and just like spontaneous realizations about words just come to you. Because we all of us know like fucking 15,000 words, and just, once you understand the like the 9 pairs of voiced and voiceless consonants like P, B, S, Z, J, Y, T, D, G, K, and the rest, then shit shit will just like pop into your head like all the time. Like, oh wow, I never realized pull and bull, you know, or like F and V. It's like, huh, why does wolf become wolves with a V?
Right.
Why does knife become knives with a V? Why does leaf become leaves with a V? Why does everyone always turn the F into a V? Well, it's because consonants come in pairs. F and V, T and D, G and K, S and Z. And when you think about it, it even shows you in the design of the letters. M and N. When the F and V don't really show you in the design of the symbol itself. But it's a simple key that anyone can learn in about like 5 minutes, and it'll really like unlock so many doors. Like, oh, I see. And then it'll just be with you for the rest of your life as like a really handy tool. And that's just one of those things. Like, you understand phonetics, you understand astrology. There's just going to be you understand a little bit of geometry, and these are just like keys that will just start unlocking so many doors. And it's like the more you bring in, the more you can take out. And it's like when you bring these things along with yourself in your life, the more you get out of almost every minute of your waking life. Like if you understand astrology, it's like, oh, okay, I read this book, I watched this movie, this television show. It's like, oh, or you you just see the little secrets in plain sight,
I think
that.
it's funny.
Go ahead.
I think it's funny that you mentioned the movie Waking Life because I was going to ask you if you've seen that movie. Have you heard of that movie, Waking Life?
No, I haven't.
Oh man, you got to check it out. So, I rented the movie and then I ended up buying it because it was so good, and I've watched it dozens of times in the last 6 months. I
Oh,
highly,
shit.
highly recommend it. You will absolutely eat that movie up. It's so good.
Okay, I just wrote it down. I'll check it out, man.
All right, well, I got to my stuff. I'm going to check out.
I'm about to have dinner in about
I'll talk to you later,
5
Fundy.
minutes. It'll be about 5 minutes, but I'll see you later, man. If you're heading out.
Hello? Anyone home?
Hello. Is anybody here? Hello?
Check, anybody home? Hello, check.
Hello.
Greetings.
I just wanted to chime in on this water level thing, or water tube level.
All right.
So what is the deal with that thing? So he's got two tubes next to each other?
No, it's one tube strung up like a U shape, so it's just one tube and it's full of red water. It's just water with food coloring, so you can see it in the. So the height of the water at both ends is going to be the same elevation because it's just one tube.
Yeah, I know. The first time I seen one of these was about 20 years ago. But it was like a hose. It was a clear hose, and for some reason I was just thinking about this today because it was some of my old high school buddies and their dad. They showed me how this worked, and then now I see this, so I just like, oh, holy cow! Gotta this is kind of reminding me of that whole thing with when I was first shown um, a clear hose full of water to level off 2 points. So that's what this water tube is doing.
Basically, yeah. It's like 16 feet long, and the ends are about 10 feet apart, roughly.
Okay, let's take a look at that again. But what it's being used for is to examine something that's how many miles away?
21.2.
21.2.
Give or
So
take.
21 miles away, and it's being so we're observing so the tube level is in the screen from right to left.
Correct. In the
And
cartoon
then,
or in the photo?
oh no, in the I thought the video.
Which video?
Let's see. In the voice the voice text.
Is the title well, let's see. Is what
Maybe I have to go back a little bit. Maybe I'm a little.
Is that at 37 after? There's one video that shows the water tube level from the side just to show what it's like. And there's another video
okay.
that shows
I
sighting
see.
along the water tube level. That's the one I posted, was the sighting along the water tube level. And then the diagram shows the side view, but it's obviously a cartoon type style.
Okay.
I gotta run outside and grab something. I'll be right back.
Yeah.
I'm back.
Mm. That's what as I'm watching this video. Yeah. So what's yeah, the water levels are going up and down.
Are you watching the video with the sound turned on?
Oh yeah, I should turn it off. Yeah.
Yeah, the sound it's fully narrated, so if you have the sound on, you'll know what's going on.
Oh no, I was. So, I mean the. Okay, is this your video?
Yes.
Yeah, it sounds like your voice. Okay. I mean, shoots. We're right here. You can tell me what's going on.
Well, there's not much to say. I set up a water tube level and I got back about 95 feet or so roughly from it, behind it, lined the camera up to it. And then
Oh, I see. So there's one in front of the other. There's one closer to there's one closer to the shore and there's one away from the shore.
Correct.
Is that what I'm seeing? Oh, okay.
Yeah.
But in order to show the difference, you just can't be right in line.
Right.
with
If
the
you're
two.
right in line, you would only see the near one.
Yeah. And so depending on up and down. Okay. Oh, there's there, yeah, and then you zoom back. Okay, that's what I'm watching right now. Like coming
Right.
away. Yeah.
Right. Because one of the questions people raise is, does zooming in or out change whether you can see over an obstruction?
Okay. Yeah, because one of the things I thought, like, when I first started watching this was like you run a hose all the way across the water.
No. There'd be no point in that. It would be just the same as the water itself.
Exactly. Yeah. Exactly. It would be the same as the water itself. And but that's I think that's why it's like I think a lot of where's the curve uh points come from the water, right? You're going to build a water level that's only 20 feet apart, or you're going to drag a hose all the way across the lake and you get the same thing.
What was the question?
It wasn't much of a question, but more of a statement that so if dragging a hose all the way across the lake or the body of water in between where your tube your water level tube is set up, you said it would be the same as the lake.
Right. If you had a 20-mile long water tube and you had one end, over there and one end over here, and the water surface in one end was say 10 feet above the ocean, the water surface in the other end would also be 10 foot above the ocean.
Right. Yeah, it would be. Yeah. Because when I was first shown the this my my friend's dad showed me this but he was only doing like a doorway or like some posts on a awning, and he had a a clear hose filled with water, and if he wanted to like make the post across from the other post at the same height, then he just lined it up using the water tube, the tube level. And so that's what I was thinking was, I thought maybe what was happening when I was watching your video was that there was a tube that went, or a hose that went all the way across the the body of water, and then you said that um you just might as well just use the body of water, 10 feet above the water, 10 feet on the other side, or whatever. Masaki. Oh, what'd you need?
Maybe got it. Like
Oh shoot. It's outside.
can you just make them up?
That's apple juice.
Apple juice.
No, it's good apple juice.
Make them
If Dada drinks it, will you drink it?
No. So this one I knew the cup.
Oh. Here. How about this one?
Yes.
This one. Okay, let's go. Come on, let's go. You sure? Where? This way. Where? Oh, there's the tractor. But where's the juice cup? I think I know where the juice cup is. I think it's in the backyard. This way. Where? Yeah, but where's the juice cup? Where's the moon? Say, okay, let's go find the juice cup. It is not. I don't see it anywhere. Oh, I think it's in the backyard. Let's see it. Let's go, guys. Go quick. Come on. Oh, crystals. Crystals. Oh, I don't see. I don't see. Oh, I think I know where it is. Here it is. But it's empty. Look. It's right. It's right here. Look, I found. Oh, that is a big shishi. Oh, Paul, put your chonies on.
That's Noni pen.
Yes. So you have to put shorts on too. Okay. You got it? No need? On the slide, it's too dark. Oh, hi, Crystal. One more time? Go ahead. Go make shishi. I go put your chonies on. Yes.
Oh, it's hot on this.
It's hot.
This hot. This hot. Fire right here.
Big fire.
Let's make your fire. Oh.
No little fire. Tomorrow I'll make big fire.
Oh.
I swear we'll make big fire. Come on, Dennis. Baby chickens. Okay, come here. Hey, put your chonies on.
No.
What happened to your juice cup? I put your chonies. Exercise. You're gonna
Do perception.
No, come on.
Yeah.
We'll bring that to mama if you. Oh, okay. Come on, this one. Okay. Take your chonies downstairs. What?
Daddy, we
All right, okay. Lunga, 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 lunga. 21.
あれあったのそこか。ね。もしかして友人
They're right here. No, this is doing.
Stop smelling.
Oh, soup. My guy doesn't want to do soup anymore. Soup.
What do you think of that water tube demonstration, Strange Days?
It was on as background noise.
Are you on for background noise, or are we on for background noise? Oops.